Thank you for joining us. Our program will start in approximately 5 minutes. Thank you for joining us. Please take your seats. Our program will begin in just a few moments.
Hello.
Morning.
Good morning, everyone.
Good morning.
Did y'all have a good night last night? Sounds like a few people had too good a night last night.
It was great.
Hello.
So yeah, here we go again. Another day of talks covering performance, dev tools, progressive apps. Someone might even mention service worker.
I'm definitely going to, which is a massive spoiler.
Once again, we have breakout sessions at lunchtime and at the end of the day. I'm going to be doing one of those. So if you want to witness a man who's been awake since 3 a.m. try to explain something deep and technical, join me for that. That should be fun. And be sure to check out the device wall and the code labs, and they're just outside there.
And don't forget to drop by the Slack channel and tweet at ChromiumDev with your thoughts. The hashtag remains the same, hashtag ChromeDevSummit.
Once again, our code of conduct is up on the website, and it's printed out around the venue. You've probably seen it already. But yeah, same as yesterday, our goals are to learn from each other and have a laugh in the process, right? And if someone or something is getting in the way of that, be it here at the venue or on the Slack channel if you're watching remotely, please tell us about it so we can sort it out.
The staff are in the grey t-shirts again, but you can also message ChromiumDev on Twitter or message Paul or one of the other DA's developer advocates on Slack.
At the end of the day, we're going to have a leadership panel where we put your questions to the Chrome leadership team.
I love that bit. Every year, I love it. It's one of my favorite bits.
Well, and there's still time to get questions in as well.
Yes.
And you can do them anonymously too. Details on that are on the website.
Yes, now, but first, for the next 3 glorious hours, this stage is going to be riddled with polls.
Get ready for the apocalypse.
Oh, yes. It's going to go well, this.
First up, or in pole position, a man who has been shaking up the DevTools world, giving us all polls for thought.
Yeah. Yeah, sorry for the puns. You'd have thought we'd have learned from yesterday, but apparently not. No.
You mean we apologize for the puns?
No, we do. No.
Here to show us all Paul the new things are in DevTools.
Stop it.
It's Paul Backhouse.
Hey!
Thanks. Good morning, everybody. Let me just get my clicker. Let's talk about DevTools and what the team has been up to in the last couple of months. So first, I'm Paul Backhouse, one of the Pauls. And I'm the advocacy lead for DevTools. So I give my voice to DevTools, collect input and feedback, and tweet and do whatever else, and be on the stage. And I also do the outreach for AMP, the Accelerated Mobile Pages project. Now, we've been talking about performance a lot in the last couple of years. We've done a lot of performance improvements, and we're going to continue to do so. Lots of the front-end up story, really, to improve the speed of your pages. But today, this talk is not about performance. This talk is about something we discovered makes more sense in this context, which is actually building websites. This is a thing that people do with DevTools as well, actually building websites. It turns out one of the audiences that does that in particular are designers. So designers, we didn't really focus on designers when building the DevTools before. But it makes a lot of sense because they've been doing more and more CSS. And a couple of surveys that we've seen recently showed us that most of the design work, most of the prototype work often happens in DevTools, which was surprising to us. Because we thought that most web developers would do changes in HTML, et cetera, but not so much the designers. But it's actually a really powerful tool. But it mostly stays in the elements panel, and we want to make sure that the DevTools work for them, work for that crowd. So what we've also discovered is that a lot of the UI was really cluttered if you look at it from a design perspective. We thought we could do better than that. And so the first thing I want to show you is a couple of improvements that we did in the UI in DevTools. So 3 things I'm going to talk about. First is how we're making DevTools a joy to use, how we're making it really simple and easier. The second one is how authoring becomes a really big story in DevTools and how we make that fast, intuitive, and really fun. And then finally, something for the debuggers and JavaScript developers with us is more JavaScript control, more tools to make your debugging flow much better. So let's start with how we're improving the UI. So if you do if you do work on a product that grows and grows and grows, and you put in more stuff and more stuff and more stuff, DevTools are quite complex nowadays with a lot of magic, lots of good tools in it. But sometimes a user interface can become a UH, which stands for user interface. And we don't really want that, right? That's not what we're trying to do. So in order to prevent that, we hired Max. Max is our new full-time designer. For the first time in history, we have a full-time designer working on DevTools and improving everything around DevTools. And you can also already see the fruits of his labor in many different places. So let's go through some of them. Well, first, let me show you how far we've got. So we have 2009 on one side. We have 2015 on the other. And there's a dramatic amount of small improvements, small but powerful improvements that went into DevTools. So a few of them. Well, one thing that is new, you might have seen, is the new main menu. We don't clutter the UI that much anymore, but we have docking now in the new main menu, much easier accessible than before, and much simpler than having a long press. We have all the important tools that you only use sometimes, like inspect devices, network conditions, sensors, and settings and help, all in there for you to access whenever you need them. And then we also made it possible to reorder tabs. That's been a feature that's been long requested, and we finally got it. Not only that, but we also reordered the tabs by default. So we brought them into the position they make sense, where they use the most. We discovered that the console tab is on second place in usage after the element panel. So we put it in its second place, which just made a lot of sense. And then we also added an overflow menu to the area, the drawer, where a lot of the overflow content sits in. So for instance, if you do a global search, we put that into the drawer next to the console because as a closable tab, because it's not something you want to have around all the time. Now, we put more and more stuff into it. We made the story more consistent, and we added an overflow menu to always come back to what you wanted. And then we also improved the context menus in a few places. For instance, this is the new context menu when you right-click on the DOM panel elements. And it gives you a lot easier control over what you want to do. Copy outer HTML, for instance, something we didn't have before. Just copy the node. You don't need to do any special magic for that anymore. You can immediately trigger the active state or focus state right from there. We still have the other place in the style panel, but this is a lot simpler than it was before. So we get that even with those improvements, and we continue doing them, there are still times where you will be completely lost, right? There are times where you will think, OK, where did that toggle go? What just happened? And that's OK, right? We're here to help. And if you've seen the main menu already, you've seen that there's a new help icon. And that help icon leads to our new homepage. That new homepage is not just a facelift to the old homepage, but in fact, it is heavily rewritten so it becomes action-oriented. So a lot of the guides and tutorials that you find on that site are specific to a problem. You're trying to solve a performance problem? Sure, here's a couple of guides for that. So that's really how we build up that page. And then also, if all hope is lost, if you really can't find anything and you don't want to dig through the page, you can still always get in touch with us. We started tweeting a few months ago on the Chrome DevTools handle. And it's becoming really successful because people realize that we actually answer and reply. And we also tweet a lot about the latest achievements in Canary and what the team is up to as soon as they come in there. So that's that. That's some of the UI improvements recently. Those were just over the last couple of weeks, but there's been a tremendous amount of UI improvements in the last couple of months. Some of them you probably don't notice every day because, well, a lot of it is changing every day. But there's quite something, quite a focus for the team. So let's move on with how we're making authoring fast, intuitive, and fun. Now, here's a page I've been working on recently in my spare time. And I want to improve it. I actually want to create a dark version of it. I thought it would be nice to play with the ambient light sensor and make a dark version. So what do I do? Well, I have to pick colors. And I don't know about you, but I'm not terribly confident picking colors out of the blue. Maybe some designers are that are very familiar with color theory, but I'm not. So usually what I do is I go to a website, I search for a palette that looks nice. And I don't really often find what I'm looking for. I mean, or I go to some color wheel or whatever. But I thought we could do better than that. So what we did here is, first of all, we made it really, really easy to add in color if there wasn't one already. So you don't have to type in background color red and then click on the color picker anymore to open it. We added 2 buttons that immediately add foreground and background color. And now you're seeing the new color picker that we've worked on. And what this new color picker includes is not just a way to pick random colors, well, because that's not what I wanted. But instead, for instance, it also allows us to pick something from the page. So hey, I see some color that I found in the header that I really like. OK, I pick it right there. This was a feature that a lot of people didn't discover because we didn't have that little eyedropper icon before. Ironically, I mean, it was always on, but people didn't discover it because it was always on, because they didn't click on it first. So that's one way. But then you can also do so with the new color palettes. We've added the material design color palette through the color picker to allow you to choose from colors that designers have chosen. And I'm really glad that some designers that spend lots of weeks going through every little color and tweak it, spend more time on that than I do, make that choice for me. Now, we didn't just ship with the base colors that you see here. Those base colors are nice, but they don't work in every context. In the case of my background on the page, they don't work. I want to have a very light, a very dark color. So instead, we also ship with the shades. And the shades come up if you long press on one of the colors. So you can long press on the colors and pick whatever you need to. In this case, this color, I think, works really well for me. So finally, I obviously also have to change a few other colors, for instance, the header here. And to do that, we made it really easy to discover what I need to change. So if I now hover over the selector rule in the style panel, all of the colors, all of the other elements that would apply that selector are actually highlighted. And now I can choose the color with confidence that I'm picking the right selector. OK, I think this works again. And finally, the text color, right? Before, I actually just had to, for contrast reasons, I just had to measure what I thought was right. But now we have this new line that you're seeing on the color picker. It's still an experiment. It's coming up relatively soon. But this new line is a color contrast line and gives you an idea what contrast works best for accessibility reasons. This is really powerful because I before had no idea what color is a good color when my eyesight isn't that strong. So this is a really great way to make this happen. So that's color. Let's move in to mobile. So I was in that situation quite a lot, right? I've been in that before. So you basically, you work on a product, you work on it for many, many months. Obviously, you develop on desktop computers because they have your build system, whatever, and it makes it really easy. But then your boss, one day before launch, asks you if you tested on mobile. And you're like, maybe. Well, we did an improvement here last year, which is the new device mode. Device mode comes up if you click at the icon next to the inspect element icon, and it brings up mobile emulation. So from here, you have a UI that you can select the device from, select network, throttling, and emulate a lot of the characteristics of a mobile phone. So that was a good start. We also had media queries in there, zoom, a lot of interesting things. That was a good start, but there was one thing that I just couldn't pinpoint that was wrong with it. And we finally could pinpoint it, which is it's sort of backwards. Why are we starting with a desktop website when all the traffic comes from mobile in the first place, when most people discover your page on mobile first, and then maybe use the desktop afterwards? Isn't that kind of backwards? Shouldn't we be building mobile first and then go up? Well, it turns out that's not a new thing. In the responsive design world, that's been the thing that they've been preaching for a long time. Just focus on the mobile website first, use progressive enhancement, and then scale up and use media queries to actually build the desktop side out. That's not a new story, but somehow our workflow was stuck in the past. The Chrome DevTools we're still heavily focused on desktop and had an opt-in mode if you wanted to debug for mobile. Now, I'm very pleased to announce that this is changing. We are building a new device mode for a new mobile-first world. So, well, I mean, you could freak out now, right? And like, are you freaking kidding me? Are you shoving that UI in my face and have it always on? Is that really what you're doing? Because then I'm going to leave. OK, so this is not what we're doing, right? That would be a supreme amount of trolling. And we're not going there. Now, instead, we dramatically simplified the story. What we have here is a new device mode. That's on my own page right now. But as you can see, it's just one line that extends to the main menu. And it gives you control over responsive design. We just started on desktop. Now we're in responsive mode. But we can also emulate a certain device that we want to. So in this case, for instance, the Nexus 5X. And add any custom devices to it if we want to. So in addition to that, we now have Chrome within the device. So now you can emulate how it would look like on the keyboard, as well as in landscape on the keyboard and with the actual Chrome of the device. And all of it is centered. So it's really focused on the responsive design story. And if you're working on a page that has a lot of media queries, you can also enable media queries, like in the old mode, in a much lighter way, and focus on them. Click on them to actually preview how it looked like at different media queries. So as you can see, the device mode icon is not in the inspect element area anymore. It's not there anymore because mobile is now the default in DevTools. Now, what does that mean in other places? Well, first of all, for throttling, for instance, you haven't seen throttling in here, and there's a reason for that. Because we thought, OK, in this new world, everything in DevTools is focused on mobile. So why shouldn't we put it where it makes most sense? And it made most sense to us in the network panel. So because it's always important to test how your site looks like on slow connections. For instance, if you're working with Service Worker. So we put throttling right in there. And the network throttling profiles can be configured in the settings panel. So now, I had this slide up last year at Google I/O. I'm going to bring it up again. Mobile emulation is not the same as an actual phone. It's important, right? We made the story pretty powerful, in my opinion, but still not the same. If you're debugging something like performance, we still can't really emulate that on the actual desktop emulation. So for that, previously you had to go through Chrome Inspect, which was a completely different window and gives you access to remote debugging, to actually remote debug your pages on a phone. Now, we thought we could do better than that and actually integrate that into the rest of DevTools as well. So now we have an experiment going that actually does that. So as you can see already in the new main menu, we had inspect devices, and it now brings up a dialog within DevTools. You don't have to go to another page anymore. You can continue to stay on a page. Now it's pending authorization. I click on it on my phone, say, yes, I want to agree. And now it's connected, and I can debug any of the pages I have open on my phone right there. So we think this new mode makes it a lot easier to work with actual devices. All right. Moving on from device mode, let's talk about something else. Here's a rule of thumb I came up with. The rule of thumb goes, a visual design practice is out of fashion when browser vendors have added a way to do it in CSS. That sounds a bit abstruse, but it's sort of true. I mean, if you look at border radius, CSS gradients, right? As soon as we got CSS gradients unprefixed and basically spec'd in every browser, there was flat design. Like people were like, well, it's not that cool anymore. And border radius was the same thing. I mean, as soon as we had border radius, everyone was like off it, and the trend was already moving on. So what's the point in doing new stuff if everyone is not using it anymore? Well, the good news is that this time we've been faster than the trend, which is great. Finally, this feels good. So what I'm talking about is animations. But when the developers think about animations, they often think about those kinds of animations. Animations that really do not improve the experience a lot. I mean, sure, it makes stuff wiggle. But I'm not really getting how that improves how I'm using my page. Not sure about you. But there's probably some purpose, but I haven't found it yet. But if you do animations correctly, they focus the state of change, right? So they make you focus, make the user focus on an actual change that's happening on the page. And that's really, really powerful, the transition that you're animating. And as well as actually hiding from the fact that something is loading, like a loading animation. Or you could do both at the same time, like we did on the old Google I/O website, where you can see now if you click on another link, right? It's both a transition that changes the state, but it also hides the fact that it's loading more stuff. That's the best case scenario. So what did we do here? Well, we added a new animation inspection mode. Is this running? No. Here we go. It should be running. And now it's running. So this is a very interesting site, because this is the actual spec that's used. It's the motion spec that the Chrome team created to work out the animations in Chrome for mobile. And now what you get here is if you inspect an element, and this keyboard didn't really work well. So now I inspected the keyboard, and I want to change the easing. I bring up this new cubic easing editor. And I change it to any kind of value and defaults. I can change the lines, as you could see. And I can make sure the easing works much better. So now if I click back to that animation, you can see that the keyboard eases in much nicer. But as you can see in this demo, there's a lot of complex animations like this one, like the menu animation or the animation where I open the tabs. Those are composite animations. So how do you focus on those composite animations? Well, that is where the new animation inspection comes in and becomes really nicely. So you can see once I go through those pages, it constructs groups, sort of tab groups in the animation panel. And if I click on them, it replays the animation that is just captured. Yes, thank you. And now I can scrub on that animation. But again, it's a composite animation, right? So we kind of realize that you want to look at that in context of your page. So you can scrub, you can make it slower, you can drag around, you can debug any state, right? And one thing that's upcoming that's really cool, we're putting some more work into this and it's completely ready, but it's the actual ability to change things in this mode. So now I can actually change things around. I can move the delay, I can change the duration of the animation. I can obviously change the easing in the styles panel because I click on stuff. And now, as you can see, I changed it in real time right there on the page. Thanks. So what have we got for offering? We've got a new improved user experience. We got animation inspection, and we got the new device mode that's always on. OK. So one thing that I have to mention is that some of the features are so new that you should be using Chrome Canary. Now, some features like the UI are already in there. I mean, you can use them, they work. But features like the animation inspection are still behind an experiment. Now, it's relatively easy to enable those experiments. Just go to Chrome Flags, enable DevTools experiments, click that, relaunch your browser, and then you have in your DevTools settings a new tab called Experiments, where you can toggle any kind of experiments that we're currently working on. And it would be great if you could do that and actually give us feedback if we should do something better. So that was all good and great if you're building websites with DevTools. But what if you're doing front-end ops? What if you're sitting in a control center and focus on performance improvements, et cetera, or actually debugging JavaScript? Well, we have some stuff for you, too. We have a few new JavaScript things that are really, really nice. One thing we've added is inline variables while debugging. So we now show what gets evaluated on every line once you're stepping through the code, which is really handy because otherwise you would have to hover over the variable first, dig in there, see what it is. But now you always see the context you're in and the current variable value in the debugging flow. We also added proactive compilations. So now if you do a change while debugging to see, OK, maybe this loop works this way, we actually show you that you did a semicolon error and there's a bug in the parsing of your code without you having to continue running it and just discover it afterwards. It's just a nice little improvement. And then we also added something that makes working with a lot of stacks in frameworks a lot easier. So you see there's a lot of stuff here from Ember. Now if I click on blackboxing in the settings, I can black box the library that I'm working with. And now the stack frames are hidden, and I can focus exclusively on the code that I want to look at. So in this case, for instance, I did not kill jQuery because I want to see the jQuery code, but I could obviously remove jQuery as well. And in addition to that, we also made it easy to do so with the events. So now, if you see, I clicked on an event in here, but it really didn't go to the right code. Now, I add framework event listeners as a checkbox, and it goes directly to the line I specified my event in. And then we got something for more advanced usage, which is object formatters. Object formatters allow you to do this. So it allows you, if you have custom objects of any kind of sort in your framework or in your transpiler, you can make them look differently in DevTools now. You can make them look a lot nicer than before. So before, you have to top, which is how it would have looked like before. But now you can style them and map them up in a way that they lock in a really nice way to the console. That's object formatters. And now, finally, I mean, Jake would probably come up here, and I was like, well, isn't this a service worker conference? What's the deal? OK. Well, yes, we have something with service worker as well. So this was service worker before. This is how you were working with service worker in this old world. You went to service worker internals, same as with inspect devices. It opens a new page, and it's really disconnected from the DevTools. And also, it is focusing on all of the things that are happening across your browser, not just the current service workers that you want to inspect. Instead of that, we actually moved it into the resources panel. So now, if you click on resources, you have this new tab called service workers in there. And it's a lot easier to work with them right there on your page. And it's only showing you the service workers that are relevant to you, allowing you to do a few cool things like forcing an update, simulate push, inspecting the worker right there. There's still some UI tweaks that we can make to that thing, I'm pretty sure. But I think it's a great step forward. So now we've got making authoring a joy to use. We made DevTools fun to use, and we gave more power to JavaScript developers. But there's actually one more thing. There's one thing that is not quite ready for prime time, but I don't want to talk about. We rarely do this to give a sneak peek of something, but I'm just so uncomfortably excited about it that I wanted to show it to you guys. And that's the layout mode. Now, the layout mode is a what you see is what you get editor for DevTools. And if you're like me, you might cringe a little, and that's OK. Right? Because you remember this kind of scenario where what you see is what you get is like sort of a maybe. Right? Maybe I get what I see. And that was the scenario with many of the tools that I grow up with that generate a lot of garbage code in the background, and you have no idea what's happening. So what was really important for us was a couple of design iterations that made this different. First one was if you look at a classical what you see is what you get editor, you get height and width controls. But how often, when you're doing a website, do you change the height and width of something? Well, you could change it on an image, sure, but mostly you change paddings and margins. So we spend hundreds and hundreds of iterations to come up with a model that actually works for paddings and margins. This is not the model that we're using, but it's just a design iteration that we're playing with. We also wanted to make sure there's no black magic going on. So we're not generating garbage code in the background, and we always have you look at what's generated right there. So with that being said, here's a preview of the layout mode. So I have this new little icon. I click on it. It becomes sort of a select. And I can click on anything on the page. And it brings up controls to change the padding and margin. Now, as you can see, when I'm hovering over it, you get these little stops, the walls, that signal in which direction you can drag and which one you can't, because everything on a website is highly dynamic. So you want to change the direction in the right way. Now, all of this matches up. So if I scroll wheel, I can change the actual rule. I can change the rule that I want to edit, and it changes all at the same time, as you can see in the menu now. And same thing here. I click on the paragraph. I take the margin or padding handle. I change the rule by using the mouse wheel. It flashes up in the style panel, and I change it right there. And it changes the one below as well. So it's a really, really simple way to change what you're having on a page. It saves it directly back to the style sheet that you have on your page. You can then take that style sheet, bring it back to your editor, whatever you want. And the handles look very, very different than what you're used to, I'm sure. And the reason for that is simply that we want you to focus on the content. We didn't want to have a bunch of handles on top of your content, so we moved them outside. So this is just a preview of the layout mode. And there's a lot more to come. We're still working on this quite a lot, but we're looking for your feedback. And now, next talk is going to be Paul Lewis and Paul Irish afterwards, talking about what we did in DevTools when it comes to performance. So not all is lost if you were looking forward to performance. Thank you.
My mic on. Good stuff. There we go. As one Paul leaves, two Pauls enter.
I don't see how this was allowed, really. There should have been some kind of policy against this.
Oh, would you stop?
It was actually really good to hear the spontaneous applause for some of the new DevTools features there. But I feel like Paul kind of missed the trick on that. He missed the one trick that you need to do to get spontaneous applause.
Or the big number?
Yeah, rather than say something like, you can scrub animations. He should have said, you can scrub animations, even those that are over 2,000 milliseconds.
See? Don't mean to school you in this game, but, it would have helped.
So one of the polls in this talk, it's you.
It is actually me, yes.
So I have to walk off the stage on my own?
I can draw you a map if you need. It's not that hard, buddy.
I think I can manage it. I think I'm going to be brave.
Are you?
I mean,
Proud of you.
Good luck though. You got everything set up.
I think so.
I mean,
I need the other Paul.
yeah. Is he around? Oh, he's over there.
Hello, Paul.
Yeah, come on.
Can we give Paul a round of applause?
Good luck. I mean, there's a few people here. Don't mess it up. There was 2,000 people on the live stream yesterday.
Thanks, mate.
You gonna be okay?
Yeah, you're not stressing me out in any way, shape, or form. Switching from MC to presenter is easy. Thanks, Jake.
It's all right. No
Do you want me
worries.
to draw you that map now? Go.
Well, here to speak about web performance.
Oh.
It's
Same.
Paul Irish and Lewis.
Right, you're.
Yeah. All right.
So I'm Paul Lewis. You may have met me.
Paul Irish, and we've been hearing a little bit about Rail. We just want to spend a moment to just focus on it, make sure it's all covered,
Yes.
and just give the deep dive on it.
Yeah.
And I want to start off by just discussing performance and the way that we think about it. Oftentimes we consider it as kind of this linear relationship between the faster it is, the better it is, and this is generally true, and there's a lot of academic research and a lot of metrics and numbers from industry that validate this and say that yes, actually conversion goes up, revenue goes up, all these things are great. But we kind of think of it as this straight line, right? And I'm not really sure, but because at certain points there's certain things, if you're on some experience and it's just terribly slow and you're like, come on, you quit. I quit, you quit. It's just. You have to, right? It gets a little bit better, and then you're like, okay, sure, yeah, I'll put up with it. Past that, even better, and yeah, I'm happy. It's beautiful, it's smooth, it's chill. But if we look at it as these, break it up into these quartiles, I guess, maybe the line is a little bit more like this. It might be a little bit more we start out, and in the front, actually, it's just it's literally too slow. From terrible to pretty terrible, it's just still not really satisfying the user. Up at the top, very high performance, changing the page load from, from being a second long to being a half second long, both are pretty much great. And it might be incredibly hard. So the ROI of development there is less important. That middle area, this is the sweet spot, right? This is everything is good, I put in the right amount of effort, users are happy, it's smooth, it's chill. And I do feel a lot of times we kind of end up we start here. And we kind of want to figure out where it is that we go.
Right.
But we need to figure out what it is. And right now, this is the too slow thing.
Yeah.
Which
I think, you want to get from too slow to where, what did you call it? Chill.
Chill?
I feel like it's a very you.
Chill is a good thing.
Well, yeah.
Well, yeah.
It is for you.
Of course.
Yeah.
Yeah. So, but too slow itself, like, is, I don't know, like, too slow.
Right.
I don't know.
Doesn't feel good. So I think the question, why I wanted to ask this, like, is 50 milliseconds too slow? Just kind of have this question in your mind as we kind of go through this. Like,
Well, 50 mil, it is too slow.
well,
Well, I guess.
I mean, you know what's coming up, so
True.
It's true.
True.
50 milliseconds, is it too slow? Well, look at it this way, right? If you're doing some page load, like you're loading the Google store or something like that, 50 milliseconds here is not a big deal, right? Because it's probably going to take a second or two. There's a lot of stuff going on. But let's say you are scrolling the store, right? 50 milliseconds here, you're going to feel that a lot more. You're much more likely to introduce jank.
Maybe janky.
Exactly. Or let's say you're doing something with WebGL.
Ooh.
I know, this is so pretty. Oh, yes. Cruciform. Jaume, well done, Jaume.
That's good.
It is weird. It's one of the nicest things I've seen. Another 50 milliseconds here, you're going to feel that one too, right? What it really comes down to is that the user context matters. What the user's doing is actually the thing that's going to define whether it feels too slow or whether it feels chill.
I like it.
Yeah, good. All right.
And I think that's kind of the way we've been thinking about this. Like, performance has had a lot of ambiguity, and we felt it on the Chrome team. We've optimized, for things like benchmarks and Kraken and Dremio and Octane, and that's cool and all, but like, we're not really satisfied with that. We were thinking about a better way of modeling this, and kind of walked back to Google's principles. And the number one principle is like focus on the user, and all else will follow. And I'm like, that makes sense.
Seems like a good thing.
Great thing. Like, let's apply this to performance. And so, like, we thought it might actually, we could flip the question kind of on its head, right?
Right. So instead of being kind of going, what's slow, or is 50 milliseconds slow, or any of that kind of stuff, instead of that, why don't we say, what does the user feel? Or, as I like to put it, how can we make performance user-focused? And I think if we're talking about users, we're talking about human beings, and we have to start with human perception. And I think a lot of people, many of us have seen these numbers before. They're about how delays are perceived. So up to 100 milliseconds, it just feels instant. 100 to 300, there's a perceptible delay, but it's not too bad. Up to a second, you're still kind of task-focused, but it's very perceptible now. And then it kind of goes all the way up to 10 seconds where you just go, I give up. I'm not going to bother with this. I'm just going to go and do something else.
And I guess there's probably one more number that we should kind of toss in the mix. 60 FPS.
Right.
Or kind of the flip side is the 16 milliseconds per frame in order to achieve 60. It's just kind of like the jank thing that's been discussed. So we'll add that into kind of the number mix right there.
So on the one hand, there's like this kind of theory, I suppose. Yeah. And then on the other side, you've actually got the reality of looking at a site and what goes into it. So for example, let's say here, I'm going to the Chrome Dev Summit website, and I tap on it, and I'm in the search, so I tap on the site itself, and that's a load. We're loading the site, and I maybe scroll a bit. That's an animation, fair enough. I'm going to tap on the menu.
It's like,
so nice, wasn't it?
Yeah.
Loads me the data there.
I like
I do a bit of a flingy thing.
nice.
Yeah. And then we go into a section with Joffrey, and then
And then Owen.
yeah. You call him Owen, whatever. So you start to sort of see these atomic actions as you're going through, as you're thinking about the things that you're building. You kind of go, yeah, that feels like these are the discrete interactions that are actually happening. So what we then need to do is tie those two things back together. We know how humans perceive delays and emotion and so forth, and we know that we can break down our experiences into these kind of buckets, I suppose.
Yeah.
So the four that we have are response, animation, idle, and load, and conveniently, by the power vested in us by transitions. So good, feels great. Okay.
I really wanted like the
You wanted
it
the
settles
kind of-
down and like
you wanted the cheesy
the
anvil
dust.
drop.
Yeah.
I know, I couldn't bring myself to do it.
that's nice,
Although I do love the flame one.
Yeah, like the classic Kino flame.
Yeah, it's so good. Anyway,
So, sorry.
Rail, let's dive into those responses. This is kind of the, you tap on something and we bring something back on screen. From the perception, we know that it's something that feels instantaneous. 100 milliseconds is going to make it feel instantaneous. So then maybe that tapping on a button or tapping on a form control, something in that kind of area. We want that to feel instant to our users. Next up, animation. Well, we want these to feel smooth and consistent. So this is animations like scrolling or transitions or gestures or those kind of things. Humans are very good at noticing variation in frame rate, not necessarily what the frame rate is, but because the frame rate on the web is 60 frames a second, that's what we aim for. And we want consistency there more than anything.
Yeah. Idle's next. Idle is interesting. It's kind of like the absence of an interaction. The user's not doing anything right now, but the thing is they might be. And the key thing here is this is a great time to do work, but the user might start interacting at any time. So you need to be available and responsive to that so that when they start to interact, you are giving a snappy response right back. And so if you break up your work into 50 millisecond chunks, you can basically guarantee that between you and the browser, you're going to do a good job of responding to that user when they start to engage. The last one is load. Load, I think, is the one that we're all kind of most familiar with, talking about it for years. And load, firstly, like getting the experience to the user, delivering to them in about a second. To keep that like seamless flow of thought really nice is kind of what we're shooting for here.
Yes.
So that's kind of like the numbers, but we're developers and we need to kind of like make this both measurable and like quantitative things that we can discuss on our teams and just make it really action focused. So if we take that stuff and blend it in, we're going to kind of just walk through the specific items.
Right. So as you said, it's like the responses is buttons, it's form controls, it's anything where you're kind of changing state, I suppose, is the opportunity to give the user some feedback. You want that to feel instant, 100 milliseconds.
You could call this, it's input latency too. It's
yeah, exactly right.
Generally, yes.
Dang, dang, response. Have you ever had that thing where you tap on something and you're like, did that work? And you go for it a second time, and just as you tap it the second time, the first one kicks in and you're like, oh, just, So you then tap it like a third time and you go, I'm going to wait this time. And then you kind of get, it just drives me mad.
That's terrible.
That's what this is talking about very much. Animation is the next one. As I said, scrollings, transitions, gestures, like pinch zoom, all those kind of things. You want those to be stick to finger fast, so 16 milliseconds.
In Idle, great time to schedule work. Chunk it into 50 milliseconds. That's the right way to do it. And lastly, load. Deliver in 1 second. But in addition to that, and probably the trickier part, is continuing to satisfy these response goals and stay responsive to the user during that load. During a page load, a lot of things happening, JavaScript running all over. It's just like a circus and cacophony of things happening on a single thread. And it's a little tricky to actually continue to satisfy like responding to the user when they start to engage. And they want to engage. Like,
they do.
They're just, hey,
There's
it's a thing. Woo-hoo.
Off we go. Yeah.
Okay.
It's good for us to see kind of goals and so on. But the important thing that we want to reiterate about Rail at this point is essentially that it puts the user right back in the center of the performance story. The technology and the technical decisions, they will come as part and parcel of that. But putting the user in the center is exactly right because that's exactly where we think they should be.
Yep.
Thank you.
Boom. Go.
You go now.
You're gonna, because you're gonna.
I'm going next.
And I'm gonna.
Yeah.
Okay.
So it's like it's a pull switch over.
It's just
just
another awkward departure.
Are you guys still talking? Do you want me to,
I need a map.
go away for a bit?
You're fine. You don't need a map. He needs a map.
Oh,
He's
okay.
quite not good at this.
So it's you again, is it?
It is me again. Is that right?
Were you using 60 frames a second on the screen?
I was actually using 60 frames a
Oh,
second.
that makes me so happy because I'm uptight
You
about.
are super uptight
frame
about
rates.
that. If you want to waste possibly 3 hours, just talk to Jake about frame interpolation on televisions.
Ooh.
See? Don't start now.
If I go to someone's house and they have,
we go.
I
Done
will
it.
spend about 15 minutes changing the settings on your TV to be correct. And frame interpolation is one of the things that needs to go away. What's the other one? Amplitude compression.
You're not
Makes
happy
me
with
angry.
that, are you?
Should I intro you for your talk?
You may as well,
may as
because
well.
I mean, it feels a bit weird if I intro me. Next to the stage is Paul. Hello, Paul. How are we doing? I'm fine, thanks.
So our next speaker is Paul.
Oh, really?
You know when you say a word too many times and it loses all of its meaning?
Paul.
Am I saying that right? Is that how your name's said? Or Paul?
Yeah, although I used to
or-
live in Sweden, and it was more like Paul there, and over
Really?
here it's like Paul. So
Paul.
pick one.
Paul. Is that am
Paul?
I getting that right? Paul.
No, you sound like you're having a problem.
Paul.
Calm it down.
Okay, here to talk about how to apply Rail to real-world sites. A big welcome for the British Paul.
You're so obliging, clapping a second time, but I guess if you're watching this on YouTube, you don't know that I just did a talk. And speaking of which, I should do this bit where I explain Rail just very quickly. These are the goals of Rail: responding in a tenth of a second, animating at 60 frames a second, being idle at 50 millisecond chunks, and loading it in under a second. So my job is to talk about Rail in the real world, to apply Rail, and I guess, are there any tips and tricks? And to know about that, or to answer that, you have to kind of start with life in DevRel. Because the thing about being in DevRel is that we do get to test technologies just as APIs are landing. We're working very hard with the engineers who are working on those, and that's part and parcel of what we do. We're sort of like the crash test dummies of the web, which explains my gorgeous good looks. And we also get to test ideas. Some ideas are good, some ideas are not so good, but all the same, we try and test them out anyway. In the last year, I have been testing Rail amongst the other things I've been trying out. And I've been building web apps to do just that, progressive ones, no less. Progressive web apps, awesome. This is the first one. You might have seen it a couple of times over the last couple of days. It's called Voice Memos. The idea is it lets you record voice memos, and you can save them to the device, and it works offline, and it uses IndexedDB and ES2050 and stuff. But you can see there's all these transitions, and it's got to load quickly, and so on. Then there's this one, which is a guitar tuner, which actually will tune your guitar. And this was a slightly different bet. I was trying to get Polymer to load under a second and get itself bootstrapped. And the dial's going round, and that's 60 frames a second, as well as processing the audio. So that was a different challenge altogether. And then the last one, which I'm still working on, is a podcast player. What a handsome pair of gentlemen there with a podcast that you might want to subscribe to. Again, so these big hero transitions, scrolling, and all that sort of stuff. So the question then becomes, does Rail work? And the immediate answer I can give you is, yes, it does. That's the good news. But like anything of this nature, I think it needs a couple of tweaks. And the reason I think it needs tweaks is just because it's a model, it's a way of thinking, but reality often just sort of diverges a little bit. I'll give you the first example. When you hear about Rail, the first thing you might think is that everything's equally important, like everything, I've got these 4 numbers that I have to meet. And it's not necessarily like that in my experience. So I'll give you an example. If you're building a content site, your profile, your Rail profile, I guess, might look more like this. It's more like the classic performance profile, where load is super important, getting that first content on screen. We don't necessarily think somebody's going to add it to the home screen or anything. We just want to get something up on screen. Animations are important here because the user's going to scroll almost certainly, and we don't want janky scroll. Idle, yeah, you could use a bit of that if you're going to beacon analytics type stuff back. But responses doesn't really rank that high because probably it's link-to-link, sort of page refresh, bounce around from different URLs. It's not so heavy duty there. However, an app will have a different profile altogether, in my view. An app is more like this because you've got these gestures, you've probably got big transitions, hero transitions, that kind of thing going on. Idle is quite important here because you're probably going to pull data from something like IndexedDB. And you're going to want to sort it, search it, do that kind of stuff. And you don't really want to do that in a way that gets in the users, or bothers the user, sorry. And then load, yeah, it's there. But hopefully you're using things like a service worker to really make these things fast and snappy. Now, you could argue that it should be this way or the chart should look that way. And for your app, it might look different. I think the only thing I'm saying is, for me, they're not always just sort of 4 equal players. The other thing that I think that kind of caught me out, actually, as I was trying out Rail, is I thought, goodness, there's these 4 independent things. Responses, and they're not going to play with the animations, whatever. The reality is, sometimes they group together. Let me show you what I mean. Let's say we're going from a list view to a details view. So I tap on my item in the list. That's a response. And it's followed by a load. And then we do the animation to the final state. So we actually have three Rail actions going on here. And that forces us into asking a question. What is the primary action in that situation? Let me throw it to you. What would you say is the primary action? Hands up for response? Hands up for load? Hands up for the animation? OK, it's an interesting one. I think the response is the most important one. The reason I think the response is the most important one is because it's the user-driven one. It's the thing where they tapped on something and they expect an answer back. So for me, that 100 milliseconds becomes the upper limit. Interestingly enough, in that case, the animation was the implicit response. They don't always go in sort of, they're sometimes grouped together in a funny way, I suppose. But that's what happens. Rail headlines then. Don't assume the 4 will be equally important. Figure out the Rail actions for your app. It's actually really good to kind of sit down and go, yeah, that looks like a response. That looks like they're going to group together. When they do group together, figure out which one is your primary and go from there. So with that, what I want to do is I want to step into each of these 4 areas and show you how I try and get within those thresholds. Responses is up first. Target is 100 milliseconds. And for me, I try and sort of break them out into 2 categories. The first is what I like to call simple responses, which is sort of like a state change, I suppose, like bloop. Okay. Most of the time, these ones are very straightforward to kind of get inside that 100 millisecond boundary, like tapping on a button or something like that. The more complex ones, and you can see another example here, the response, load, and animation ones, which really is a response, I think, those become more difficult, those complex ones, those combination ones. What I do in those situations is I take this approach. First of all, I will set up a timeout. The idea being one of 2 things is going to happen. I'm either going to get inside that 100 milliseconds or I'm not. Now, if I, in this case, fail to meet the 100 millisecond window, I'm going to show a spinner. Be like, for whatever reason, this is taking a long time. I'm sorry. Maybe the disk is slow. Maybe I'm going to the network, something like that. At the same time, I'm going to request the data. Then when the data comes back in, I'm going to clear the timeout. So if it's fired in under 100 milliseconds, we just clear it. Don't worry about it. It was a sort of easy thing to do. And I'll hide the spinner. So if it has shown, it now goes away. One of those 2 is kind of unnecessary, but they're both needed in this situation. And then I can do my transition to the details view. When it comes to like measuring the responses, say, for example, we're going to tap on the hamburger button here to bring out the side nav. The way I tend to approach measuring this is with DevTools and console.time. So for example, in the button listener, I start here with the console.time, which is me saying, right, start tracking this one thing, please. And then I'll do my toggle side nav, and then I'll wait for the next frame. So when my JavaScript is finished, there'll still be styles, layout, paint, composite, and all that kind of work that needs to happen. And at the start of the next frame, it's a pretty decent marker that says, OK, that previous frame is shipped. We've responded to the user. And so I'll just do time end. If you do take that approach, and you've got, say, you can do this on desktop, but you can also do it on a mobile device. And here I have my Android plugged in. And I go to Chrome Inspect, and I can click on the Inspect button, and you see I get my little device view there, which is great. Go to the timeline, and I take a recording, bring out that side nav, and I get my details. Now, 2 things here. Firstly, in my console, I see this, which tells me how long it took for that to finish, which was 13 milliseconds. But I also get this extra row in the timeline, and now I can start correlating that piece of work with what was going on the main thread and what was going on the compositor thread. All of a sudden, it becomes very easy to kind of see when things are overlapping. Oh, goodness, I didn't meet that marker, and that's because there's loads of layout. OK, I need to figure something out. So it's a very quick and easy way to start getting this data. So responses differentiate between the simple and the complex ones. The complex ones should normally be raced with that sort of timeout. And then you can just go crazy with time and time end to track your response times. Then you can do what you need to do with those. You can also use the window.performance, the user timing API as well here if you want to kind of beacon some of that back, I think. Next up, animations. Now I'm going to go straight to the how to win at animations bit. Because the reality is we have 8 milliseconds here. Most people go, I thought you said 16. And I did. But that's what everybody's got. And when I say everybody, I mean us and the browser. But the browser has overhead, and it has housekeeping to do. And so we get left with a window of about 8 milliseconds in which to do our work. And that's not a lot of time. And so the way to win is to work with the compositor. And the way to win and to work with the compositor is to limit yourselves to things that can be done just with the compositor. For example, you can use transforms or opacity here. So I built this site, csstriggers.com, a while ago, and it will tell you for every CSS property what it's going to trigger in the rendering pipeline. I give you the heads up. There's only two that don't trigger paint or layout and paint, and those are transform and opacity for elements that have their own layer. Now, there we go. There's the transform one. The way I do my animations, particularly these kind of big hero ones, is I use a process I call Flip, which I mentioned last year when I was talking about building the Chrome Dev Summit site for the 2014. Yes, that one. And I've since given it a name. First, last, invert and play. It helps you remap your expensive animations to cheaper ones, like this. Let's say I want to get this purple box from the top left to the bottom right. Most of us, I think, would probably go, well, transition on width, height, left, and top. The downside of those is that they trigger layout and paint, and they're not something you're going to be able to do at 60 frames a second, typically. You might get away with it, but probably not. It's definitely more challenging to build, but what you do is we start by calling something like getBoundingClientRect on the start position. This is the F of Flip. So we say, where are you on screen and what are your dimensions? Next, and this is without any animations on whatsoever, we add a class that puts it in the final position, the L of Flip, like so. We call getBoundingClientRect. It's a nice roll-off-the-tongue kind of API. We call that again to find out where it's moved to on screen. Now what we can do is we can apply a transform, and we just move it back to the starting position. As far as the user is concerned, nothing changed. But we know we just did it with cheap to animate properties like transform, and the same is true for opacity. Now what we can do is we can switch on our animations and just let it play forward. We just remove that transform, and it goes back. What we're doing here is we're most likely taking advantage of this setup where the user tapped, and then we do some kind of animation. And what we can do is we can take that window of opportunity, because like you saw before, it was like 13 milliseconds to do my response work. Well, that left me about 90 to do other things. So what we're going to do is we do the first, last, and invert part of Flip there, and then we can play out nice and cheaply. It works. We've used it on the Google I/O website, used it last year on the Chrome Dev Summit site. It's used on all three of my apps that I built this year. It's great. It works. There are caveats, and so if you are interested in reading more about it, I do have a blog post that you can grab there, bit.ly/flip-anims. So genuinely applied to the podcast one, let's say you're tapping on the podcast, it goes like that, just backwards. You know, it goes to the final bit and squish it back in, and then you play it forward and you get close to 60 frames a second. Well, you actually get 60 frames a second if it goes well. Similarly to the responses, when you want to measure things like this, you can call console.time, do all the flip stuff. In this case, I'm using transition, so I can wait for a transition end. And then on the end of the transition, I'm just going to call console.timeEnd. And in DevTools, I'm going to see this kind of thing. And again, I can see a couple of red triangles just above the main thread activity, which tells me that my frame rate did drop a little bit. But I don't think there was anything I was doing. I think that was just one of those things. If you don't do with a flip-like animation, it will probably be very difficult to get 60 frames a second. But it's a big cheat, and I love it. So animate with transforms and opacity where you can. Flip your expensive properties over to cheap ones. And be super cautious and avoid work during scrolls in particular, if you can. Big shout out to the Parallax Massive. Yeah, my favorite crew. Next up, idle. Now, our target here, as we discussed before, is 50 milliseconds, and the reason being that we want to be able to respond to the user quickly. So if they're in the middle of something and we're doing some idle time, and they tap, we want to respond. So we can finish our idle time of up to 50 milliseconds, and we can still probably get something to screen quickly enough that the user feels OK about it. Now, up to not so very long ago, there wasn't a great answer here as to how do I actually do this, because you'd be in a situation where you would have to kind of add event listeners to everything on your page and be like, well, the user doesn't seem to be doing anything because there's no events firing. And I don't know how long I've got, but I'm going to guess, so I'm going to maybe try and do it now. It wasn't something that we could realistically do. Chrome currently, as of Chrome 47, has request idle callback, which is an extremely useful API when you want to do idle work. Here's how it works. Let's say I've got some tasks at the top there, and it's an empty array. And let's say it gets populated. And I know how long my tasks should take. Maybe I've got 100 of them, and then I'm saying that each one's going to take maybe 1 millisecond. What I do is I call request idle callback with my callback. And when my callback fires, it gets this deadline object. And the deadline object has stuff in it, one of which is that time remaining function. And I can basically say this, look, while I have time remaining, and as in enough time to do a task, and I have tasks to do the task. Now, if I run out of time, and I still have tasks to go, I can request another idle callback. The browser's in the unique position of knowing what the user's doing, what's going on in the system, whether the main thread is free, and how much time it thinks you've got. The schedulers inside of Chrome and Blink are very good at this. So it can tell you, look, you've got this amount of time, this would be good. I wrote a post on Google Web Developers, Web Fundamentals, it's the updates, it is, about using request idle callback. So if you want to read more about it, head over there. The thing about idle time, though, is it is a bit different, because most of the time we're used to being like, well, I got an event, I'm just going to do my stuff, off we go. But you have to think differently when it's idle time. You have to think defensively, because you're kind of running against the clock. It goes, you've got 6 milliseconds, go. And you're like, I don't know, OK, great. And it's a different way of working. It spins it on its head. But it's fine. You won't get preempted, by the way, if you go over that time. It's just that the reason the browser gave you that time is because it knows what's going on. If you're looking for things that you could do with idle time, the basic answer is non-essential work, like beaconing your analytics. It's a good time to just kind of say, look, I'm not, you tapped on that button to bring out the side nav. I'm not going to send the analytics right now. I'll just request an idle callback, and maybe when the animation's finished or something like that, or the user's just like looking at the menu, that's a good time to kind of process that work. You have to think in small deterministic operations rather than, right, I'm going to make all my DOM changes now. Great. Now, what you need to do, say, for example, if you were trying to do DOM work, I'd suggest you either use something like a VDOM, or you do something on a document fragment. So you're working kind of off DOM, and then in some future request animation frame or something, then drop it onto the page. And as I said before, you want to think a bit more defensively. You're kind of running against the clock a little bit. Load is the last of the rail. And our target here is 1 second or 1,000 milliseconds. And I've added my own little caveat there for the 75th percentile, which is to say most people, because most of the time on 3G or 2G, you're not going to achieve it straight up because the radio might be off or the user's device is just busy doing other things. Makes it very, very difficult. But if you say something like for the 75th percentile, it becomes a lot more achievable. However, it doesn't absent us from making good decisions in the architecture of our apps. This is how I try and approach it for something that's built with vanilla. So in the case of voice memos, inlining that initial view is super critical. Bob Dodd, I nearly messed up there. Bob Dodd showed this yesterday, where you have a skeleton, and you say, this is the initial view that you need, and I'm going to inline my styles for that. I'm going to, in this case, I inline an SVG, and so the user gets something pretty quickly on screen. Then we do like an async. The first I'll load on some JavaScript, so it's not blocking. And that's going to start the request for the views that we're going to need, hopefully in the order that we're going to need them. In the case of the app, it's actually quite straightforward for me because I know the user flow. You're going to record something. You're going to see its details. You're probably going to go back to the list, like that. And I do the list later because I don't need it up front. And then I can go back into the details and play it and so on if I need to. So there's a variant on this, which is how I work with Polymer. And the way I do, so the guitar tuner uses Polymer, but it's all custom elements that I did. And the way I do it, again, is very similar. Inline the styles, even for the custom elements that I've got on the page. I basically make it look like that. So it's like everything's roughly in the right place. In fact, it's very much in the right place. Then, with my JavaScript in place, I'm going to lazy load on my various imports like that. And they are all going to request Polymer independently. But the way that HTML imports works is that you can request the same URL 30 times, and it'll actually only get loaded once, and then all 30 would be satisfied. So it's kind of like they're all having a race to get Polymer. And when Polymer comes back in, they can all bootstrap, and the app is complete. And it works really well. When you're doing your testing for load, I cannot recommend web page test highly enough. It's where I always go. What I tend to do is I tend to switch on for mobile 3G, so I feel it's quite tough. I'll do something like first and repeat view, and the checkbox there at the bottom is for capturing a video, which is really, really useful when you just want to kind of feel what it actually, what it's like to use. To kind of make the point, though, about the 3G and even trying to make the right calls on the architecture, I get a speed index here of 3,403. Ideally speaking, I'd like to see something lower than that, maybe 3,000, maybe a little bit less. But the reason I'm not going to get much better than that is because when I look at the request for just the index.html, which had everything in to get that initial view up, you see numbers that look like this. The DNS over half a second, the connection, the SSL negotiation, time to first byte. But the content download, the bit I'm actually feel like I'm in control of, is very, very tiny. In other words, there's the flame transition. Don't mind if I do. 99% connection. It's like that. It's like all that other stuff I don't feel like is really something I can affect. And this is what it's like on first view. On the left is desktop on cable. On right, mobile 3G. And off it goes. It's pretty fast. But this is the bit where we go, now I'm going to bring it back to the 75th percentile. This is how I'm going to try and win. By using, I did say it was a spoiler, service workers. Ta-da! Yeah, I'm not actually going to explain the code of the service workers. Jeffy did a great job with that, and we've got plenty of stuff for you. But the important thing is, by having a service worker on, my numbers for repeat views are really very, very good. And the reason I'm visually complete slightly after a second is because I do a nice fade in, so it doesn't think I'm visually complete. I could not do that. I could just snap it on. I don't think that's quite as nice, so I take the hit on the numbers. But I know what I'm happy with. And this is what it looks like in video. Ready, steady, go. You can't say fairer than that. If a user has an app that does that, they are going to be so happy. Jake built an app called SVG OMG for SVG editing, and somebody remarked on Twitter, they said, I didn't realize the web could be this fast. And it's like, yes, it really, really can. And it's really nice when it is, and it's perfectly possible as well. So then, load stuff. I would say inline your app shell CSS, lazy load absolutely everything else. Bob Dodd did a great job explaining that yesterday. I'm saying the same thing today. Far future cache your JavaScript, your CSS, your images. This is classic page load stuff, and use a service worker. One other thing that I've been working on, which has been a sort of like, I suppose a 20% project-ish thing for me, is something called BigRig. And DevTools is absolutely amazing and what I use on a day-to-day basis. But sometimes I just want a bit of a smoke test for like rail measurements and be like, is that roughly doing the right thing? Or maybe I'm looking at somebody else's stuff and I'm just like, how much time is going into JavaScript or not? And where's that? Which JavaScript from which domain? And that's why I built BigRig. This is BigRig. You can have a play with it yourselves. The idea of BigRig is that you make a project. So let's say I make one for the Chrome Dev Summit website that I want to track. And inside the project, you have actions, and actions are things you're interested in. They're Rail actions, essentially. Like in this case, I do load, response, and animation. So let's say I want to do the initial homepage load or something like that. And it creates it for me. And then you go in and it says, upload a trace for this action. And you're like, what? Traces are Chrome's internal way of measuring performance. Timelines are traces, effectively. And you can get a timeline file from web page test. So here I've got Chrome Dev on a Nexus 5. Select that. And again, it's mobile 3G. Why not? And under the Chrome settings, you can check a box that says Capture a DevTools timeline. Turns out really quite useful, that. And off we go, we start the test, and it takes a while. When it comes back in, you see there's this link here in the corner. It says timeline. So you click it, and then you go back to BigRig, and you give BigRig the file, like so. You do the dance while you wait. And eventually it will say, this is what you spent your time doing. This is the parse HTML, this was the JavaScript, this was the styles, the layout, the paint, the composite. And you get that those numbers immediately, and you can also go into the extended information where it'll tell you by domain where the JavaScript was coming from. So 4,009 milliseconds on the site itself. And you start to get this, over time you can actually build up a picture of, how am I sort of spending my time across all these Rail actions. So it's good for responses, like I'm going to tap on a thing. What it does is if you give it a timeline file with console.time and console.timeend, it will use those as the labels, and it'll go, oh, you got one there, okay, that looks like a response. That one looks like an animation, and so on. Say it's good for animations, it'll give you those in frames per second, and again, you can start to see how you're doing there. This one's an actual real one. Paul Kinlan uses BigRig to monitor his site, and you can see on the far left-hand side, there's a big block of green and a big block of yellow. And the big block of green, he was like, why have I got a big block of green? And we went to look at his site, and it happened that he'd forgotten to resize down an image. And it caught it for him, and he fixed it, and you can see it's sort of settled down a lot for him. If you can post the timeline file, the trace file, to an endpoint, and it'll process it. And if you do that with the hook, you can see which web page test result it was, and you can also see the git commit as well. So you can be like, oh, I had a regression. Why? Kind of useful. And in his case, in case you're curious, that's what the blame game looks like for him. I've suggested that he might want to lazy load his comments. Makes it quite easy to do that kind of stuff. So if you're interested, BigRig is on the Google Chrome GitHub org. Some people don't want a UI, though, and that's cool. So there's an alternative, which is the globally installable BigRig. Similar kind of deal, actually, just on your command line, where you can go BigRig with a file, and it's the same timeline file from before, and I'm just going to ask it to pretty print the results, because otherwise it'll return just JSON to you. And you can see here, again, it's the same kind of details, but if you want to integrate it into an existing flow, you can do that as well. And that is under Node BigRig, or you can just do npm install. And then there's this one as well, which is another tool that I've been working on. And these are all, as I said, these are kind of to try and make Rail measurement just a bit easier if you want to do it outside of DevTools. And there's loads to do, and there's loads I want to do. One of the things is it's hard to do a scroll test. So I've got the BigRig runner, and you can give it the site that you're interested in tracking, or just getting a scroll test from. I'm telling it to look for the body element, and I'm going to pipe it through to BigRig. And you see Chrome's open in the background, and it just does an automatic scroll test without me doing anything. And at the end of the scroll test, it spits out the results, which BigRig then parses and says, well, that was a smooth scroll and an animation, and it was 54 frames a second. And it tells me what I was doing per frame. Kind of useful if you just want to, as I say, do a smoke test and go, how am I actually doing? OK, I have not so much time, so we'll come back into the final thoughts on Rail in the real world. Rail and those thresholds, they genuinely work. If you build a site or an app against those Rail thresholds, you'll find that it feels just right. It feels snappy. It's well worth dissecting your site into those Rail components and trying to instrument your code with time and time end and so forth. And you could stick to the limits. They are very, very good. They will serve you well. And as always, test and use web page test, use DevTools. And if you try BigRig, do let me know. And with that, I will say thank you very much.
Nicely done, sir.
Thanks for having me.
And BigRig, that's all on GitHub, right?
It is, yeah, yeah.
Yeah, so people can contribute and send you a poll request.
Yes, yes.
Actually, some people on Twitter have been getting involved in this, and they said the stuff you were doing, the optimizing the web component stuff, you could release that, and that could be Polymer.
Yes,
Yeah?
yes,
Yeah?
I fully endorse this.
And our hotel, we've got back to this evening. Where is that?
It's Palo Alto.
Palo Alto.
Yes, it is.
So congratulations, everyone. You made it to the break. There's going to be coffee out there, and there's in soft drinks as well. There's also, once again, going to be a coffee cart outside. Yeah, you survived being pulverized by the first set of talks.
It's going to be relentless, to give you the heads up.
There is more to come. See you back here at 11:30 for more poll-based vocalizations. See you.
Thank you for joining us. Our program will continue in just a few minutes. Thank you for joining us. Please take your seats. Our program continues in just a few moments.
Welcome back. MC Paul resumes. Speaker Paul has disappeared. That's good, isn't it? Did you have a nice
Good
break?
to have you back.
Thank you. Coffee? Good? Everything good? Yeah. Okay, cool.
Yeah. Right. And coming up next, a man who needs no introduction.
Wow. Okay. Okay, I like it. I like it. All right, so we've been hearing a bit about Rail today, and we're going to dig in and we're going to see how we can apply what's inside the Chrome DevTools to really measure, diagnose what's going on, and fix it. So first up, you've seen this slide before, between response, animation, idle, and load. I'm going to be focusing mostly on these two pieces inside of response and load, kind of having that instant 100 millisecond response coming right back after tapping an action, and then page loading up quickly. And what I want to do is basically just do a performance audit live with some websites in production It's just a lot of live demo. What could go wrong? Don't know. But the first thing that we're going to look at is the actual Chrome Dev Summit's website. And I want to take a look and see how it loads and if we can identify ways that it could load even faster. All right. I'm going to come over here. And what we got is a fresh build of Chrome. And we're looking at the Chrome Dev Summit site. We're emulating as mobile. It looks pretty good. And I just want to capture the reload action, just to see what's going on. So, well, I can just hit Command R, and that's cool. But one of the hard parts about like what we see here with the waterfall is, yes, we see the waterfall, and there's a lot of network requests, but it's really hard to do the correlation of what is happening at the network layer and what is actually happening on screen. So now up here in the top side, we can actually turn on screenshot capturing. And so this will basically capture screenshots every single time that the page is visually changing. We capture all of them and then keep them so that you can help to correlate what's going on. The other thing that I'm going to do while I'm here is just turn on throttling. Regular 3G is usually what I go with. I'll flip that on, and I don't know. I'll just, Command R will capture that. OK, good. You can let it finish. I'll let it finish. Oh, I'm impatient. You can hit the red guy. All right, cool. So here's our network waterfall. Up on the top here, we have the actual what happened inside of the view. And you can just double click on these to view what happened. OK, this was our first paint. White screen. Good. Happens a lot. It's, it happens. You can just hit right on these if you want to like iterate. Ooh, look at this. You can see the page kind of fading in. I guess there's a fade effect there. And there we go. Yeah, cool. So this is over here, this guy, right? This is our, we call this the first meaningful paint, right? It's not the first paint, but it's the first paint that like a user would care about. It's typically what you'll see. So when you're diagnosing page load, you really just want to start from that first meaningful paint and just work backwards from there. Because usually the reason why that was delayed was because of some network request that it really needed to actually finish that off. All right, so we got that. And we can also, like, as we hover over these down in the waterfall, we can see kind of the relationship of where each of these screenshots were taken. So this one is over here in this-ish area, which is interesting. But one thing that we can do, because there's so many network requests, we can kind of simplify things. One thing that we really want to know is, of all these network requests, which really matter when it comes to page load, which are going to be render blocking, right? Now inside the network pane, there is this priority column. You can just right-click inside here. There's a lot of things in here. Priority is one of them. So this is basically the network priority that Chrome and Blink uses to go fetch this. And these priorities more or less map to, is it render blocking or is it not? So if it's high, then it's very necessary. And if it's a low priority, then less important. The nice thing, too, is you can see like this JavaScript file, right? It is low priority. And like scripts usually are high priority, but this one's low. And you're like, well, maybe it was just like async tag, async attribute. We can just click through on the initiator, which is whatever triggered that request, and view it. I'm going to just move that out of the way. And where did it click? It just highlighted it. I'm going to click it once more. Ah, yeah, this line. OK, cool. And here's the insertion. And yep, async equals 1. So it's nice to kind of like verify that setting a script to be asynchronous does, in fact, make it be fetched at a lower priority. And so we know that. But the other thing that we can do here to kind of simplify the view and let us focus a little bit better is focus on only the asset types that really matter when it comes to kind of being content blocking. So this is just kind of a hack. You can hold down Command and just click on these guys, JS, CSS, web fonts, HTML, and I'll include XHR just for now. A bit more simple. And so now if we hover over, we can get a little closer view. OK, cool. So it looks like our yellow line dropping down is hitting right right after these two guys finish, I think. The nice thing is we can also, just zoom in. Is it? Yeah, it might be overlapping. Not sure. What are these requests? Is the schedule.json and the widget APIs.js. This one's low, so I'm going to bet it's async, so I think it's not going to matter. But schedule.json does, if this is the schedule page, we might be using that. So that might make sense. This is like my number one suspect, right? So then here it's like, OK, well, this request happened way out here. And let me just verify if I click in. OK, yeah, this is like the JSON of everything that's happening. OK, so that's necessary. It was requested way out here, not at the beginning. Why? We can look in the initiator column and just see what it says. But another way to do this is you can hold Shift in this view, and we'll basically highlight the asset dependency graph, more or less. So like, if we highlight in this, then schedule.json was requested from elements.html, which is highlighted in green up here, which was in turn requested by the original HTML. So you can kind of like walk your way down and see the relationships. And this is really valuable because on your homepage, if there's a lot of like third-party content, a lot of anything, it's all about these like CSS requires these web fonts and scripts require other scripts. And knowing kind of these asset dependencies is usually critical in finding out why your load is later or not. OK, so the schedule.json is requested from elements.html. And you'll see there's two right here. And it looks kind of weird because they look like the exact same thing. And it is weird. Turns out it's a bug. And it was in Chrome for about a day. It's fixed now, but this is the build I have. So that's just what it is. Sorry. All right. But let's just say really kind of either one of these. This was what ended up making this request. Now, I can look into this and see what is inside this payload. It looks like it's like a vulcanized polymer, all the elements. And it's big, which is why there's so much blue, like a lot of download time, 2 seconds worth of download. It's 133 kilobytes gzipped. And if I kind of expand that, 550 kilobytes ungzipped. OK, so it's a pretty big file. And that is why the download time was so big. Again, I'm throttling, so there's that. But it's a bit more realistic when it comes to mobile. So like one thing that we can already say is essentially, if the schedule.json is what is our last thing that we need to actually get this paint out, and the elements.html has to finish for us to do that, then if we can affect the size of this big blue chunk, then we're going to make that first paint much faster. So like so we can basically say that if we dropped the size of this initial vulcanized elements.html like in half, then we would be ending the request somewhere around here, like 2 seconds. And then the schedule.json would just be able to shift over. And so we'd be looking, instead of at a load time of about 4.2 seconds, we'd probably be looking at about 2.75 to 3. So we'd be able to knock off a second worth of load time with that one change. So this is kind of like the way that you can associate both visually what's happening and kind of the dependency relationships between assets in order to really diagnose what is really happening in page load and why it is taking a while. All right, cool. But it's interesting. Like the schedule.json was actually requested through JavaScript. And while much page load concerns are very oriented around network, there is plenty of things, especially as people are putting more sites that are built as web apps online, a lot of times that you're dependent on JavaScript to really finish everything. So I want to take a closer look at a heavier app. So we're now going to take a look at Hotel Tonight. If you haven't used Hotel Tonight, it's just a really nice app and mobile web app that finds you a hotel to stay at, even same day. It's cool. The team did a really nice job building this. In fact, Hotel Tonight was it was native app only. And then this summer, they released a mobile web app for it. And it's really, really nice. So I want to take a look at it and see what we can find out. This time, instead of using what's happening in the network, we're going to go kind of like dive into it fully, everything that's happening with the timeline, profiling JavaScript and all that. The first thing I'm going to capture is reloading, just kind of the initial load of the page. I'll turn on screenshots over here, because I like the screenshots. And we're just going to hit Command-R. See how that goes. All right, cool. That was fast. Good. All right, what's going on? All right, so the first thing is we have at the top of the timeline, this is the overview. The red is indications where we think there might be responsiveness concerns. Underneath that, these little green blips, and this recording, not terribly useful. It usually the green represents the frame rate. So if you're really looking to hit 60 FPS, you want that green to be tall, and you'll be janking if it's falling beneath. The next section here is usually the most interesting. This is the main thread activity. Yellow is script. Purple is recalculation styles and layout. And this is kind of getting you a sense of what your activity is over time. And then after that, a little bit more faint, you can see it here, is kind of a condensed version of the network waterfall. Following that is the screenshots. So we can kind of like track the load of this. And you can see like it loaded fast, right? And we're looking here, and here is where like that first paint came up. So I'm just going to zoom in here. And it's actually interesting, right? Like there's this whole section of like things going on. And you think like that might be where it loads. I mean, that is where the JavaScript does all the work. But it looks like there's not a lot happening up in front, which is pretty peculiar. But we can see, in this tiny little view, this network request. And so I'm like, OK, yeah, I guess it's the HTML. We can now introduce the network requests into this view. So we turn on this checkbox. And here we have what's actually happening in the network layer. So here's the HTML. And then at some point, these JavaScript requests kick in, and so on. But it's nice to kind of get this association between what is happening in the network and then on the main thread. So one thing I want to do, right, like it looks like it paints very quickly. If we want to look and really associate what the page looked like with what is happening down here, you can just click on these frames right here and see what the state was. And so you can click these, and I think, yeah, this one. OK, cool. So this is the frame that basically gave us our first meaningful paint. Now, we're looking at Rail. We want a first meaningful paint that's in a good amount of time. So you can hold Shift to do this kind of measurement. 600 milliseconds, which is good. It's definitely hitting the 1,000 millisecond budget. And that is the first meaningful paint. That is a solid paint. But it's cool, right? Like there's not the paint comes pretty much immediately, and there's not a lot of JavaScript that's sitting between it. And if I just want to like take a closer look at what is in this HTML payload, because it seems almost magical. I'll pretty print. And pretty print on the HTML, it's going to pretty print the CSS and the JavaScript. And there is minified HTML in here. So I'm going to cheat a little bit, because the pretty print doesn't yet do HTML. Bring it over into this little web app that you probably have used before. Get that. OK. CSS. Here's the HTML. OK. They're using React. Yes. And what's interesting, too, is as you look down, inline styles. So they're using the inline styles on every element, which is kind of a thing that's happening now. And it seems actually OK, right? Like there was no extra CSS request. It was all in line. It was fast. So as far as I'm concerned, it looks good to me. That's pretty cool. And so basically, they did a fantastic job here of optimizing for their critical path, inline the CSS. The first HTML payload is enough to get that view up on the screen. All right, cool. Now, let's come back. And I just wanted to see one thing. So they got the load within 600 milliseconds. That seems good. But we should go and see kind of how they handle responses. So now we're going to just start a new recording. And I'm just going to tap on this search hotels. See how this works. OK, cool. All right. When you capture screenshots, this part takes a little bit longer, but it should come back right. Woo. OK. Overview, what are you telling me? Some things, I don't know. It's nice to have these screenshots, right? Because you can zoom in, and you can even see the little loading animation is animating. So all that was captured, right? So it's like the click, and then animate, and then we got stuff. So I'll just zoom in on kind of that chunk. And, all right. So in our flame chart, we have this area over here and this big guy. And one cool thing, you can see here's the XHR coming back. And it's nice because now that we have network here, we can just validate that, yep, here is the actual AJAX request. It's API Hotel Tonight inventory, right? Cool, makes sense. So now we got a nice kind of correlation. We had the click, the network request, we waited on that came back, we did this work. So in total, what do we have? We started with this click event, but I suspect in front of that, we zoom in enough. Yeah, we had a mouse up. It might even be a touch start in front of that sometimes. So this is where kind of the input started. And then we zoom out, and this is where the paint finished. Was it this one? Yes. This is the frame right here where everything finished. So if we measure this area, this is about 1,700 milliseconds. But specifically, like we have, this was our response, right? We clicked, and we started getting a loading spinner. That is a response. You are giving immediate feedback. You're saying, hey, we're going to wait. So in total, that was about 200 milliseconds, a little longer than you want, but OK. It did the AJAX, and then it looks like it did a bunch of JavaScript after that. And so the load itself was, yeah, see, that's a second and a half. Good, but probably could be better. Now you're at this point where, OK, seems like this is fairly wide. We could probably see what we can do about that. So in the Flame graph, we're looking at all of the JavaScript call stacks. And you can just drag it. You can also hold down Shift while you scrolling trackpad to scroll. And it just, it's very tall call stacks. The tall isn't really a problem. Tall is just the height of the call stack. No issue there. Just makes scrolling take a little bit longer. But you can see receive component, update rendered component. Like this is React doing some stuff. But it's so much data, like I don't really know where to start. So here's one way to go about it. We can view things kind of like you'd have over on the Profiles panel. The Profiles panel, you'll kind of start a recording and then kill it, and there's a chart, but you might be looking at something like this. And this is great, but a lot of time you'll see this program, and you're like, what is that program? I know, yeah. I wondered for the longest time. So program, for the most part, the numbers are pretty much all the things happening that is not JavaScript. So the recalculation of styles and the layout, all like this stuff, this is program. It's time that the pure JavaScript profiler can't account for, but you see it over here in the timeline. But the challenge then is like, this is a lot of information. So now we have the same sort of breakdown, but over here in the timeline, with both everything that's happening in the JavaScript and what's happening from the browser. So I can work my way down from, say, for instance, this finish loading, and look at the total time from the call tree, and just kind of like follow the path down and see where the time is spent. But these call stacks are really tall. It's going to take some time. So I'm just going to work from the bottom up and see what functions have time in their costs. So in the bottom up, I'm mostly interested in the self-time column. And here, for this big chunk, we're looking, this is 900 milliseconds or so of time. And our number one guy is this, capture stack trace. And you're like, I just looked at this, and I was like, capture stack trace seems like something that you wouldn't want to be slowing down the user for a quarter of a second on capturing stack traces. Doesn't seem like terribly important to the user. So let's see what's up. Capture stack trace actually is showing because we now implement the ability to see what's happening at a native level. So capture stack trace is actually not in the website's code. It's in V8. I'll just navigate over here. This is the definition of capture stack trace, and it just sits inside of actually V8's source. There's a lot of JavaScript that V8 uses to do JavaScript stuff, and capture stack trace is one of them. So this is ours, and this is what's taking time. But why is this happening? So we'll just kind of like walk upwards. Why did capture stack trace get called? Because of error constructor. Error constructor because of T. T is in React. OK, cool. So let's click over there and take a look. Check this out. This is nice. I didn't have to pre-print anything. This is actually just, these came in from source maps. You can actually see over here they use Webpack, and they created source maps. So this app in production actually ships with the source map, so it makes my job of demoing this really easy. You know, it's quite nice. All right, so we're looking in this area. It was like function T or whatever, but it dropped me here, and I can see the new error. So I don't really know what this is saying, but I do know it says that we're creating a new error and we're turning it upwards to say something. I don't know. But turns out that this error creation, to basically message upwards and then be caught by React and do something, that error creation actually has a significant enough cost in this case that it accounts for a quarter of the time of this big block. That's probably not what they expected, but we're able to see it here. And so there's probably a good way that we could address that, do something different, and then drop the cost of this at least by 25% and end up with something that is fitting a bit more into our 1 second budget for the load. Let's see. The other thing that I wanted to point out, and I'm going to come back to the network to show it, is in addition to the priority stuff that I showed you before, there's also a connection ID column that you can turn on. Now this is really helpful, especially if you're in HTTP 1.0, haven't yet moved to HTTP 2.0, because it's basically giving you an ID for the actual TCP connection that it's using. And here you essentially get to see when new TCP connections are created and which ones share. So I can actually sort by this and see, for instance, that that these requests here actually all just shared a single TCP connection, which is actually why you see like this gray gap here, because this request was just waiting for this to finish, and then same thing here, because they're all sharing the exact same TCP connection. So it's getting into the internals of networks and how they work, but still it gives you a bit more insight into what is actually happening under the hood and why you might be seeing this sort of a delay. All right, let's bring that back. Bring it back, bring it back. All right, cool. So in the timeline, some new stuff that I showed, capturing screenshots, the network waterfall, bringing in there, and summarizing all of the work, just aggregating it up to tell you what is happening across all the operations in the tree view, both call tree and bottom up. You can also, and this is pretty fun, you can also group all that work by different things like domain. So if, say for instance, Hotel Tonight, it looks like most of this is their own code, but I can also take this work and separate it out, see by like URL, which files are all my costs coming from, or sometimes even better is the subdomain. So here we can see like all the third parties, say for instance like analytics or whatever, you can see their actual costs on the page for that recording. Even things like Chrome extensions will be included here. So it's really nice to get a sense of my page is complicated, lots of third parties going on, not sure like who to blame. And this gives you a really clear idea of which players are consuming time on your main thread. All right. Over on the network, I showed the dependency visualization. understanding the priority of different requests, that connection ID, and the screenshots. It's good stuff. As you can imagine, a lot of these things are fairly new. Not all of them, but many of them. Canary has them. In only a few cases will you have to turn on the experiments, but the end of Paul Backus's talk gave you a good idea of how to take care of that. And I also just want to point out, like, we're not finished. There's a lot more things that we're working on, especially in this performance space. We want to make sure that you always get good insight on how you can really make a big impact when you're addressing performance and getting the information that you need. And also, if you are really into the stuff, you're interested, we're hiring. So holler at me, and like, we'd love to get some people that are really excited about building fantastic tools for developers to make them really productive. All right. So I just did kind of like a live perf audit. There's been a number of these that have done for all sorts of different sites. One in particular was the mobile Reddit site, which is a fun site and that had a lot of interesting things going on, got written up, a lot of interactions from the community, just like figuring things out, and ended up making their site a lot faster. But there's a lot of these. I encourage you to read these. You'll learn a lot, but at the same time, I also encourage you to do it yourself. This is the Wikipedia team. They literally printed out on paper the timeline, and then just like took Sharpies and Post-it notes and just marked it up and said, like, for this 10 milliseconds, we're doing this, and then this, just accounting for the time and justifying it too. Like, should this thing really take this much time? And it was really effective for them. And in fact, like, they shared this a little bit ago. They were able to drop the page load size, the page load time for Wikipedia in half. And like, I don't know, like, that seems pretty good. We all use Wikipedia. We want it to load fast, especially when we're like in a bar, like trying to win an argument. So seems good. All these results come directly from their work diagnosing in a performance audit, kind of in this manner. So I encourage you to do it. I think that's it. Thank you guys very much.
Ah, that was great.
Wasn't it just?
Would you say Paul Irish is the best Paul on the team?
Challenging. Well, I guess sometimes I sort of feel like I operate in the shadow of Paul Irish at bigger events like Google I/O, particularly. Yes.
Yeah. Okay. Let's act this out. You're at I/O,
Right.
right?
Okay.
Big conference.
And you are.
Well, so you're at I/O, and you're Paul. You're going to be a member of Chrome DevRel.
Yes,
you're
I'll
going to
be
be
me.
well, probably you're going to be Paul Lewis.
I'm pretty good at that.
And I'll be someone else at the conference.
Okay. Let's do this.
Okay. Let me get into character.
Me too.
Hey, you're Paul Lewis, right?
Hi. Yeah. Now at this point, I'm very excited. Somebody's coming to talk to me. Great.
Is Paul Irish around?
No, don't think he is. So.
Okay.
And that's how it goes.
Every conference.
Yeah, every single time. It's fine. Anyway, our next speaker is a total non-Paul, the first non-Paul of the day, a charlatan in the Pauligarchy.
Hey. It's someone called Seth. Seth. It's so nice to say a different name. It's got a much nicer sound to it as well, like Seth rather than Paul. Paul.
I think you'll find it's Paul, but whatever. Whatever. Talking about V8 and the improvements we've been making to its performance. Welcome to the stage. It's total non-Paul, Seth Thompson.
Hi, everybody. My name is Seth Thompson, and I am a PM on the Chrome V8 team. But I'm here to represent the whole team, and it's a big team. We have folks in Munich, San Francisco, Mountain View, New York, and contributors from around the world. So this stuff is really due to their efforts. OK, let's get started. So V8 shares the same name as a race car engine. And I don't know much about cars or even mechanical engines, but I am fascinated by Formula One for two reasons. The first reason is it's just so fast. The cars are going at such speeds around the track that I read if they could actually get enough runway on the ceiling, they generate enough downforce to stay on the ceiling. That's crazy. So I think we picked the right name for suggesting unparalleled speed. But the second thing about Formula One that I think is more pertinent to this talk is the fact that every year, the cars that the racers drive undergo drastic changes to all sorts of parts of the car, the engine, the brakes, the shape of the car, the steering. So, I mean, here's just a picture over the years of how much each car has changed. And you can imagine how different they must be to drive around that track. I mean, the track is the same, and the driver is the same often, but the cars that they're working with have just different performance characteristics. You know, year to year, a team might change the tire tread. That means increased traction. That means that the driver has to be cornering in a different way than they did with tires that were smoother. They might upgrade a V8 engine, the V6 engine to V8. This creates more power and torque, but it changes the performance characteristics once again. Team might change the turning radius to accommodate a particular track. I think Monaco, the track has such tight turns that they need to change how steering works to actually get the car around the turns. And the driver has to accommodate for that on the fly. And the shape of the car, the body of it, changes in ways that fundamentally affect the aerodynamics. Just a small modification to the tip or the tail can feel different as a driver going around the track. So when I joined Google, or before I joined Google, I thought that the V8 engine, which turns dynamic JavaScript into native machine code, was done when they first announced it. I mean, that was such a major improvement in speed. It really ran almost as fast as native code for a variety of applications. I assumed the team packed up, gave each other high fives, went home, were happy, they were done. But I couldn't have been more wrong. Ever since then, the team has been working on an amazing set of features. Things like adding new support for language semantics and syntax as ECMAScript changes and JavaScript changes. They changed the heuristics that they tune for optimization. Things like code caching, inlining, type inference. There's a bunch of hacks in there to really squeeze out extra performance. And the results are dramatic. Chrome today, with V8 of today, is a turbocharged version of the original V8. So the engine really is changed. And unlike a car, which gets a new release maybe yearly, V8 gets a new upgrade every 6 weeks as a new version of Chrome and Chromium is released. So this talk is about the engine and the driver working together. V8 in Chrome and you, the developer, writing code for V8, working together to make the fastest possible web apps. So the talk is in 2 parts. The first part is what we're doing on our end to make all JavaScript currently out there faster, improvements in the engine to eke out extra performance. And the second part is how you, as a developer, can best take advantage of these changes and adapt to machinery that's being evolved underneath you. Because ultimately, the goal is to write fast JavaScript that's fast today, but then that remains fast as it stays out there on the web and is browsed via new browsers with continual improvements. So let's start with what V8 has been working on, what the team has been working on in the past year. I'm just going to highlight 4 big areas. We released a new optimizing compiler. We drastically improved garbage collection by making it smarter and more intelligent. We've added support for ECMAScript 2015, aka ES6. And we have this incubation project, which is really cool, which is a Svelte interpreter. And I'll talk more about why we did that in a second. So let's start with Turbofan. Turbofan is the code name for a new optimizing compiler. Now, V8 as an engine, I mentioned, compiles dynamic JavaScript to native code. But it has actually a bunch of different compilers. And it chooses which one to use based on the code itself, how long a function is, how expensive the function is, what language features a function you're writing might use, and especially how hot the function is. The more you run a particular function in JavaScript, we pull out the big guns, and we use a compiler which takes longer, perhaps, to compile your code, but results in much improved optimizations. So why did we write a new optimizing compiler? Well, we wanted to start up from the ground up with a new approach. Turbofan represents the JavaScript AST in a sort of interesting new form called a sea of nodes. This reduces the loads and property accesses at a really low level in the memory to this giant soup that we can have more freedom in how we schedule which accesses and which loads come first and last. the scheduling freedom is unparalleled and allows us to architect new and improved optimizations. But what does this mean for you? Well, Turbofan is designed from day one to support ECMAScript 2015. So it's true. Some ECMAScript features, even if we supported them syntactically in our older compiler, we couldn't use all of the optimization techniques that, let's say, another compiler used because the support was spotty. But Turbofan will support all of ES 2015 and beyond, and it will make it fast. This is really exciting. Turbofan uses static type information for the first time. Previously, we inferred type as a function ran. We made guesses about what the type was. But with Turbofan, when there's static type information, we can leverage it from the beginning. So I'm very proud to announce that we now fully optimize, or will fully optimize ASM.js with Turbofan. This is a big improvement. And soon, when the WebAssembly language spec is finished, we'll be able to optimize that as well. So rather than guessing at what types you're using in JavaScript, if you use ASM.js, compile C or C++ code, we can run it like native code because we know from the beginning what types are being used. So Turbofan is great, but this next improvement I think users will really feel fastest. So idle time garbage collection is a method of freeing memory in the browser more intelligently. Now, I'm sure you use Chrome, and you know that when you have a lot of tabs open, the memory consumption is non-trivial. So all of these optimizations make the browser feel so much lighter. So what's going on? Well, Blink, the rendering engine in Chrome, released a scheduling API recently. This is amazing because for the first time, a single API has a global knowledge of what tasks are happening in the browser. That is, when clicks are coming in, when a scroll event is happening, when the page is actually being rendered to the screen for a frame, and of course, when V8 is busy performing a JavaScript execution on the main thread. So with this new scheduler API, we have a sense of what's going on. Now, I'd like to show a quick diagram here that explains why jank happens in the browser, why something that should be a smooth animation feels kind of jerky and stuttery. Well, for smooth animation, you need 60 frames per second. So the bottom of this diagram has markers for frames going forward in time. And in between those frames, the browser's doing work. It's running JavaScript execution to figure out what to paint to the frame for the next screen. And you can see here it's often variable. Some frames have a lot of JavaScript work, and some have idle time. Now, as the JavaScript is running, it's creating new objects. The memory profile is increasing. So V8 has to have a garbage collector, which comes along at some point and says, oh, these JavaScript objects aren't being used. We can free them up and lower the memory profile. But normally, it waits until the memory profile hits a certain point and then schedules garbage collection. It does this because it doesn't know any better. You can see here how big that garbage collection chunk is. And if it comes at the wrong time, it may postpone execution of the JavaScript for the next frame and miss the frame. This is a janky, disrupted animation. With the scheduler API, though, now we know when these idle spots are happening from V8. So we can proactively schedule garbage collection in smaller chunks before we really need to garbage collect. So you can see here, we've got some free time in that second frame. So we'll go ahead and garbage collect and reduce the profile a bit. Having this global knowledge of idle times allows us to make garbage collection essentially happen when you're least expecting it, resulting in smoother animation. Here is a demo of the Ort Online 3D benchmark. And you can see, after these improvements, just how much smoother this is. In fact, the video that's playing in Keynote right now is not representing this correctly. If you try this in your browser on the right, it's even smoother than it looks here. And it's faster, too. You can see how much further we are along in the benchmark than we were before. And again, this happens because we know more intelligently when to schedule garbage collection in between frames. Now, there's another improvement that this knowledge of when the browser is idle brings. V8 has this heap of dynamic JavaScript objects. This is what makes the memory profile so big, what takes up space in your memory. And often a page creates a bunch of memory, or a bunch of objects when it initially loads. So you can see here this graph of a page creating a bunch of objects and increasing memory. Right after the page loads, we increase the heap size to that limit prime. But then garbage collection kicks in, we reduce the memory footprint a bit, and then I background the Gmail tab. So let's say I go away, I'm not using it actively, and the page goes idle. Well, you can see the usage of the creation of new JavaScript objects kind of tails off, and we don't have much memory consumption. But before these improvements, that heap size had still been raised, and we were taking up more memory than we needed. Well, now, Blink knows when you background the Gmail tab, when you're not really interacting with the page. And we can use that time when it's in the background to clean up after ourselves, shrink the heap, and just take back a bunch of memory. So here's another demo. They're flipped this time, so be careful. On the right is Chrome 43, the old version. On the left is Chrome 45 after we implemented these improvements. And you can see when you initially load the page, memory consumption is pretty high. It's around 150, 200 megabytes. But the crazy part, it was about 150 on either side. But after both tabs go idle, only in the new version does Chrome realize, hey, we're idle. We can free some memory. And quickly, I think you'll see it happen soon here, we save a bunch of memory as we shrink the heap. Boom, it's down to 80 megabytes right now. So it's about half of the memory that the older versions of Chrome took. This is huge, and it's out there in the wild right now. You and your users will feel that Chrome feels lighter and snappier because of this. So that's garbage collection improvements. But here's one that as developers, you might be particularly excited about. We are spending time right now working on implementing ES 2015 in V8. So ECMAScript is the body which determines what the JavaScript language is. And this last year, they've announced a new specification with a bunch of really cool features. We've got promises, proxies, arrow functions. V8 has shipped a bunch of these features already. So you can go out today and use classes, a newer syntax and semantics for better object-oriented JavaScript programming. We've shipped arrow functions. Not only is it shorter to write this, you don't have to write those anonymous functions anymore, but it's much easier to deal with lexical binding of this. So the this in this case refers to the correct thing, whereas previously, when you're writing this longhand, you might have to bind the context of that inner set interval to the outer context. And we've shipped spread and rest operators. These just make it so much easier to write arguments that take in something like an array. And we've staged a bunch more features. These are just two highlights, default parameters and destructuring assignments. But we've got a bunch more in the pipeline. We are really committed to delivering ES 2015 in the browser. And like I mentioned, because we're doing this in Turbofan, it's not just that we support these features, but we're really committed to optimizing them and making them fast, too. So here's a project which is new. And it's a bit of an experiment, but it's pretty exciting. Designing V8 is all about trade-offs. As you try to go faster, you grapple with increasing memory and having a more computationally expensive CPU operations. But as Tal mentioned yesterday, increasingly a bunch of users on the web are browsing from what we call svelte devices, or these Android phones, or phones in general, that have drastically reduced memory profiles. So while you may be using an iPhone or an Android Nexus in your pocket with 3 to 5 gigabytes of memory, many of our users, in fact, a huge number of them, are browsing with just 512 megabytes of memory. This makes it really tough to perform optimizing compilations for JavaScript. So Ignition is an experiment to trade off a bit of speed. It's true. An interpreter is slightly slower than compiling code to native. But it is drastically reduced memory footprint. So already, based on our experiments, this Project Ignition has shown that we can create a bytecode from your JavaScript AST that's 3 to 4 times smaller than unoptimized code, than what we normally would run off the bat in a browser. And it really will be noticeable for users on mobile devices that just are not as beefy as some of the things that Chrome and V8 were originally built for. So really excited about this. But what's next? Briefly, I want to talk about frameworks. V8's motto is to make all the JavaScript on the web fast. But how many of you use frameworks when you're starting up a new website? Is the first thing to do to find a new framework? Usually it is. People use React, Angular, Ember, Polymer. All of these frameworks perform in different ways. They're often setting DOM objects rapidly. They might have a virtual DOM implementation. Some of them use an immutable pattern where they create a new object every time the object changes. And some of these APIs are designed to be ergonomic and really flexible and easy to use. But they turn under the hood into things we call polymorphic functions, which are bad for performance. So V8 historically has made these types of applications with frameworks fast just by making all JavaScript fast. But next year, we really want to dig down into the specific usage patterns that modern frameworks are using and optimize for them in particular. So we want to reduce boot time of frameworks, and we want to turn the patterns that they all use into really optimized code. So this is something that historically I think we haven't spent much time looking at, but we're really excited to tackle this. And we've been working internally on some advanced benchmarks which use real websites and are able to load them deterministically for our testing. So we'll be testing on the web, on real websites that, of course, are using frameworks. So this is what V8's been working on and what we'll keep working on. But there's another half to the equation. And that's the code that you guys as developers are writing. Obviously, you know to use efficient algorithms and optimize the types of data types you use for something. But as Paul showed just earlier, and as you've seen at this entire conference, there's times when you're optimizing for something like Rail, and you dig into DevTools, and you see just in the flame graph, JavaScript execution taking up a massive amount of time. And sometimes you can't do less. So the question is, how can you write that same JavaScript in a way that V8 can make faster? So I've shown a bit how the V8 engine is like a Formula One car. It's this incredibly powerful machinery that allows you to move at blinding speeds, but it can be finicky sometimes. And more importantly, over time, its performance characteristic and performance affordances change as we evolve the engine and make changes to it. So I'd like to think about how drivers in Formula One actually adapt to changing machinery, like an F1 car. So one of my favorite drivers is Ayrton Senna, the 3-time world champion. I actually showed this deck to my team and got 40 emails back with different names that I should mention instead. But I'm going to talk about Ayrton Senna. And I like to imagine, what if he was a JavaScript developer? How would he apply this knowledge of adapting to a new car to the browser and adapt to new versions of V8? I'm going to give 4 tips that I think are inspired by the sort of things that drivers do. The first tip is understand how modern engines work. Now, Ayrton Senna doesn't have a mechanical engineering degree. Neither should you read the source of V8. But having, at a high level, a sense of what's going on under the hood is really useful. So I'd like to share 2 things which are fundamental enough that they're actually shared architecture across all of the JavaScript engines out there on the web. Because really, you want to write code for everything. So this includes SunSpider and SpiderMonkey in Firefox, JavaScript Core in Safari, and Chakra in Edge. Look at this code right here. It's pretty simple. I'm just creating a point class and instantiating a new object 3 times over. Well, I mentioned that the V8 engine is turning this dynamic code. Because remember, in JavaScript, your objects can have any number of properties, and you can change the shape of them at any time. Under the hood, V8 needs to turn that into native machine code. And it does this in a way that you can imagine as creating structs, like C-like structs, for every object it sees. So when it sees this point, it infers as the function is run, or as this code is being run, it infers that that object is not this dynamic dictionary, but it's actually a struct that looks something like this. It has 2 properties, x and y, and they're both ints. So when you create these 3 points, it knows that the shape of the object you're creating is the same, and it optimizes it for that. So these 3 points share the same object under the hood. We call that a hidden class internally. But in JavaScript, you can dynamically set properties. So if I modify my third point to add a new attribute, a new property, z, under the hood, we have to go back. We notice this. We still support it, obviously, because it's valid JavaScript. But we have to undo that optimization where we said all points shared the same hidden class. And we create a new hidden class. It looks something like this. It has an extra attribute, z. And this is really bad over time, because we have a bunch of other optimizations that rely on there being the smallest number of hidden classes possible. Here's a quick example. And let me just show you how to fix this. You should always declare all of your properties in the object constructor, because V8 can look at that and say, aha, all points will share these properties, and I can optimize for that from the beginning. So this is a much more effective pattern. I'll say that one more time. Declare all properties in object constructors. Don't dynamically add or remove them. Here's an example of why this is so important. If you have code like this, say a function twice, this function just adds the input together and returns it. In JavaScript, you could throw an integer at this, and it would add them using math. You could throw a string at this, and it would concatenate them. You could throw a bunch of different types at this. So when V8 sees this code here, it's a really hot for loop. And it runs twice 10,000 times. 9,999 of those times, the input to twice is, in this case, a string. Or excuse me, an integer. Am I reading that right? A string. And it sees that. So it says, aha, we're going to optimize twice. It's going to be optimized for integers. Hooray! But then, on the 8,000th time, you send an integer down the chute. And it says, well, we tried to do this special optimization, but it broke. So we're going to have to de-opt to a slower version. So when I talk about integers and strings, what I really mean is these hidden classes that I was talking about before. JavaScript doesn't have types, but we think of objects as having particular shapes. So it's important that when you call a function, you use the same shape of arguments and returns so that V8 can turn them into highly optimized machine code versions and consistently use them without de-optimizing. Now, this is called monomorphism. That's just a fancy word for it. Now, I mentioned two high-level parts of the architecture. These are unlikely to change because they're so core to how all modern JavaScript engines work. But I don't expect you, and in fact, it's an anti-pattern, to go memorize all of the other heuristics that V8 and JSC and SpiderMonkey and Chakra use, because they're changing so fast. So in general, it's a bad idea to memorize rules, and it's a much better idea to use the tools, the suite of tools that Chrome and Chromium provide you, and others. So for example, the V8 engine has a headless version called D8. And if you use it, you can pass in certain flags and introspect what's going on under the hood. There's some information out there on the web if you want to do that. Paul and others today, all the Pauls, have been showing you how to use dev tools and find flame graphs where you can dig into actually which functions are taking the most time. In fact, in the CPU profile page, you can see those same de-optimizations that I was talking about a couple slides earlier. You can see them because there's a little warning sign next to the function in DevTools on the CPU profile page. And there's a couple more interesting tools out there if you really want to dig into the nitty-gritty. Something called IR Hydra, which actually shows for any JavaScript how we turn it into native machine code. But I want to quickly give a brief demo of a little tip that you can do today, probably without installing anything extra. So I mentioned D8, which is the headless version of V8, but I actually don't have it installed. And if you're not a Chromium developer, you probably don't have it installed either. But I do have Node installed. And Node embeds V8. In particular, Node has all of the V8 options available as flags that you can pass into Node when you execute something. Now, before I show you this demo, I want to make one important caveat. It's important to check the version of Node you're using, because you want to be on the same version of Node as the one in the browser. So if I run this, I can actually see what version of V8's included. It's 4.6. That's the same as Chrome version 46. That's what I'm running in the browser. So check that the versions are the same. But when I have Node installed, I can pass in this flag called, and this works for D8 too, but you probably have Node already. I can pass in a flag called trace deopt. And what this does is it executes a JavaScript file, and it logs out when those horrible de-optimizations that I talked about happen. So I'm going to run it on the code I showed in the slide. Remember, this is this twice function, which has a polymorphic function call. You pass in a string for a while and then an integer. And if I run this, Node and V8, D8 under the hood will tell you that. Now, this is a bunch of low-level assembly, but in particular, this first line here is really important. That's the one that we want to look for. It's actually grep for just the word deopt. This will print out when it hits a particular function deopt. So you can see here it says, if you read it across, JS function twice was deopted. You can imagine doing this on a bigger code, a bigger piece of code. Let's say something that has 4,000 lines. And counting how many deops happen. This is a good way to sort of figure out, just by squinting at it, kind of how optimized your code is, or how much room there is for improvement. Let's take a second to run. 12. OK, so I know I can compare this to another body of code or change the code a bit and see if it deops less. But let's apply the knowledge to this example. So I mentioned that polymorphic calls are bad, where you pass in 2 types into the same function. So what if we remove this if statement and just pass in a? I actually have it over here. It's called monomorphic. So in this version, we do the same thing. We have this really hot loop, but we're only passing in one type of object, one shape of object. It's a string. And this time, V8 can optimize this and not hit those deops and have to revert to a slower version. And you can see here, it runs without a problem because there's no more de-optimization. So this is just a quick tip. Start with DevTools and the flame graph. But if you really want to look under the hood, you can use Node. OK, so that was 2. Use tools, don't memorize rules. What are some other things you can do? Well, definitely stay up to date. You can bet that Senna understood when the car got a new brake or when the engine was updated. He was talking with his engineers every day. Well, we have a really easy channel for you to figure out what's going on in V8, under the hood and with developer-facing improvements. It's the V8 blogspot at v8project.blogspot.com. So read this and see what's going on. And you can also read the change log in our source tree, although this is more fundamental architectural changes and doesn't get updated quite as frequently. So the blogspot is a good place to start. And I really want to impart that V8 is constantly changing, and we're constantly making improvements on it that are driven by the types of code that we see out there in the wild, that you guys as developers are writing. And we can move faster with this feedback loop by just communicating more. So if you've got code and you're not sure why it's slow, you've looked at some of the dev tools, you've dug in and tried to remove things that are obvious, but it's still slow, file a bug. Because in V8 and all the modern JavaScript engines, reasonable code should run reasonably fast. Engage with the team on communication channels like Stack Overflow, and in particular, you can send mail to v8users@googlegroups.com. Talk with us. Show us new frameworks and libraries. If you are using the latest and greatest framework, and for whatever reason you're seeing a long boot time or a bunch of de-optimizations when you shouldn't be, show us this framework, show us this library. It helps us stay up to date with what developers are actually using. And finally, the biggest help is if you contribute benchmarks of real-world apps for us to test against. Because the way we figure out if we're making good performance changes to V8 is by running benchmarks against it. And we want those benchmarks to be as close as possible to real apps. It's best if they actually are real-world apps. So send us stuff that you use to test speed, and we can work to optimize it. And finally, 2 anti-patterns. I mentioned these earlier. Don't memorize hard and fast rules. There's some information floating around on the web about how V8 doesn't optimize try-catch statements. Well, it's true. It's true today. But we're about to ship optimized versions of try-catch. So these characteristics change. And if you just used a rule that you read one time on Twitter or on the internet, you'll miss it when V8 finally ships the improvement. And actually in Firefox, they already have shipped it. So these things are changing so fast, you can't rely on rules. You got to rely on tooling to figure out what's changed. And lastly, don't use micro benchmarks to make design decisions. When I talk about benchmarking and profiling and running a performance audit, it's very important it's on your actual app and not some slimmed down version. It doesn't help to write a 4-line JavaScript statement and try to figure out what way of iterating over an array is fastest, because I can guarantee you that when that same array iteration happens in a 50,000-line real-world production app, a bunch of factors, the context will be different, and you can't guarantee that V8 will perform the same. So don't use micro benchmarks. And lastly, to bring it full circle, one of the things that I was so struck by Senna and these F1 drivers is how closely they work with the team that built the car. They constantly talked, and the team really was just as essential in winning races as Senna was as a driver. So you are Senna, you're the developer, you are the driver, and the V8 engineers are this team of engineers working to make the machinery that runs your code faster. So let's work together. Help us help you reach that checkered flag. Thank you very much. You can contact me at seththompson@google.com and send mail to v8users@googlegroups.com. Look forward to hearing from you and sharing more about the exciting things that V8's working on. Thank you.
I didn't know you were such a big Formula One fan.
Oh,
we should
no.
go for like a picnic or something. I used to work for a terrible financial company, but they sponsored Williams, and I got to go to the factory, and I got to touch Senna's Williams with one of my hands. This is my Senna hand. This one.
If it's not TVs and getting rid of frame interpolation, it's F1 with you, isn't it?
Well, it said do not touch on it, but we don't pay attention to rules, right? That was the moral of that story.
Well played. You actually anyway. So. You're doing better on this particular trip to California than our last one, aren't you?
What do you mean?
Well, so I don't know if you've seen, Jake and I do a YouTube series, and we do a podcast called HTTP 203. And the last time we were out filming, it was at Google I/O actually, wasn't it? And we did like a 6-part over, filming. And why don't you tell them what happened on the very first day?
I got a little bit sunburned.
You didn't. You looked like Hellboy.
I mean, it was overcast. I thought I'd be okay. I was not okay. I mean, and I really panicked afterwards. I thought I'd ruined the entire shoot. I mean, I was even setting an alarm to go off every hour during the night, so I would get up, fill the sink with freezing cold water, and dip my head in it to reduce the redness.
Does that work?
It does not work.
So you came for pro tips. Well, you got one.
Well, I went onto YouTube in a kind of blind panic, and I searched for sunburn makeup. Help me, please. And I found this tutorial written by performed by this teenage girl, and she started by applying loads of moisturizer, and I was like, yeah, whatever. I've been up every hour dunking my head in water. I've got the moisture situation under control. But then she busted out green makeup.
Ooh, yes. Tell me more. Go on.
Makeup.
It blows my mind.
Well, I thought this is not going to work, right? Green makeup. She's going to go full Incredible Hulk, but it turns out Hulk counteracts Hellboy. It was incredible. So far, I went to the store and got myself some green makeup and found it, and I put it on, and it works. It was perfect, right?
It was not perfect. You looked like Mr. Data.
Yeah, okay. But the one thing you can say about Mr. Data is he does not look sunburnt.
You can say that. You can also say he looks shiny and silver. So a fun game for you would be to watch some of these episodes and go, I think Jake's got his green makeup on.
Yeah, it didn't go unnoticed, and thanks to everyone on Twitter who pointed that out. Right, okay, there's been a lot about Rail so far, hasn't there? Like real-world performance, tips and tricks. But how can you scale Rail measurement out to real people who are visiting your site?
And to answer that question, welcome to the stage a man some call Ilya Grigoric. We like to call him Ilya Grigoric.
All right. Great, thanks guys. So watching some of the presentations this morning, it's pretty exciting time to be a performance developer, performance engineer, because frankly, there's just so much data that's becoming available. It wasn't long ago that just like a couple of years ago, we couldn't even talk about something like Rail because frankly, we couldn't surface the right data for you to act on it. And I remember the first iterations of it when we started working on it where we're exposing this data and it's just big data dumps, and it's very hard to process, right? And now you have DevTools kind of threading it together, bringing it to a cohesive picture, and it's becoming a really viable thing that you can tackle. So this is all exciting, and this is necessary, and it's critical to our success, because you need that sort of environment, the controlled environment where you can capture the data. You can take the trace. You can actually bring in the trace from another developer, analyze it, look at all the parts of the stack, and kind of piece them all together. So you're not looking at memory versus frames versus network in isolation. All of those things interact. And really, kind of the big breakthrough that we've had in the last year or so is starting to piece all those things together such that you can actually figure out what's going on. So this is critical, but I'm going to claim that this is actually not sufficient. Because once you've done all of this control testing and you have all your regression monitoring and you've run all your builds and all the rest, then you deploy your application into the real world, and the real world is kind of messy, as you probably realize, because there's just such a big variability in the devices, in the networks, in just conditions that your application may run in. And it's a little bit crazy as to the kinds of reports that you'll get back from your users. For example, you might never expect to hear that, hey, my application runs slower when it's sunny outside. But that is exactly the kind of scenario that at least one of the teams that I worked with has encountered. And this was an obvious head-scratcher, but after doing some extensive user research and other things, they realized that, well, it turns out that the application is an application that many users use while driving. So they like to mount their phone on the dashboard. The dashboard gets kind of hot. The thermal regulator kicks in. It throttles the phone. The application runs slower. So you get slower frame rates on a sunny day. And that's kind of crazy. And it's not the kind of thing that you would model in DevTools. I don't know, maybe at next Chrome Dev Summit, we'll add a new weather emulation mode. You heard it here first, right? Like, this is funny, but it's true. Like, this is the kind of stuff we have to deal with. And this is why we need real user measurement to both capture the real world data coming from the users, and also the APIs to kind of counteract and figure out what's going on the device. So this is the part that I want to focus on here. We've heard a lot about debugging and DevTools and other things. The part that I'm interested in here is what can we do, what can we gather from real users? And turns out this is actually an area that we've been focusing on for a while. We have the W3C Web Performance Working Group, where we have all the different browser vendors talking about this. And we spent internally in Chrome quite a bit of time over the course of last year digging into all of the subsystems, trying to understand, do we have the right APIs to first identify and measure each component of Rail? If we do, or if we don't, how can we make them better? And if necessary, can and should we add new capabilities to the space, such that you can actually bring this data from the real world? So the good news is we're not starting from scratch. The Web Performance Working Group has been hard at work for quite a while, and we have a collection of APIs that already fill in some of these gaps. And in particular, we do a pretty good job on the loading part, so the networking part. And if you're not familiar with these APIs, I definitely recommend that you check out the perf timing primer, which kind of threads the whole story together for what's a high resolution timestamp and why do you want that? What's a timeline, and how do these events get emitted? And how do you measure the, say, loading time of web page versus resources and all the rest? So we have some good resources there. But of course, that doesn't capture the full arc of the Rail experience, where it's not just the first load, but also the interactions afterwards. So we started looking at, first of all, how are developers using the current APIs today? Are they sufficient, even for the load part? And can we do better? And one pattern that we found, maybe not this exact pattern, but something very similar, is that due to the nature of how these APIs have been implemented and spec'd, many developers are actually polling for performance data. So the typical pattern is you want to observe that some event has happened, that, for example, the resource fetch has finished, or maybe the application is emitting custom metrics, and you want to observe that. So if I'm an analytics vendor, I'll just sit there and pull periodically the page. I will pull out all the entries from this global buffer, and I'll then diff them, or try to diff them, from the previous state to try to figure out if something is new. And this creates a lot of unnecessary work, obviously, for the platform, because oftentimes there's just no new events, and this is just unnecessary work. It also has some funny race conditions, and because it's a global buffer, if somebody else comes along and clears that buffer, then some other application is losing data. So this is not great. So after some work in this space and thinking through the plausible solutions, we actually introduced a new interface. And this is already available in Chrome Canary. That you can boot this up and play with this today. This is an observer interface, where instead of polling for these events, you can actually say what type of events you would like to listen to. So for example, if you're interested in fetching or in fetches going on in the browser, you can subscribe to resource events, which will be emitted when the resource has finished fetching, or things like marks and measures, which are user timing metrics that the application may be emitting. So this is an API that an analytics vendor or your own application can subscribe to and get these notifications. And we can actually deliver these notifications in a smart way. You've already heard about the concept of idle time and pushing some of the non-critical work into these idle blocks. We can schedule these types of events into the idle time such that your RAF loop does not get interrupted. So you can play with this today, and I encourage you to. This is a very nice addition to the API. Now let's move on to the response. So response is a big component of Braille, right? We've learned that we want to respond to all user input within 100 milliseconds. So where exactly is that 100 milliseconds spent? And we spent quite a bit of time with the input team trying to figure out all these different stages of where the latency goes today. So when you tap that glass, the hardware actually has to register that fact and deliver it to the operating system. The operating system then needs to dispatch that events to the browser. The browser has a bunch of event loops and needs to deliver that event to the correct event loop. Finally, that event loop gets to your handler, dispatches the callback, you execute your code, right? There's quite a few layers in here. And doing some testing, this is just a device that was done in the lab. The actual numbers will vary depending on the hardware and other things. But we found that the hardware to operating system latency can be as high as a couple of frames, so 30 to 50 milliseconds, which is quite significant. Similarly, getting the event from the operating system to the browser and then finally to the application can also take another couple of frames. So if you think about our original 100 millisecond budget, we're already spending quite a bit of time just getting the event to your application. And then finally, your application has to run. And then we looked at how you would measure that today, or how developers are measuring it today, right? And you would use something like the user timing API, where you get that callback, you do a mark start, then you finish your work, you do a mark end, and then you have your duration for the handler. And that's your response time. And of course, that's not great, because we want to provide better accountability, both for the browser developers and the engineers or developers building all these applications. So there's a big question mark here. It's like, how do we surface this? And the proposal that we have on the table right now, it's actually being implemented in Chrome and a few other browsers, is to change the definition of the event timestamp. So there's an existing timestamp property on the event object. But turns out today, due to various implementation bugs, it's not terribly helpful. It uses a different time base. It's not terribly accurate. So we're exploring changing this to a DOM high-res timestamp, which is a high-resolution timestamp, which will have the same time origin as all the other performance events. And more importantly for this particular case is that for input events, it would reflect the timestamp of when the operating system got the event. So this is a much more accurate, higher fidelity timestamp that you can use in your applications, which is quite nice. And then for other events that are not input events, it would be equal to the time when the event is created by the browser. So this is something that's going through the implementation phase right now, and I'm hoping to see this come to Chrome soon. So with this code, you can actually, the way I guess you would use this is if you're trying to track the response time of, say, your touch events, you would subscribe via Touch Start Listener. You can then compute the final time by just subtracting the performance.now, which also returns the high-res timestamp, and get the full duration, or at least a much more accurate duration, which is nice, right? Ideally, this is kind of where we want to be. Except, as we started digging further, we realized that there's some gotchas here. So when we look at scrolling, which is one of the most fundamental and important interactions on your device, we found that in many cases, there's a huge delay. 100 milliseconds, sometimes even 500 milliseconds, before the browser can actually do the scroll. And if you dig in to understand why, it's actually quite tricky and interesting. So let's go back to our original flow diagram here. You get the kernel event, you dispatch it to the browser. The browser says, hey, are there any touch handlers registered on this page? Because if they're not, great, I'm done, and I can just do the compositor scrolling. I don't have to talk to the main thread or do any work at all. This is the fast path, and this is nice and beautiful, right? But in practice, most every application will have some sort of handlers register. So really what happens is then we say, OK, fine, we can't do the compositor path. Now we need to actually dispatch this event to the main thread. And just this one hop, this synchronization to the main thread is already a bottleneck, because just adding one single handler will force this entire path. So we dispatch it to the main thread. We then run your handler. And then we have to check in the handler, did you call prevent default? Because prevent default allows you to effectively stop the browser from doing its default operation. Right? So we have to block on this. And this is critical. And of course, this is not great, because now if let's say your application is executing something on the main thread, scrolling is blocked. And even just the synchronization is expensive. So clearly, we need something better. And this is a good example of perhaps some missing functionality or some missing APIs that will allow us to build much better and more responsive applications. So one proposal that's currently being discussed and is under development is this idea of passive event listeners, where when you register the event listener, you can actually declare it to be passive. And effectively, it does two things. It promises that you will not call prevent default, or rather, even if you call prevent default, that is effectively a no-op. So you will not prevent the default action. And it also allows the browser to then proceed with scrolling without blocking on that execution. So if we go back to our original diagram, there's a lot of pointy arrows here, but the important part is on the bottom, right? So we say, is there a touch handler? Yes, there is. Is it passive? If it is declared to be passive, then we can continue with the scrolling, but we will still dispatch the event. So you'll still get the event in JavaScript land. You can still process what you need. And ideally, actually, you would take that handler and move it into some idle time, right, where you can process it and unblock all of your critical work such that your animations run as fast as they can. And this is really nice. So as I said, this is one of the proposals on the table, and I'll be curious to see if there are others. But this is what we're currently experimenting with. So as a quick summary for response, we have event timestamp, which provides much better granularity for response time. Do be careful with event listeners. This is something you may want to audit on your application today, just to see, am I registering these things? Are the things that I'm including on my page registering these things? Because even just including one may have much higher cost than you may expect. And then finally, you probably want to start experimenting with Performance Observer, at least checking if it's there and leveraging where possible, because that'll allow you to eliminate a lot of this extra polling work. So moving on, animation. This is a big use case that we found. Perhaps you may not think of it as animation, but this has come up in animation because it overlaps with scrolling and animation a lot of other use cases, which is visibility. We have this concept of visibility, right? And there's a lot of best practices that we craft around some concept of visibility, where we say, look, we have these long pages, but not everything is important in the sense that some content is visible, and you may want to prioritize it. So maybe that's fetching, maybe that's rendering, maybe it's doing some other work. There is things like the lazy loading and infinite scrolling, which depend on knowing the position on the page. Then finally, there's analytics. I want to know if a certain thing was seen and how long it was seen for, and other use cases. And this is very, very common. We've certainly had many discussions around this topic on the Web Performance Working Group, but we never really had a good solution for it. We're just kind of collating all these use cases. And really, what it boils down to is the core use case here is the developer wants to say, I want to know when this particular element or section of the page intersects with the browser, with the visual viewport, if you will. And if we think about the properties of such an interface, right, if it was to exist, then we would like it to be simple and easy to use, because that's certainly not the case today. If you want to do viewability sort of patterns today, it is possible. Many people have built them, but it's actually very, very hard and tricky. And oftentimes, it comes with a very egregious cost in terms of performance, because you have to listen to scrolls and everything else. And all the things we just talked about, you're doing all of them. So you're pretty much guaranteed to be on a slow path some fraction of the time. So we want great performance, obviously. Another one is we probably want to be expressed as a passive query. This is actually a common thread that I think you're going to start to see here, which is instead of polling and asking, we want you to just express what you want to know, and we will notify you. And this interface also allows us to then delay the delivery or schedule the delivery of such events into appropriate time blocks where you're not interfering with other critical work. So because we're very inventive with our names, we call it Intersection Observer. And this is another API that's currently being implemented and being discussed. And the idea here is pretty simple. As the name implies, you have an observer. You can give it an element. So here I'm using a document query selector. I'm just passing it an element. The root bounds modifier is a funny name, but really what it's saying is you can actually define a margin. So if you think of that green block on the right in the diagram, there's the red blocks, which effectively say the margin. So I can express things like, I would like to know when this thing is 1.5 or half or whatever viewports away, which is quite nice, because if you're building something like, say, a lazy loading section, you could actually say, well, I don't want to start loading the assets when that section becomes visible. I would like to start preloading them sometime before, and such that those resources are actually done by the time the user sees them. So you can play with this, and we definitely welcome your feedback, because there's a lot of different use cases that I think this would make much, much more efficient. So take a look at the spec. There is bugs for implementation open on Chrome, and I'm hoping to see it come soon, because it'll certainly be very helpful. Now, another funny thing I noticed, so as I'm watching the presentations this morning, I think I've figured out Paul's master plan. So a couple of summits ago, or maybe at last summit, we started talking about the request animation frame that you have 16 milliseconds to do all your work. Then when Paul wrote his rendering course, he actually changed that number to 10 milliseconds. So now we have only 10 milliseconds to do this work. And then finally today in his presentations, he's lowered the number again to 8 milliseconds. So I think his master plan is to just keep lowering it. It's kind of like gradually increase the temperature or decrease the temperature. But at which point, at some like Chrome Summit 2020, it'll just like 0. You're not allowed to execute rafts at all, right? And that's it. But more seriously, this actually does get to an important point, which is how much work can you do in 16 milliseconds? And why is it that we say 10 milliseconds, 8 milliseconds, and you'll hear 5 milliseconds thrown around? And the answer is, frankly, because there's just such high variability in the CPUs and the GPUs and all the rest. So what runs efficiently on your particular hardware may run slowly somewhere else, right? And there's other subjects or other criteria that may change this. So we're now actually seeing devices that have small and big cores. So your application may migrate between a small core, which is a slower core, and a big core, just based on what's the temperature, what's the battery, what's the other environment factors around you. So it's really quite unpredictable. And the important part here is it's actually an unknowable answer, right? Like I cannot tell you how much work you can execute, even if you ask me right before, because there are other things that may kick in. The operating system may deschedule us, and another application may want to run. So it's really hard to reason about. And what you end up with is a picture that looks something like this, right? We have different rafts. These are just different scenarios, right? Where we execute some of our code, and then the browser has to do some work. And depending on what kind of operations that you executed, the browser may have to do different amounts of work. So you may have invalidated a huge section of the page, which means we need to repaint and do some other expensive operations. Or maybe you touched something that's very efficient, and it's all very quick. And if everything runs nice, and if you follow Paul's advice, and you say, great, I'll limit myself to 8 milliseconds, and then I'll be very careful about the kinds of operations that are being executed, everything will finish quickly, right? And then I know I'm guaranteed, pretty much, that I'll get my smooth and solid 60 FPS all the way out. Except there's another problem here, right? Like now we have this unused time. So really, we're leaving this time on the table. This is time that I could have spent perhaps making my applications better, because I could execute better animations and do more work, right? Like if I'm running a spell checker, I could actually do more work and provide a better service to my user. So we kind of have this odd trade-off, right? And there's no one number that really makes sense. So one question to ask here is like, how do you even know when you're missing frames out in the wild? When we deploy the applications today, we have pretty good tooling for getting data on the network performance. But we don't have any way to gather data on the animation part. And that's what frame timing is all about. Effectively, what we're doing here is we're exposing this concept of a frame, which is loosely the time between the two vsyncs in the browser. And we want to capture that and deliver that when we exceed that budget, such that you can subscribe to it and get that back to your developers, right? This is the important part here is we're not exactly telling you why you're slow. This is the kind of data that you would get in DevTools. We're just telling you you're slow, such that you can identify that in some part of the world, when the temperature is really high, you are actually missing wraps, right? Sounds kind of crazy, but that's what it is. And once again, you would use Performance Observer to get at this data. So you subscribe to the new frame type, and periodically you would just get these events that would give you the duration of the slow frame, such that you can aggregate it, you can run your own logic on it, you could even adapt to it if you wanted, because if you're consistently getting these slow frames, perhaps you want to throttle your canvas or your something else and run it at a slower refresh rate. So this is could be both a runtime optimization and also just beacon it back to analytics such that I can understand why and where this problem is happening. So I think this will be very useful. So some takeaways here. Intersection Observer, I think this is going to be a very powerful and a very big feature for many different applications. So I strongly encourage you to take a look at the explainer and give us feedback. This is the right time to give us feedback. And then finally, frame timing API will definitely help as well for identifying animation. Idle is something that we've already kind of talked about a little bit. So let's dive a little bit deeper. This is that earlier problem that I surfaced, right? We execute our work in some limited amount of time because we said we're going to fix it to 8 milliseconds or less. There's some unknown entity of time that the browser will take to do its work, and it's really hard to reason about what amount of time that will actually take, right? Like if you constrain yourself to some fast operations, you can kind of guarantee that you're not going to go like really expensive, but it's still hard to reason about. But then there's that chunk of time left at the end, right? And the better performance you want to get, the more of that chunk is going to be left there, which is kind of unfortunate because we'd like to make use of it. Like this is a lot of time that just being left idle. So we have this new API, request idle callback, and Paul already talked about it, so I'm not going to go into a great deal, but effectively it allows you to move some or all of your work that is not critical to the actual rendering out of your wraps and other logic and into these idle blocks, where you know that you're not going to then blow the budget as long as you stay within the provided deadline. So this is the kind of thing where you want to be very accurate or very precise about how much time I have left and make sure that you don't overrun. Because if you do, then we're going to miss a frame, right? So this is definitely the kind of thing you want to avoid. And Paul has a great write-up with a number of different use cases for how to use it, where to use it, and all the rest. So I encourage you to check that out and experiment with it. This is already available in Chrome. You can start leveraging it, and I'm hoping to see it in other browsers soon as well. So for response, move your non-critical work into idle callbacks. I think you've heard this theme. We're moving garbage collection, right? We're moving scheduling and delivery of these performance events into idle. And I think you're going to find that we're going to be moving more and more work into that, such that we unblock your application from doing the critical work that it needs to do to make everything nice and smooth. And then finally, load, right? This is something that, of course, we actually have pretty good tooling for already, but we're not ignoring it either. Yesterday, we learned a lot about some of the new and exciting architecture primitives that we're getting with Service Worker, and in particular, this idea that you can now take your entire critical path and move it onto the device itself, right? So instead of being at the mercy of the network and at the mercy of the RTT, you can take your HTML, your CSS, and JavaScript, the things you need to actually paint some pixels on the screen, put them right on the device. That's the app shell. And make that visible regardless of the network you're on, or whether you even have connectivity at all. So even if you're offline, you can paint those pixels and then put something like a loading spinner or something else to let them know that, hey, I'm fetching content. So I think this is very, very important. But of course, the next question is, I need to start the worker, right? That also takes some time. There's another thread running. There's maybe even many threads because we have many different service workers. So we'd like to know how long that takes. And you can actually measure this now. So we've added the worker start attribute to resource timing and navigation timing, which allows you to see if the worker was active, you'll be able to tell if it was active based on the timestamps, and also how long it took to start the worker if this request was blocked on starting the worker. So the difference between the worker start and a fetch start, if you're familiar with those specifications, would be the time to start the worker. Which is very handy. So this is already enabled in resource timing in Chrome, and we're working on adding this to navigation timing as well. So I think this will be critical for augmenting your existing ROM analytics once you enable service worker. And then similarly, you also need the same kind of tooling and capabilities within the worker itself, because now that you're scripting a lot of your fetches and other logic within service worker, you probably want to move some fraction of your RUM analytics to live in the worker as well. So for that, you need things like user timing, which allows you to specify custom metrics. So you can just put marks along the timeline, or measures, which any time span between 2 marks, and also get the same fidelity resource fetching data for things like how long did the TCP connection take, and the DNS, and all the other components of making the request. So this is now also enabled in Service Worker, and you can start using it. And an important point here is we have resource and user timing. There's also the navigation timing, which is specifically for the HTML document. But navigation timing is not enabled in Worker, because from a worker's perspective, every fetch is a resource fetch. Even a navigation request itself, like there's no difference, right? You get the same fetch event. So there are no plans to enable navigation timing, because everything looks like a resource fetch. So if you're wondering, that's why. And this is available in the Worker today. So if you're running Service Worker, definitely enable this. So worker start and resource and user timing. And with that, I think we're at the end. And thank you, guys.
Thanks for nothing, Ilya. There was I with my master plan, reducing the number, and you go, look, here's a big expose on his reducing the numbers. Thanks. Would have got away with it if it weren't for your meddling. Cheers.
Well, but the problem is you're taking small numbers and you're making them smaller. You are never going to get an applause behaving like that.
I actually have more faith in our team here than you do. Let's give it a try. 1 millisecond. Aha, you see?
I would say that was about 50% there.
We're not entertaining that idiot up front.
Well, it's lunchtime.
Yes. Food. That's good. It's gone really quickly this morning, hasn't it?
Yeah.
It's been great. Okay. Well, we also have breakouts starting in here at 1:30. There's Chrome DevTools. They'll be having a session focused on getting feedback about that, and that's at the front of the room.
And there's also Lovefield, which is be a session for the Lovefield SQL storage system that's backed by IndexedDB, and that'll be at the back of the room.
Okay, so food is out there. There's vegetarian, vegan, and gluten-free food, as well as the meaty stuff. So just check the labels to make sure it's right for you.
And same as yesterday, if you ask for a kosher meal, check in at the registration desk. So the breakouts are here at 1:30, and the talks resume at 2:30. Thank you very much.
So this is kind of weird, but especially as service workers and progressive web apps come online, I think like understanding your battery profile would be super helpful.
Thank you for joining us. Our program will continue in about 5 minutes.
Welcome back. How you doing? You all good? All right. Now you may be noticing that I'm on my own for this bit because Jake is off preparing for the leadership panel. But we're all good. Even though I don't have my safety Jake blanket. Our next speaker is known rather enigmatically as Surma. That's it. Just Surma. And when he was introduced at the Polymer Summit earlier this year, Matt McNulty noted that he's in good company. Cher, Madonna, Beyonce. What he didn't mention is that Surma makes outrageous demands before he's willing to get on stage. Jake and I are not allowed to make direct eye contact with him at any point. He can't be shown code indented with tabs or spaces. He demanded a bouquet of puppies in his dressing room. He demanded a dressing room. That was weird. But most importantly of all, he refuses to walk on stage unless people chant his name. So let's get that started. Surma, 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 Surma. He's coming. It's Surma.
Thanks, Paul. From Paul and Jake, or as I like to call them, Bald and Balding. He is right, though. He's right, though. My name is Surma. So, my name is Surma, and I work with the Google Chrome team in London, and I'm here today to get you guys excited about HTTP 2. So I know that this is a long day, and there has been great content being thrown at you by good-looking people. And so I thought I'd start with a TLDR, which is switch. There really is no way for you that this could perform worse than your current HTTP setup, your current HTTPS setup. So what I'm saying is basically, HTTP 2 is performance for free. So you just go ahead, enable it. And if you actually can justify it and put a little more effort into it, HTTP 2 offers even more levers for you to put even more optimization in there and get more performance out of your site. From now on, by the way, I'm going to call HTTP 2 H2 because that is A, the official symbol for the protocol. So even Chrome Inspector signifies HTTP 2 that way. And it's so much easier to say. So I hope you can accept that. As you've learned in the last 2 days, and especially today, performance matters. And as I said, there's a lot of features that are on top of H2 that give you more possibilities to optimize your website. And I'm using the generic term performance here because it can really be applied to a lot of different things that you have. It could be the time to first render. It could be the total load time of your page. All of these are more optimizable once you actually have H2 enabled. So hopefully with this, I got you interested enough to actually listen to me. And I want to start with a little history on how we ended up where we are today. So H1 is old, HTTP 1 that is. Tim Berners-Lee spec'd the first version, which is HTTP 0.9 in 1991. Just think about that. That is over 20 years ago. And this is what he originally had in mind. It is a simple document. You have text, you have a little bit of formatting going on, and you have links to other websites. And that is really what the H in HTTP stands for. It's hypertext. You have a web of documents. And this is allegedly one of the first, if not the first, website out there. And this is what the protocol was designed for. About 5 years later, HTTP 0.1 came to be. And it added basically a few headers, a little bit of meta information in a security protocol. So in HTTP 0.9, you had to get, post, and head. And in HTTP 1.0, put, delete, and our favorites, link and unlink, came to, which we all use daily, right? So these are more methods that added. Not all of them were obligatory, as you can tell. And that is basically what we stuck with until then. And then only a year later, HTTP 1.1 came, which is kind of weird to move that fast suddenly, but there were problems that had to be addressed. So HTTP 1.1 basically added the options method, which you needed to do like cross-origin communication. You had the host header, which was now obligatory because people started hosting the multiple websites on the same server. And you had more control over caching, but most interestingly, keep alive was added. And I say that is the most interesting part because websites now started to look like this. This is not really a document anymore, nor is it just hypertext. This is really just more like hypermedia. You have things, images, videos, sounds that refer to other things on the web as well. And if you look at the last 4 years alone, the total transfer size of a website has tripled in the last 4 years. And as I just said, HTTP is over 20 years old. And obviously, since we are kind of starting to abuse HTTP1 here, performance went down. It's really mediocre at that point. So people started saying that H1 had flaws, which is not really right. We were just abusing it for things it wasn't designed for. And so we came up with workarounds to address these problems and kind of kept it going up until this day. And these best practices, which are really workarounds, which are really hacks, were things like concatenation, sharding, spriting, caching, and vulcanizing, and all these kind of things that, for some reason, we have to do to not have an abysmal performance nowadays. And all of these hacks address problems, as I said, and the most notorious of these problems is head-of-line blocking. Head-of-line blocking is the phenomenon that when you send a request on a connection to a server, that connection is from now on useless until that point when the server has responded completely with a response. And originally, a browser was only allowed to have 2 concurrent connections to the same server. So you had 2 connections, on each of which you would put out a request. And you had to wait until one of these was finished until you could reuse the connection. So obviously, there's kind of a bottleneck there. And we realized that, and people started, OK, let's raise the limit. Let's go to 6 connections. And you can kind of realize 6 connections is not really enough again, and it just like postpones the problem a little bit. The Golang guys, or actually a lot of people, but the Golang guys wrote a great demo showing off this problem, where they tiled an image into 180 smaller tiles, included all of these tiles in a website with image tags, and just served it over HTTP1. And as you can maybe, hopefully, tell by this graph, first of all, you see the 6 connections and the 7th one to load JavaScript from another server. But you see the 6 connections, and there's a lot of like sparseness there. The connection is not really saturated at this point. So I also looked at the saturation graph. So you look at the green lines of both of these graphs, and you can see that with H1, there's almost no saturation whatsoever, and with H2, it's at least a lot better. Still not optimal, but a lot better. The second big flaw that we had, or that there is in HTTP1, is that headers repeat a lot across requests. The most notorious examples of headers that do repeat are user agent and cookies. Both of them are long and static, and they just keep being added to each and every request. That comes from the fact that HTTP used to be stateless, or is supposed to be stateless, each request being completely independent from the next. So people needed to work around that and started using sessions, and identified a session with a cookie, with a long UUID in that cookie. And each of these cookies would be appended to every request being sent over and over, which really is just a waste of bandwidth. Another minor part is that people started like, OK, I can compress my data, obviously. Like, I can just gzip everything that goes over the wire. But that would only apply to the actual data. The headers, which are still highly compressible, would still not be gzipped, and that's also just a missed opportunity. So at that point, people realized that we were not using HTTP1 for what it was designed for, and something else had to come up. So we started doing Speedy, and we tried out a few things and kept the stuff that was working. And on the basis of Speedy, HTTP2 was specified, and this is where the interesting part of this talk actually begins, because now we are at the glorious era of HTTP2. So the question, or the first scary things I want to address is, H2 has the same semantics as H1. So you still have request response. You still have headers, which are key value pairs. You still have a body, which can be any kind of content. So your apps will all be able to stay the same as they are right now. You don't have to touch the code at all. The only thing that's different is how these requests are going to be encoded on the wire. They're like wrapped differently on a binary level. The second scary part is that H2 is a protocol upgrade. So people might be thinking, how can I upgrade? Am I going to lose clients? No, you don't, because every connection starts out as H1, and then it's an upgrade to H2. And if this client doesn't support H2, it will just stay on H1, and everything will work as before. So, but what is H2 really? First of all, it's a single TLS encrypted connection. So technically, in the spec, there is a protocol called H2C, which is the clear text version of H2. But most browsers have actually opted out of implementing that. So there's really no way for you to get around the TLS part of this. But we had a talk of Emily yesterday, I think. And we have services like Cloudflare and Let's Encrypt, which is going to go in open beta on December 8th. So it should be really easy for you to set up TLS at this point. And yes, I said it's a single connection because head-of-line blocking, the issue of having only 6 connections, is being addressed on a protocol level. So we can actually work with a single connection. The stream, the connection itself, actually looks like this. What used to be a request-response pair in HTTP 1 is now a logical stream. That's what it's called. And all streams actually share this connection. They're multiplexed onto the single connection and share the bandwidth of the single connection. And head-of-line blocking is not a thing anymore because these streams are being chopped into frames and put onto the connection. And that means that if one stream goes into the blocking state where it's waiting for a response or for the client to push more data to put on the wire, another stream can take over and utilize the connection fully. So you can see how this will actually solve the head-of-line blocking thing. Actually, an additional feature is that the client can specify dependencies and waits for each of these streams so that it can say stuff like, this stream is only useful if the other stream has already completed, and that the bandwidth, the weights are there to distribute the bandwidth more appropriately for the application that you are doing. However, this feature is on the client side only right now. It's not been exposed to the server side just yet, but it is being considered. So as I said, it's split into frames, or chopped into frames. And there's multiple frame types, but the most important ones are header frames and data frames. So as I said before, we had headers as key value pairs of strings, and we had data, which could be whatever you need. So it kind of makes sense to split these apart because they have different content types, right? So this is what's actually been happening, so that the stream now actually looks like this, that you have frames of data and header data being on the wire. And remember that all of this is end-to-end encrypted because TLS is enabled. And there's a lot of things new in H2, and I'm going to address most of them. But this feature alone, having no head-of-line blocking and a single connection that does multiplexing, actually invalidates a lot of the best practices that we already know and had to do. All of these best practices here, like concatenation, inlining, vulcanizing, and spriting, were there to reduce the number of requests and to get more out of a single request. It had also a very bad side effect that it made caching really inefficient, because if you think about, you would have a lot of icons on a website and you would sprite them into a big image. Changing a single icon would invalidate the entire sprited image, and you would have to re-download it all over again. And now requests are cheap, and you can just leave the tiny images on the server and have them cached individually. So here's a demo of the tiled image that I showed earlier. And one of the videos is H2, and one of the videos is H1, and it's your guess which is which. And just keep in mind, there's no feature being used here except the fact that head-of-line blocking is gone. All that's happening here is a static website being delivered over H2 with 30 milliseconds emulated latency and a 3G emulated network bandwidth, so to speak. And yes, cache is being busted. So you can see the impact of this feature alone is already huge. To visualize this a little bit more, these are the waterfall graphs. And you can see that H2 is much, much steeper, which is because on the left side, we have the limit of 6 connections. On the right side, we don't. So you can see that we always have this chunk of 6s with indentation. On the right side, we don't really. So H2 is much likely to saturate the connection, the available bandwidth that you have. So the question really is, how does this feature of having a single connection without head-of-line blocking, how does this translate into real life? And luckily, Financial Times did an actual live test where they moved their static assets to an H2-enabled CDN of Akamai, and they kind of segmented their clients into 3 groups. The clients that didn't support H2, the clients that did support H2 but didn't use it, and the clients that did support H2 and did use it. And as you can tell by the graph, that this alone, just moving the static assets to a CDN with H2, has a great impact for the amount of time it takes to get to the mobile load event. To get back to the split frame types of header data and of header frames and data frames, this is a great opportunity because now, since they're separate from the data, we can actually compress headers now. And not only that, they actually came up with a compression specific for HTTP headers. And since it's glorious and new, it gets stars. HPAC, which is the compression for headers, defines the notion of the compressor and decompressor, which is pretty normal for a compression. But the interesting thing is that these compressor and decompressors work on the connection rather than on each of the streams. So you have one instance, and all the requests go through the same instance, which gives us the ability to actually back-reference header values that have been used in previous requests while compressing the current request. So I want to go into this a little bit more. So we send out a request to example.org and want to get the index.html. And the compression works just like gzip, is a Huffman encoding kind of. And additionally, it has a lookup table. So it just has the first 62 entries of that lookup table have been extracted from the most popular websites that are out there, and the requests that they get, obviously. And also, pseudo headers have been added to accommodate things like the method and the path, which are technically speaking not headers, but should also be compressed. And what happens is that the compressor goes to the lookup table and tries to find the values that are in the request. So as you can see, the method get is in the table. The /index.html path is in the table. The header key host is in the table. And only the value is not. And so what happens is that it's actually being encoded as a few bytes indexes in the table, and then just a gzip of the string example.org. The interesting thing now is that after this has been completely transferred over to the server, the values that weren't in the table are being added to the dynamic part of the table, which starts at index 62. So now we actually have host example.org in the table. That means once we set out the next request, and this time we want to post to /something, we can reuse the table and don't have to re-encode example.org. However, in this case, /something is new, so that's going to be gzipped and going to be able to be tabled afterwards just as well. And the nice thing about this is, this works completely transparently. There's nothing you need to do. Once you enable H2, this just happens. You will reap the benefits of having less data over the wire just by switching. You don't need to change your app. You don't need to have some kind of configuration magic going on. And that is really something you should keep in mind. And again, just by having one single new feature, a lot of best practices that we have actually become invalid or actually counterproductive. So as I said, you have this notion of a shared compressor and a decompressor. So having multiple connections is actually bad for you. So you still want to do CDNs, obviously, because you want to be geographically close to your clients. But you want to keep the number of origins as low as possible to exploit the fact of the shared compressor as much as possible. So the same thing goes for sharding. It's the same notion. You don't want to do multiple connections. And also, non-changing cookies are actually highly compressible now. So what used to be kind of an anti-pattern of encoding session data into cookies could actually become viable now because it's so highly compressible. Up until this point, everything works the same. That's what I mean. You can just switch and reap all the benefits that I was talking about. There's nothing you need to do. But as I also said, there is features which you can exploit when you change your app a little bit, and it gives you more room to improve your website in terms of performance. Probably the best known feature of HTTP 2 is push. And it is not to be confused with a web push notification API. Push is a technology or something of the protocol that allows you to respond to a request that hasn't even been sent yet. And what that means is that if I request index.html off of a server, the server could be like, OK, here's your index.html. He's obviously going to answer. But then the server can go and be, OK, you got index.html, but I'm pretty sure you're also going to need style CSS and script.js, so here you go as well with those. And those are called push promise frames. And once the client is done parsing, the index.html actually is aware of the fact that he needs style CSS and script.js, it's already in its cache, and the request will never go out to the network. And Eric Beidelman took a Polymer app, removed concatenation and vulcanization, and then added push to it, where he pushed all the resources that he needed, and saw a 60% improvement in load time for the app. So a client is also able to cancel a push if the client is sure it doesn't need it, but still be careful in what you push, because pushing mindlessly can also have a negative impact. So it's something where best practices still really have to arrive on what is good to push and what is not good to push. So as you can tell, H2 does a lot for you. But there's still things that you as a developer need to take care of. So like setting sensible cache control headers, reducing the number of origins and therefore DNS lookups, taking care of a good first render, which we have had talks about. And most importantly, actually, compression. Compression, just like H2, is performance for free. Just have gzip enabled on your server. You don't need to upload gzipped files. It's something your web server does for you. Compression on the fly. Because at this point, almost half of HTML, a third of CSS, and a quarter of JavaScript are still being sent uncompressed over the wire, which is just a wasted opportunity. And as you can see, I'm emulating a 56 kilobit connection here, admittedly, but the performance impact is huge just by enabling gzip. Actually, compression used to be enforced by Speedy, but they removed that because it doesn't make sense on every type of content. JPEGs and movies, for example, are already highly compressed, so it's just wasted CPU cycles to compress those with gzip all over again. So it is your responsibility to do that, to enable gzip. So I guess at this point, the question, the most interesting question really is, should you do it now? When can you start? How do you get H2 onto your development machine, onto your production environment? Ironically, at this time, the browsers are actually ahead of the servers for once. All the major browsers support H2, and CanIU says there's full support. That is technically not true, because stream weights and stream dependencies are not well supported, at least not consistently, but HPAG and the multiplexing protocol itself is supported across the board, and you can be sure to use it. And then there's still the upgrade feature that if for some reason the browser doesn't support it, it's just going to stay on H1. On the server side, at least very recently, a lot of the famous servers have merged or started working on an H2 implementation. Google Cloud Platform is actually pretty interesting, because the second you enable TLS on your project, everything will work over H2. And some of these servers, and GCP is one of them, actually allow you to specify pushes by setting a link header in your response. In terms of languages, most languages are working on implementation. Most of them actually have an implementation for HTTP2, but they're not necessarily complete. For example, the Go implementation is really good. It's really high quality, but the push feature is not exposed to the user just yet. If you're wondering if your language of choice actually has a library, there is a curated list by the HTTP2 guys, which you can just load up and look for a language and look at the libraries that there are. If you just want to play around, however, I wrote a tool for you, which I called Simple HTTP2 Server. And it is basically the same thing as Python's Simple HTTP Server. It just serves the current directory over HTTP2, right? So this is just the same, just with HTTP2. So you can just download a binary. I have binaries for all major platforms. And when you start the server, it will generate a certificate for you, a self-signed one, so you don't have to worry about it, because TLS is the thing, right? And once you go to the actual URL of the directory, you will see the contents or the index.html, and it will be given to you over H2. But just keep in mind that this is not a production server. This is really for playing around locally and seeing the benefits of switching. So if you're interested in that, go to the Google Chrome org on GitHub and get the Simple HTTP2 servers. The binaries are in the release section, and you can just download one single binary. It does everything for you. Talking of production environments, though, I see different levels of commitment to H2 right now, and they involve different levels of effort for you to put in it to actually do the switch. The simplest part, or the easiest way to do it right now, is the same thing that the Financial Times did, which is move all your static assets to an H2-enabled CDN, because the biggest number of requests for a website are for assets. So removing head-of-line blocking just for them will already give you a great benefit. Exactly, and just so we will see here on the slide that the green arrow is supposed to be HTTP2, and your API would still be over HTTP1. So one impact would be, for example, again, the image, where you over 3D reduce the load time from 8.4 seconds to 1.8 seconds, which is huge, but obviously this is a test case that is tailored towards showing off the issue of head-of-line blocking. So if we look at a more realistic case, and in this case I chose the Material Design Lite website, the impact in how much faster it loads is pretty negligible, but in terms of how much data is transferred, we actually save 10% of data, which on mobile can be huge, especially it adds up, right? So as always, measure the impact so you know if it's actually worth your time. Tier 2 commitment to H2 I would see as having an H2-enabled reverse proxy in front of your current app. Basically, Cloudflare is doing this right now, but Cloudflare is using Speedy, but it has the same kind of benefits. It basically removes head-of-line blocking and does the header compression for you. And head-of-line, that works because from backend to backend, you don't have the limit of just using 6 connections. So this would basically speed up your app and give you a better opportunity to do the caching on the side of the client. And then, obviously, the full tier commitment would be doing a full H2 deployment. You use push, you use waits, you have everything set up. But as I said, it's probably unrealistic to do this at this point due to the lacking server support. So to end this, I kind of want to take a quick look at the future of H2. Static hosters like Google Cloud Storage or GitHub Pages don't give you a way to specify what resources to push when somebody requests index.html, right? So Eric Bidelman, Alex Warren, and I have been working on a manifest format that allows you to specify just that. And Eric and Alex also wrote libraries to consume these manifests when you write an app on App Engine in Python or Go. So the manifest looks like this, where you actually say, for the index.html, I would like to push the app.css, and for the page.html, I would like to push page.css. And you can define as many resources as you would like to. And as you can tell, it's just straight up JSON. And as I also told you, we are working on libraries in different languages to consume these on App Engine. And also, additionally, Eric wrote an npm package that generates these manifests for you by analyzing your HTML files, which is kind of nice because that means it's just another build step instead of you maintaining these manifests manually. At some point, I would like to see support for more hosts to adapt these manifests, but we just came up with it, so it's too early to tell. WebSockets might not be a thing anymore. I mean, they still work, just as before, but they are a separate protocol and therefore a separate connection. They're not being multiplexed over the H2 connection because separate protocol. So it might actually be suboptimal for you to use. And since long polling is now really fine again in H2 because you are not wasting one of your precious 6 connections, you can pretty much emulate the same behavior over a pure H2 connection instead of using WebSockets. Time will tell if this is actually true or not. To summarize this entire thing, should you do it now? Yes, do it. Why? Because performance matters. HTTP2 really will give you benefits just by switching it on and not caring about it anymore. And when you're doing that, also enable compression. It's a wasted opportunity not to do this. It's almost gross negligence. So I think everybody should just switching over, be a good citizen of the internet. How to enable it? It really depends on your current setup. It really depends on how much time you can put into it and how much you really care. But in the end, if you take one thing away, look into your current setup if it is viable for you to switch, and if so, do it. And if you have any questions about this or concerns, or you want to keep shouting my name, which is fine as well, I'll be around, or you can hit me up on Twitter. And with that, thank you for your attention.
I'm not looking, I'm not making eye contact, it's fine. Okay, so you've heard a bunch from us here at Google over the past couple of days, but we wanted to bring you a different perspective on progressive web apps. And we were thrilled to hear that Flipkart was shipping one, and so we asked them to come and tell us all about it. So please welcome to the stage to talk about building and deploying a progressive web app at scale. It's Flipkart's Amar Nagaram, Abhinav Rastogi, and Jai Santosh.
Okay. Good afternoon, everyone. We are excited to be in this conference. In fact, this is one of the best conferences we've ever been to. Not many times your work gets showcased in the keynote. And to add to it, incredible audience. I mean, everybody we ran into yesterday and today had so much stuff to tell us about Flipkart Lite, all the positive feedback we got. Thank you so much. We're really honored to be here. In fact, there was so much stuff on Twitter. We were actually spending all night to go through all that stuff. There's so much stuff going on, and especially the feedback, right? I mean, this is just the beginning. There's a long way for us to go, and a lot of feedback we were getting. It's incredible. But truth be told, it wasn't an easy journey for us till here. As many of you know, beginning of this year, we shut down our mobile site. And we kind of actually committed to one thing, and one thing only, and that was like we wanted to give the best experience on mobile to our users. The challenge is to actually make this happen in a country like India. Tal, from her talk yesterday, was giving out some astonishing numbers about emerging markets and India in particular. Like a typical device in India is at least 6 times inferior to a normal device you would find here in terms of memory, CPU, storage. On top of it, you have 87% of your internet users on 2G network. If you actually kind of put this together, it's almost impossible to give a compelling experience on a mobile device. And we have one more challenge on top of it. We are an e-commerce application. Users don't come to e-commerce application every day. So when they come to you, you better be getting their attention. You cannot afford to throw dinosaurs at them. This really got us started on a completely different journey, a journey that we have never taken before. In fact, it was such a soul-searching journey for us. We ended up with an awesome product that we are very, very proud of. In fact, we are so proud of it, I would not miss an opportunity to show it every time. Like, in fact, I was showing it to a lot of you guys yesterday whenever I ran into you guys, and I'm going to do it one more time. I'm going to show a video of how Flipkart Lite actually works. So, okay. There you go. So you fire it off from the home page, just like an A2 page. There's a splash screen. You slide up the categories. Look at how fluid the animations are, everything that expands. This is actually a live app. I mean, you're looking at a live e-commerce app. Look at how fast the products are loading in the search page. And this is actually coming from our 30 million product catalog. The product page almost loaded instantaneously. I mean, all of this actually happened in a matter of 2 to 3 seconds. This is incredible. In fact, what I'm going to show you next is the most useful feature that we built in Flipkart Lite. We just switched to offline mode and see what happened to the app. It is visually different to the user. It's no longer showing the dinosaurs. The user is still able to do whatever he did in the last session. In fact, if you look at all of these products, everything is grayed out except the product he was actually browsing last time. So this is the offline experience on Flipkart Lite. There you go, online, and it's back up. So how do you get this? You go to flipkart.com on the latest Chrome or Opera browsers on your Android device, add it to your home screen, and boom. You don't have to install it or anything. That's it. I actually have a funny story to share here. When we were actually working on this internally, not many people in Flipkart actually knew about it. So when I was actually showing this demo to our leaders and all of the other Flipsters, I was actually showing them, hey, so yeah, we call ourselves Flipsters. I was actually telling them, hey, here's a Lite app that we are working on. What do you think? Oh, it's cool. It's fast. It's light. Yeah. How do I get it? I don't see it on the Play Store. Oh, you won't get it on Play Store. You just have to go to browser and type in the URL. And this is after we shut down our mobile site. So everybody's jaws dropped. Oh, this is incredible. So yeah, I mean, we've had an exciting journey in coming up to where we are today. But we sincerely believe behind every product there is an incredible team to make this happen. And this product was no different. It was 5 engineers, 42 days, and we got it. In fact, I'm going to ask a couple of those engineers to come up on stage today to talk about what really happened in those 42 days. I mean, I know I was getting requests for too many Red Bulls, but a lot more happened than Red Bull. So I'm going to actually ask Jay to come up first, take us through what really happened, and hey. Thank you.
Good afternoon, everyone. I'm Jay Santosh. I'm part of the Flipkart team. I work as a UI engineer there. So we are incredibly excited to take you through what our journey was, what our experiences were when we were building this Flipkart Lite app. So before we shut down our old mobile website, this is how the rough flow of the application was. So the browser fires a request to the web server, which in turn calls other API services, gets the data. It sends back a very fat HTML, and then from the CDN we load further assets. This approach actually worked for Node.js browsers that we had. If you see, like back in India, we had like about 60% that was coming from Node.js browsers. Supporting all of that was difficult and all that. But we wanted to ensure that we wanted to give a very good experience. But the page load times in this approach really suffered a lot. So we had to trash this approach out. So what we changed now, so we thought probably once the application is loaded, we can actually do a nice client-side application whenever like on the client side. So for the first page load, you actually contact the web server, get the HTML bootstrap shell, which loads up your single page application. Then we went ahead and added something called service workers. So this acted as a proxy for further requests to API or push API or CDN. So we cached whatever we could, and boom, this gave us a lot of advantage. So a little more on the client side, what we did, we used React to build a single page application, navigating through the various pages with React Router. We also built a lightweight Flux implementation for fetching data for our application. So we built something called frontend.js. So the GitHub link for the library is available in Flipkart/frontend. Yeah, but still, the first pain time still suffered because we had to load up fully the single-page application so that it's interactable for the user. It still took a lot of time. So what we wanted to do was enter HTML page shells. How many of you, I think through the Dev Summit, you've heard a lot about what page shells are, what you can do. So we just go into a little more detail about what we did for rendering our HTML page shells. So we divided our application into two states. One is the loading state, which is before you even fetch the data, you know what your state can be. So that is what we call as the loading state. Then the rest of the application moves on to the loaded state, which is after you fetch all the data that you need. So a typical loading state would look something like this. So this actually, you can actually give the user visual cues into how the application will look like once the data is fetched. So you can actually render whatever you need upfront and before, much easily than only rendering after you fetch all the data. So if we move on. How did we achieve these HTML page shells? One thing that we wanted to do was minimize the server processing time as much as possible. So that meant we wanted to generate these HTML page shells upfront during build time itself. So whatever JS, CSS images that you write for your application, we ran it through Webpack. We generated bundles. So once these bundles are generated, we process them through another render cycle, which allowed you to generate the final HTML page shells that you wanted in the loading state. Because you can predict what the loading state can be for each of your pages, and you can generate them at build time. To give a little more idea into what we call as pages in a single page application is, I mean, you have a lot of like logical pages in your application, and each of these can be generated as a static page shell for you to load them really fast. So this is now the new state of the application that changed. So during the first page load, you actually, when you load up your single page app, to load it, you first make server request, get the HTML page shell back. And this is something with like very less processing time on your web server. I mean, this is not like generated at runtime. So it's like we were able to optimize a lot on that front. So once you get the page shell back on the document, it's ready for rendering because you have all the HTML that you need to put the loading state on the browser. And you also have to fetch the data now to fully render the application. So we utilized service workers. We also utilized service worker to, once it's installed, we were able to fetch the rest of the page shells that are there in that single page application. Because what you loaded upfront was only the first page of your single page application, right? We also used service workers extensively to fetch all our data endpoints, data from our endpoints. So we, if you see the code a little, you have like the API endpoints that we call. We kind of went with cache first strategy. So you can see for most of them, we have like what is the sw.fastest in our configuration for Toolbox to fetch the data. But yeah, for fetching all the static assets, etc., we use like cache first. Just to reiterate what cacheable HTML page shells are like, your page components are rendered in the loading state upfront when you load the HTML immediately with all the critical CSS in line so that it will allow us, we thought it will allow us to get to the first paint time really fast. So once you load this loading state, now you have to fetch the data, or you can also utilize whatever data you had pre-fetched using service workers and re-render your application. This is one thing that I want to bring to your notice, that in this kind of an execution, you can actually have partial re-renders compared to native world. You can, so whenever you need to change something on the screen, you need to re-render every pixel of it. So everything on your page on the native app. But here you can actually have partial re-renders possible. Since we were using React, it allowed us to do so. Another thing is we get too excited about page shells. We could go ahead and generate lots and lots of page shells. If your application is like really complex, you could end up with a lot of page shells, which when you're prefetching after your service worker is installed, it might consume a lot of bandwidth for the user. So what we thought of was maybe this is not the right approach. So what we did was, if we analyzed our product, we went back. We analyzed like what are the product flows. So there are, if you look at our e-commerce product, there is a phase where the user browses from the home page, searches for a product, goes onto the product page, and then goes onto the checkout phase, and then completes the payment flow. There is another flow called the order management flow, where he can manage his order, like returns and cancellations of his products. We also have like an account management flow for the user. If you analyze these flows, they are not really like very interconnected. They are like, you can kind of say they are mutually exclusive. So there is not a lot of back and forth between these flows. So what we did was we broke our application down into these product flows, which are mutually exclusive. And instead of going with a one big monolith single page app, what we did was, we broke it down into smaller single page apps. So that way, what it allowed us to do is we were able to build and deploy this separately. We separated out the set of servers that these are deployed on. And this gave us much more freedom into pushing whatever effects to only one set of servers and not all of them at the same time. Since we bundled them separately, we also decided that since all of the single page applications behave in the same way, there is a possibility to share whatever common libraries and utilities that you have. Like for example, our front-end JS implementation, the React library, we were able to make it all common for all the applications. And what was needed to make it work as a, and it almost made the whole application work as a kind of a big single page app. So what was SW Toolbox has this another wonderful thing, which is like it supports Express.js style routes. So yeah, so you can actually model your application, and you can put in logic in your service worker code to manage your routes of your product flows in such a way that you can actually, whenever you needed an app-to-app navigation of all your single-page apps, it meant you only need to download app-specific files, because you can actually, because we had already prefetched and pre-cached the common libraries that were needed for loading the single-page application. So the results of what we did here is like we actually tested on a 3G connection first, and after the page load, this was the timeline that we could achieve. So we could actually get to the first paint in like 30 milliseconds time, and that was something phenomenal. And this way, we then went ahead and tested it on 2G. And voila, the results didn't change. We were able to achieve the same first paint times as that was possible in a faster connection in 3G or Wi-Fi. So this was really made us really happy, and this is where the power of service workers comes in for you, where even in flaky networks you can actually load an application state for the users upfront with really faster times. So I'll go ahead and hand over to Abhinav. He's my fellow teammate. He'll walk you across the rest of the journey that we had. Thank you.
Thank you. Hello, everyone. As they introduced me, my name is Abhinav Rastogi. I'm a UI engineer at Flipkart in the same team. So yeah, I think we established yesterday that you guys are pretty comfortable with British accents. Let's see how it goes with Indian accents. We'll find out. All right. So the first thing I want to talk about is the Add to Home Screen feature and how we utilize it. So it is a very important feature, when you are a progressive web app, and especially for an e-commerce channel like Flipkart. It becomes very important to re-engage the user very easily with very less friction. So when we went native only, when we were only apps, the app installs were a very important metric for us at all times. How many people are installing it? What's the current active user base? The same thing happened when we went as a progressive web app. The Add to Home Screen tends to be, at least it seems, it is an important metric, because people who come from the home screen tend to be, it's easier to convert those users. So Add to Home Screen, as we discussed, as it was being discussed yesterday, has a certain heuristic that the browser implements before it allows the website to show a pop-up to the native browser pop-up to Add to Home Screen, which, for a very good reason, doesn't happen on the first time. Now, when a user lands on our website, Add to Home Screen is something that is a very new feature, and especially for an audience like the Indian audience, we realize we may need to train the users of what this feature is and what are the benefits. So for that, what we did was we created a first-time user experience which trains the user what Add to Home Screen brings to the table for him. So let me show you a quick demo of what kind of an experience we built. So this is a loading state, and this is the experience that we built. We give a brief explanation of what Flipkart brings to the web, and we tell the user that it's just a tap away, and this is what you get when you add to the home screen. And it's dismissible, and you continue using the website like you would. And it's only for the first visit, where anyway the Add to Home Screen native pop-up will not show up in any case. But going further, we again need to prompt the user, not prompt, but we need to give some way to the user to add to home screen whenever he wishes to do so. For that, this is what we did. we added a small add to home screen button at the corner, which again guides the user of how he can add to home screen manually. So if you look at it carefully, to get his attention to the icon, and again, this happens only once or twice in the first few visits, we shake the icon a little bit, and we also tap into the hardware access that we have, and we trigger a navigator vibration, which immediately brings the attention to something that is shaking on the screen. So the next thing I want to talk about is the splash screen. Now again, this is a very cool new feature which makes it very difficult for a layman to distinguish between a web app and a native app. So what happens is when you add your manifest, you add your theme colors, and you add your icons and text, your splash screen shows up. Well and good. Another thing, what we saw after this is that the splash screen shows up, which prevents the user from seeing a blank page. You immediately see a splash screen and you go to the application. What happens after this is some of our data is still loading, at least on our home page, right? So we added another layer, we added another splash screens, you could say, or a loading state for our home page, which triggers for both when you launch from the home screen or when you directly open from the browser. And as you will notice, I will just play this. This is the native apps load this, and this is what we added over that. So we tried to reuse the same experience, but add a loader over that. And when it fades out, the experience is ready to use. This gives a very seamless experience to the user. There's no jank, there's no jumping of content as it loads, or things like that. Another thing we talked about yesterday was the custom navigation UI. So Alex pointed out yesterday that you need to have you need to provide the user with some way of navigating, right? So when you go to full screen, you lose the browser traits that are there, and the browser brings some very useful features to the table. It brings the ability to go back for a user, to refresh, to go to the home, to go to your home page, and things like that. So when we go full screen, we need to build this, and this is exactly what we added. So as you navigate across the app, we have a dynamic header which adds the back buttons and home and search and things like that, right? And it's dynamic. Now we can customize it. So across different pages, it behaves differently. So if you load a modal, the same header can show a close button and things like that. Now, as we've been talking about service workers quite a lot, right? So let me also add a little more to it. So the next thing we built was a rich offline experience. Some examples that we saw so far are that if you go offline, instead of showing a dinosaur, one thing we can do is show a custom error page, which at least tells the user that we know what happened, that something went wrong, we are not able to access the internet. We went a step ahead, and as we showed you in the demo earlier also, we built an experience that is delightful to experience. So as you will see here, when you go offline, now we are just going to airplane mode to demo that. We changed the color scheme of the application, which guides the user without any annoying pop-ups or modals or popovers and things like that, or consistent banners that you're offline, like in-your-face error messages. We avoid that, and instead we give a delightful experience no matter what the situation is. The next thing I would like to talk about is what we did with some hardware APIs. Now that we have good access to really good hardware APIs, the first thing we decided to do was try out geolocation, which gives us a very easy win. We are just one tap away for the user's permission to access his location, and we are able to accurately and easily predict how much time can we get a product to his doorstep. Just makes it very easy and delightful for the customer. Another thing we did was added an Easter egg. So the API that we used here, just to give you a hint, is the accelerometer API. I won't tell you what the Easter egg is, but I will tell you how to trigger it. On the home page, you can simply tap the logo twice, and you should see something happening based on the accelerometer data. You can try it out at flipkart.com. Now, while we are doing all this, we needed to make sure that we always made sure that performance was always the first benchmark, the most important feature of our application. Yes, we treated performance as a feature and not a side effect. So we have been talking since morning about Rail, right? And it really does help. If you follow these principles, it really does work. The one that I won't go into the detail of all 4, but one that I want to talk about is the animations. And yes, since I'm talking about animation, I had to animate that. So the animation part of Rail says that you have to render each frame in under 16 milliseconds, right? So as some of you might know, there is a project called Project Ganesh, which also is the name of an Indian god. But this is something that allows rasterization to happen on the GPU. What this brings to the table is a lot of performance benefits plus a lot of benefits in terms of power consumption, right? So you enable it, we enabled it using some hacks like a meta tag, which enables GPU rasterization for us. And it gave us huge amounts of performance benefits. But there are a lot of gotchas there, right? It's not just easy sailing all the way. One thing that we figured, I will give you one example. One thing that we figured was that animating SVGs is costly, right? So we figured that SVGs are actually vectors, right? And rasterizing them on GPU gets quite costly sometimes. And it goes into a specific rendering mode, which currently with the current technology didn't give us equal performance in all the phones. So what we did right now is that we can either remove those or we can replace them with PNGs. And one, of course, the obvious thing is that use opacity and transforms instead of height, width, and those kind of things, so that you avoid unnecessary layouts and paints. Just prefer compositing. So here you will see an example that this is a website, this is a web app, which is able to give a consistent 60 FPS performance on these kind of animations across devices because of these kind of optimizations. And here is some proof. All right. One last thing, one more thing that I want to touch upon is security that that Emily talked about yesterday. HTTPS is really a baseline now. We achieved the shiny green lock, as she said, and we have to tell you that it brings perceived security, which is very important in a country like India, and it also brings a very real security benefit. We implemented end-to-end HTTPS and made sure that there is no mixed content in any of our pages. This also gave us the benefit that it is future-friendly. What I mean by that is that I can think of at least 2 use cases. Like, for example, we heard yesterday that hardware APIs, because of privacy reasons, some hardware APIs might become restricted to HTTPS access only. For example, your camera or your location. We are ready for that. And the second is HTTP2. It can give us great performance benefits, and that is on the cards for us very soon. And HTTPS allows us to proceed on that without hindrance. We also heard yesterday about content security policy, which allows us to set a specific response header, which tells the browser to very specifically allow only certain types of assets to be loaded from certain types of domains. So the simplest form of a CSP is that you just give a default SRC, and that's it, it works. But for a complex website, it might be that you have a variety of different domain origins for your different kinds of content, so you can configure all of them separately. All right, so this covers a lot of the basic stuff, a lot of the modern web technologies that we're using in Flipkart Lite. But this is not the end of the story. This is just the very beginning. We are just getting started. We are deeply committed to the open web, and we would like to see this on all modern browsers, and definitely giving the same experience across all modern browsers. So currently what you see is the minimal experience. It's just the quick buy flow that the user is able to open the website, search for a product, and buy it, right? And the rest of the pages, like your accounts and your orders and things like that, which are, of course, necessary. We want to add a lot more things. We want to enable things like push notifications, which brings users back, and we can tempt them with great offers as and when needed. With this, I will hand it back to Amma.
I don't know what was harder, doing all of this in 42 days or talking about it in 30 minutes. Well, yes, like Abhinav said, we are excited about what's yet to happen in this space, and we are deeply committed to this. I would actually like to take a moment to call upon the awesome Flipkart Lite team. Guys, please. So those are the 5 engineers. He's our engineering manager and product manager. So thank you, guys.
Amazing work, 42 days. Oh, wow, well done. Phenomenal. Right, we have another coffee break, and then it's on to one of my favorite parts of the Chrome Dev Summit, the leadership panel. Now, after the coffee break, on your way back in, you can get one of those beacons, so you can start like messing with the physical web. Oh yes, it's good. I will see you back here with Jake at 4 p.m.
Two.
One, two, 1, 2.
Thank you for joining us. Please take your seats. Our program will continue in about 5 minutes. Thank you for joining us. Please take your seats. Our presentation will begin in just a few moments.
Hello again. Now, before we get started, there is an attendee survey that should have arrived in your inbox, and we would love your feedback on this Chrome Dev Summit, so please fill that in when you have a chance. So, it's Jake, he's back. Hello, mate.
Hey, how's it going?
Hi. Yeah, good, thanks.
Have you been doing okay?
I've been doing fine.
No major panics, no heart attacks, nothing?
No.
No?
There've been a few. Have a sit down. Have a sit down.
I should have a seat. Yeah, I'm going to be here for an hour, so may as well. Oh, chair didn't break. Good sign.
Okay.
Yeah. I think
Ready? Should I introduce the
I think
panelists?
I'm ready. Yeah. Introduce the panelists. Let's get started straight away.
Don't mind if I do. Greg Simon, Engineering Director. Woo! Darren Fisher, VP of Engineering. Oh, I like this. Round of applause all the way down. Grace Klober, Principal on Chrome Mobile. Rahul Roy Chowdhury, Director of Product Management. Dmitry Glazkov, Software Engineer. Alex Komorowski, Senior Product Manager. Matt McNulty, Software Engineer. And Parisa Tabriz, Security Princess. Now, wait. Now, I was like, seriously, that's your real job title, right?
Oh, here's some good planning.
That's the real job. How did you get that job title? Because self-appointed. Jake, we have work to do, buddy.
Yeah. All of a sudden, developer advocate sounds far too dull. I mean, can we invent something better now?
Yeah, I am right. Developer Avengers.
That's pretty good. Or I don't know, like Devra, the Unstoppable.
Yes.
Could be that.
The Web Platforce.
The Web Platforce. I like that. Like I can hear that. Like deploy the Web Platforce immediately.
Yes.
Darren, where's that? Can we be the Web Platforce? Can we make that decision now?
Go for it. You can call it whatever you like.
Yes. Well, there's a big announcement. Perfect. Right. Well, I'm going to get off stage.
Oh, I thought you were going to say something like, and a big welcome to the panelists.
Well, there you go. You just did it.
Thank you. Excellent. Let's get straight to it. Yeah, so you've been submitting your tough questions to these folks, and I get to hide behind those kind of spiky words and demand some clean answers. So yeah, let's get straight to it. So this first question, which has been submitted anonymously, which is always a good start. Add to home screen is pretty good, but it's not in the app launcher. It doesn't show up in battery usage or data usage stats as a separate item. You know, can we get that? Grace, do you want to start us off with that? It should be on already.
Is this working? Okay.
Yeah.
Yeah. So we're definitely aware of this, and we're working hard to try to make the Add to Home screen behave more like a native app. And there are some complications, like I think mentioned for the battery usage, that we can try to do a better job. But for like a data usage, it's Add to Home screen still run inside the browser process. So and then in Android platform, that's just a single process. We have some challenge to work on.
But the ultimate goal is to make these.
Yeah, definitely more like, I mean, in the coming year, what we try to do is make it more like a native app from the user perspective. Yeah.
So this next question is also anonymous. Is Service Worker ready?
What is the audience?
I'm gonna. Yeah. What does the audience think? I don't know. Do you think it's ready? Okay, well, moving on. Well, no, okay, so like we've had 2.2 billion page loads a day through Service Worker and 350 million push messages a day as well, and 2,300 sites using push. And yeah, okay, it's at the moment Chrome only. Well, with Opera support as well, and Firefox support. They're hoping to land that early next year. So it's on their standards track now. So yeah, I'd say it's pretty ready. But the important thing here is it's progressive enhancement. Like you know, pages aren't going to break in browsers that don't have Service Worker. And I really think that developers are in a position of power here. That if you start using Service Worker and you can make your sites have more features and run quicker with Service Worker than without it, then for other browsers that's going to show them, look, if they want to compete on the web, they need to have Service Worker as well. I reckon. Just what I think. If you want to ask questions during this event, we also have a microphone in the middle there. So if you want to ask a question live, then please do come down the aisle. It's sort of a weird kind of wedding venue, this, isn't it? Especially with all the white chairs. But if you want to ask a question, you can. I'll go on then, because since you've got up, it's sometimes difficult to find someone who's brave enough to get to the microphone, and that person is you. What is your question?
Hi, I'm Paul. First of all,
would you like a job in DevRel? Platforce, thank you, yes.
A really great conference. It's really nice to be here. I have a question because I heard a lot of web APIs and how the web works, but I haven't heard nothing about the Chrome apps and Chrome extensions and these APIs. Is it something's going to happen over there? Is it going to be available and so on?
Well, we had one question as well. It actually ties in very nicely to the next question we're going to ask, so we can sort of roll that into one, which is when is Chrome OS and Android going to merge, and how soon can we develop apps for that? So, Darren, do you want to take that one? And question
I can talk about all of these things, but so first off, to your question, it's Chrome extensions, Chrome apps. These are parts of the platform. These are parts of Chrome. They are things we are investing. When it comes to Chrome extensions, we're invested in enabling customization of the browser. You're gonna see us continue to evolve that. What we were here today and yesterday to talk about was really the things we're doing to enhance the web platform. That's a big focus of Chrome and focus on the web itself, the web ecosystem. Historically, at this summit, we've talked about the whole spectrum of things that Chrome's doing, but we really wanted to focus in on progressive web apps, the mobile web, and all the things that you guys can do to create great experiences there. When it comes to Chrome OS and Android, there was certainly some interesting press recently. I just want to reemphasize that this idea of Chrome OS being folded into Android, it doesn't really it doesn't make a lot of sense. In fact, Chrome OS is an extremely successful operating system. If you think about, in particular, where it's been so successful, because of the simplicity of the system, because of the web, really, it's been a fabulous computing platform for education, businesses, and in many homes. It's really something we started 6 years ago with this idea of bringing the simplicity of computing, speed and simplicity, security, and these core values, the things that make computing just less painful, right? To try to create a simpler computing experience that people really love. And I think we've been pretty successful here. And Chrome OS is something that we're really behind and trying to grow. And in particular, now you can totally imagine that as the teams work together, they're going to look for opportunities to leverage across Android and Chrome OS, especially under the hood and so on. But as far as how that evolves, I think the number one thing to keep in mind is that vision, the core user experience of Chrome OS, is a thing that's here to stay, and we're fully behind.
So, yeah, go for it.
Just really fast. So, if you look at all the things we're working on ChromeStatus.com, on the open web platform, you'll see a lot of the APIs, or a lot of the functionality from the Chrome OS APIs that we're working into the open web, right? I was just in the office earlier this week, and I saw one of the Chrome apps engineers with Web USB running, like blinking lights and everything else. Now, there are some security things that we need to get past on that one, but we're very focused on bringing all of this functionality to the open web.
So Chrome works great on new devices like on the Nexus range and things, but in some parts of the world, brand new devices have small screens, half a gig of RAM, and limited storage. How important is it to Chrome to ensure that Chrome works well on these resource-limited devices, and what are we doing in this area? Grace, do you want to take that one?
Sure, I will take it again. We call the low-end devices very important for us, right? So this year we spent a lot of time especially working on the memory footprint, and we achieved a 30% memory footprint reduction for our browser process. And thank you. For the render process, we're working on so that 30% is especially for the low-end devices. We're really targeting that market to try to make sure 512 devices works well. And for render process, we're actually having a cross-the-board effort. I think yesterday mentioned for the V8, they reduce the memory usage. There's like a 10% in the render process that will be benefit the low-end devices too. And we'll continue looking into what else we can reduce in the coming years.
Well, one of the questions I had via email recently is a lot of the devices they don't have a lot of on-device storage, and a lot of the storage is deferred to SD cards. Are we looking at anything to be able to move Chrome storage, or even for particular origins, move the storage onto the SD card?
So we are looking into that. For this, because SD card, IV app, if they have the permission to access the external storage, they can access. So we have to ensure user aware the particular local storage data for the origin can be accessed by the other app. And then we need to build some like a permission model before we can move the data storage to the SD card.
So this next question is for Parisa, I think, and it's quite a pointy question, but where are you hiding over there? So I'll read it directly to you, because I think that's how it's supposed to be written.
Okay.
The deprecation of APIs and features on HTTP is causing developers pain. Why are you forcing this upon developers? What are you doing to help make HTTPS easier for developers, especially on intranets?
Yeah. Well, obviously, whenever there's an opportunity for pain, I take it. No. So HTTPS is really important. Did anyone see Emily's talk yesterday? Awesome. If you didn't, yeah, it is deserving of applause. So she went over, I think, the motivation for this better than I'll be able to. But HTTPS is really important. Without it, as a user and as a developer, site owner, you can have no expectation for security, right? So for really powerful APIs, one of the APIs we deprecated recently was Get User Media. So having access to a camera, device camera, we consider very powerful, and something that really should only be done in a secure context, so that user can have some expectation that the bits they're sending to a site have not been tampered by some third party, and the developer also can have some expectation that no bits that you're sending to the user have been tampered or snooped. So we think HTTPS is really important. We're doing a lot of things to try to ease the path. Emily's talk went over things in the web platform in terms of features that we're supporting, as well as a new panel that we just added to DevTools to try to help developers who want to support HTTPS to get to green. But really, we think it's the responsibility of us to make sure that really powerful features are only accessed in a secure context.
So we've had a question in from Slack. Yeah, you can ask questions on Slack as well, and they get forwarded into this Google Doc I'm looking at. This question comes from Oliver J. Ash, who's from The Guardian, the developer who did the fallback offline crossword page, which I think is brilliant. We've seen a lot of stuff around Service Worker, these new features, push messages, but we're not seeing many Google products using these things. When are we going to start seeing Google products such as Gmail, Inbox, Google+? When are they going to start using this stuff? I'll direct that one at Alex, I reckon.
So I can't speak on behalf of any of the other Google products, I guess, but just like a lot of you all are experimenting with these technologies and seeing how they can make your things load much quicker, be much more robust to flaky networks. I think that these are things that would also make a lot of sense for a number of the Google Web properties as well. So although I can't announce anything, I think that would make sense.
So we're kind of seeing on the web a resurgence of SVG, because SVG's been around for ages. And kind of when it started, spec people or browser developers were going to web developers saying, hey, do you like Flash? And we're like, not really. Do you like XML? No way. Well, you're going to love SVG because it's basically both of those things. But we're looking at deprecating Smile, which is the animation system. And so we had a question in about that. Are we going to break all existing Smile content out there on the web by removing this from the platform? Dimitri, do you want to take that one?
Thank you for not making that question too pointy.
Why are you breaking the web?
There you go. That's more appropriate. Yeah, and the context here is that we did recently, well, not recently, but this spring, started talking about removing Smile, SVG feature that enables you animation. One of the weird things there is that the reason why we're doing this is because we actually don't see the path to interoperability, which is, this working in every browser. And so at this point, like, it's just a 2-browser feature, and no other browsers want to do this. And so we are sort of like in this really hard situation where we're like, do we carry this along, or do we remove it and make our burden a little less? And obviously this involves developer pain, and we felt it very much on the Blink Dev, which is the mailing list where all these things are announced. It's now a Senti-thread with people chiming in very regularly. Yes. And the interesting thing there is, I want to say that, first of all, some of the things that Smile does today are simply not easily possible with the web platform features. I think I want us to first get to the point where we can say with full honesty that we can complement the features of Smile with the corresponding web platform features that are on an interoperable path, and then maybe talk about deprecation or removing at this point. At this point, this Smile thread is mostly a heads up. Look, we know this is not going anywhere, so, take a look.
I guess part of the plan as well is for the animation API in JavaScript to start taking on kind of a lot of this stuff.
Yeah, web animations is actually one of the kind of interesting parts of that, and I'm going to do the "it's happening" thing. So it's actually being implemented across the board. That's really cool. Very excited about that. But there's still some pieces missing.
I mean, we're seeing, SVG was unloved for so long, but with devices of different density, especially people are starting to pick it up again. But I mean, the implementation we have still inherits a lot from WebKit, the initial implementation, and same for Safari's. Firefox's implementation is old as well. It kind of feels like it's only Internet Explorer and therefore Edge that have kind of shown the way with, you can make SVG perform really well. Are we going to step up our game there? Is that something?
Totally. We're totally stepping up our game, and we want to make SVG as performant as it can possibly be. I have to say that as a platform developer, I'm amazed that people can use this thing because it's one of the most terrible spec APIs ever, and there are some places where like you don't want to go in there because bad things will happen to you, type of alley situation. And still, it is success. And it's kind of the story of the web. The thing that wins is not necessarily the best designed one, right? And so, yeah, we want to work on this, but we also kind of want to look forward ahead to SVG2 and prod that SVG working group along a little bit and say, hey, come on, it's been 2 years, give something. And so get something going there.
So we've got another standards-based question. I'll just read it out as it's been sent in. Pointer events. Seriously, when is it happening? You've been promising it for ages now. Grace, you can have that one.
If you check the check-in log, it is happening right now as we speak, right? So it is behind the flag, and then I think I see Rick over there. Yeah, so he's leading the effort, and then there's a CR bug. I do not recall exactly bug number. If you want to know, you can find Rick after this, and you can. Yeah, I see him waving his hand. Yeah, so you can follow the bug, and he also has a Twitter feed updating the status, so you can follow him on the Twitter. And today, I believe, is soon. I think soon, behind the flag, you can try it out. And there are some technical hard things we need to figure it out, so we don't have exactly date. We're going to turn it on by default. Hope sometime soon when Rick figured it out next year.
And please be nice to him. You know, he's a really cool fellow, so just take it easy. By the way, love the way you ask the questions and read them out. You have to do this everywhere.
Well, we've had a question in from Twitter that's been pasted into this document, and I'd like to thank Paul Kinlan, who's managing this at the moment. Especially thank you for posting every question in using a different font. That's not messing with my OCD at all. This question comes in from Henry Helvetica. Could be real name, I don't know. So the way Chrome pushes forward, how did the panel feel about PPK's call to slow down? And I'm specifically not allowed to answer this question. I think that's because I've already written blog posts about it. So just a bit of background, PPK wrote this blog post saying, you know, the web platform is progressing too fast and we should stop doing it for like a year. For some reason, I'm sitting on the fence about this one.
You seem pretty
But you know, are we moving too fast on the web? Are there mistakes we're making by trying to push the web forward so fast? Or should we be moving even faster? Who wants to take that on?
Yeah, so the way that I would measure this is what is the developer adoption of the new things that we're doing? If there's a big gap there, then maybe we are moving too fast. But there are certain things like, like we got Service Worker out there really fast because, which was really fast. But this one really fit, our model of how we want to move forward, which is an extensible platform and explaining the platform. So I don't want to just throw in tons of APIs that no one will use. So always looking for that feedback, and that's why we have on Chrome Status all of the histograms and what people are using.
I think too, if they're for things like Service Worker and a bunch of these other things, we worked very closely with other browser vendors and standards committees and standards bodies. For example, with Service Worker, we worked incredibly closely and co-developed that with Mozilla and other members of the standards community. And if other browser vendors are coming to the table and having meaningful discussion, other people are implementing, developers are using, I think to me that says, no, we aren't moving too fast, and we're actually moving at a pretty good pace.
And don't forget that if you want to ask a question live here, the microphone is just there. Someone's already done it, so it's not as scary anymore, right? So if anyone's feeling brave, you can come to the front. Oh, sorry. Go on, carry on.
Point now.
Yeah. Sing a song. Don't let me stop you.
No, I was just going to say that this whole past year we've had a real focus on just the core engine and just optimizing existing code paths and prioritizing scheduling work much better, all to bring a lot of wins to the platform. A lot of the V8 improvements came from just being smarter about scheduling. And with the focus on emerging markets, there's been such a focus, such an emphasis placed on being smarter about resource loading and scheduling, all of this stuff. You have pages with lots of iframes, cross-origin iframes, making sure that the main document content is given the right priority, et cetera. There's just so much we can do when we really focus on the core engine. So I think part of the answer to the question is, it's not always just about new APIs. Sometimes there's real holes that need to be filled, and that's where something like Service Worker comes in, push notifications, et cetera. But a big part of this is just like making sure the engine works well and that you as developers have a lot of control. The engine shouldn't feel like a big mysterious black box, right? You should feel like you have a lot of control. Dev tools to help you understand it, et cetera. So there's just a lot of work going into the core platform. And I think that stuff really pays off.
I want to riff on that a little. And actually, PPK's post, I had a little milder response to it than maybe Jake. And basically, my question, my thing was that if I were to summarize it, I would say the question he's asking is, to what end? Why are you doing this, right? And I think this is what Greg said, is that you have to in order to deliver things that are valuable, you had to get really good to listen to developers, at listening to developers, understanding what they want, and building something that the question is, are you moving too fast? Has such an obvious answer, right? Because it's like, yes, because the developers need it, and it's really obvious to me that this is necessary, and that's the next step. And I think that's what we've been doing, and I think Darren underlined the quality and excellence of the product, focus that we're trying to do in balancing that. I'm really optimistic about 2016. We are not moving too fast. We are more focused and better than ever. Yay, web.
Well, I had an angry response to it, like you say, but I tried to channel that anger. So if anyone's interested in hearing that on the latest episode of the HTTP 203 podcast, I wrote a 5-minute poem about how disgusted I was about this idea that we should stop on the web. So that's something you might want to check out. Yeah, exactly. May as well. I've got a room full of people on a live stream. I'm going to plug my podcast. Do you want to ask a question?
Yeah, hi, I'm not Paul. So when there's so many visions and directions for the future of the platform, how do you unify and prioritize all these ideas?
So it's a good question. Let me take a stab at it. I think it's very important for us as a team to pick the battles we want to fight, to pick the problems we want to solve. And so for example, for this year, you've heard some of the themes in this conference. Performance is a big issue on the mobile web. We want to really invest and make appreciable progress on it. Emerging markets and serving the next billion users who come online is a big focus. And so really what we look at is we sort of look at what's happening out there, look at what users are doing, look at future trends, and then make a very deliberate choice about where to focus our efforts and then align behind that. And then, there's definitely a lot of ideas that come up midstream and you try and incorporate those in, but the idea is not to be spread too thin, so you don't want to make 10% progress on a variety of fronts. You want to just nail a few things really well.
I would emphasize too that this web platform, it's an ecosystem, it's a community. That's why all the work we do on Blink is fully in the open. That's why Blink Dev encourages folks to come in and share their perspectives, their feedback on proposals people float there. We had our Blink On Contributor Conference last week. We had a whole bunch of folks there from other browser vendors as well. And so it's ultimately by talking to developers, it's by observing places where there's obvious gaps that we're hearing again and again from folks that they need. But it's ultimately a collaborative process because we're kind of all in this together in a way. Right?
I'd just add one extra thing to that because I think it's challenging, like having to prioritize all these different things you want to do. And one thing that's really helpful is Chrome has sort of these guiding principles of simplicity and security. And anytime we find ourselves maybe like excited about one idea and getting away from those core principles, it's very helpful to kind of refocus and sometimes prioritize.
So, moving on to Polymer, does Polymer support progressive web apps? There seems to be a big emphasis on server-side templating and rendering when it comes to this stuff. Is that something that Polymer supports? Matt,
yes, so it does. I mean, if you watched Rob's talk yesterday about that, it was building a progressive app in Polymer. So you should probably pay attention next time.
Good quick answer, fair enough.
But no, actually, I can elaborate a little bit more on that. So I think, if you look at Paul Lewis's recent blog post about performance on frameworks and how they impact things like Rail, Polymer came out really well in that comparison. It's relatively small, it's relatively fast. I think there's some things we can do to make that faster and get first paint quicker, and we're working on that right now. But we're already in pretty good shape. And I think, when you start to see things like server-side rendering, a lot of the reason for that is because, in certain circumstances, other frameworks have much bigger payloads and much more JavaScript that they're passing down, and you have to do something different on first paint as opposed to later paints. And our goal is to, for Polymer to be really, really fast, have a really fast first paint, and still with idiomatic usage without having to resort to tricks like that.
But is there, you've got the paper elements that doing a lot of the UI work. Are they going to support async? Because that seems to be one of the things that you really need to get this kind of first render down.
Yep, absolutely. That's some of the stuff we're working on right now.
So we've got a question from Slack, from Simeon. So one of the big warts of the current progressive web app story is that we don't have a good way of handling mixed content or cores. And I think what we mean by handling here is a native app can download podcasts, RSS feeds from anywhere on the web. It doesn't have to be cores compatible. And if you're wanting to build something like a podcast app, you can't really do that on the web at the moment without building your own proxy to send everything through, to not lose the padlock, or to add cores headers on. And some of these, in the case of a podcast app, some of the files are going to be huge in doing that. Do we have any ideas on how to address this gap? Parisa, if this is mixed content, do you want to take a stab at this one?
I don't have any great ideas, but it's a real problem, and something we should think about more. I don't have any great ideas for it. I think it's a legitimate situation.
One of the requests we get quite a lot is to say, like, why can't we just make a request to anywhere in the web and get the content? Because if we don't put cookies on it, then it's not leaking any data. But the situation we have there is we don't want the web to be able to access things like your local servers. I mean, if an evil page could just do a port scan on localhost and look for sites that are there, I mean, that's basically where you'll be running prototype servers, new stuff that you don't want leaked onto the web. And same goes for intranets as well. So I guess with that question, I don't have any good ideas. Anyone have a good idea?
I have a larger thought about the importance of the security for the web. We talked a lot yesterday about the importance of the low friction on the web that makes it so easy for users to tap on a link and experience something new. That's so important for that really healthy reach that the web has. And one of the reasons that is true is because of security, because users don't have to be afraid what's going to happen when they tap a link. And so sometimes that means we get things where it's like, we could have done this better if we would have shipped a whole native app. Well, yeah, of course, the security model is different. But that's one of the things that enables this superpower of the web. So that's one of the ways I think of it.
So we see it as a bug that native allows this sort of stuff to happen.
I wouldn't call it a bug. I'm just saying that it's a different trade-off in terms of reach.
Do you want to ask a question on the mic?
Hi, my name is Adam. I have a question about the push notifications. So right now, when the user decides to accept push notifications, the token is bound to a single device. And do you have some plans to synchronize it across all the browsers, or when the user buys a new phone, that they don't have to sign up for the same notifications as before?
So we've definitely talked about those kinds of use cases and tried to reason how to do that in a way that makes sense to users and that helps them accomplish the things they want to do. One thing to remember too is that when a user chooses to enable notifications, it's often very tied to a specific device or context. So I might turn on breaking news alerts on my desktop computer because I'm always looking for something to distract me during the workday. But I don't want to do it on my phone necessarily. And so you have to think very carefully about the different user contexts that you'd want to show it, and not to say nothing of the security implications and privacy implications of that. We definitely talked about it and are open, trying to figure out the best way to do that or approach that problem.
You could imagine a variety of approaches, with Chrome synchronizing data already between different Chrome instances and so on. And like Alex said, I think this is something we've talked about, but in the initial cut, we want to keep it simple and focus on the single device case.
Okay, thank you very much.
So we had one question in from Slack. Why does Jake not wear shoes? Answer is simple: you shoes, you lose. Is V8 actually paying attention to the use ASM flag, or because it used to be we were saying we're going to make just all patterns fast. So have we changed our stance on that? Greg, do you want to take that?
Sure, I can take that. So V8 over the past year, actually more than a year, has been working on a brand new compiler that's called Turbofan. This is to replace the old one, which is called Crankshaft. Anyway, so Turbofan is a type-aware compiler, fully type-aware, which means that in the limit, it won't need to look at the useasm key at all. It will just be able to infer the types and then map it internally. However, they are using the useasm as a trigger to test Turbofan as it rolls out, and then once they have deprecated Crankshaft, then they won't look at it anymore.
So push notifications for apps that have been added to home screen, when you launch a window from a push event, they don't launch in a full screen window. Why is that? And is it something that we can change? Because it means you go from this nice native-like experience to something which all of a sudden looks very browser-based. Is there something we can do to fix that? Grace, you want to take this on?
I think that's a good suggestion. So currently, you can targeting basically targeting the existing already open window. So if the at home screen currently is one of the window is open in the background, you can still target it. So I think we should try to make sure because at home screen we wanted to work more like a native app. So I think it's making sense for us to be able to target it by the push notification, even when it's not running. So.
I mean, from a standards point of view, this is something we've been looking at as well. I mean, it's just kind of been ideas that have been thrown around the room so far, but we've been thinking about something like a launch event in a service worker that will be fired if there's been a kind of launch of a website done in an ambiguous way, and that will include things like clicking a home screen icon, clicking a link in the native app, and that will let you decide how to handle that. Should it be launched from the home screen? Should it create a new full screen window? So the hope is to let you create single window apps or multi-window apps using this. And by ambiguous, I mean like if someone long presses and says open in a new tab, that's not ambiguous. We don't want you to be able to disrupt that, but we want you to have control when the launch is ambiguous. Right, okay, we've got another question from Slack. Asking for clarification on the ASM bit. Does Chrome do ahead of time compilation like Firefox and Edge for use ASM?
I'm not sure about for use ASM, but there is snapshotting going on now. But I'm not familiar with the latest on what triggers it.
I think it's async or defer on the script tag will do that. I think so. I think we do it for work as well. So I think we're all very excited about Let's Encrypt, but Google isn't on the sponsorship list for it. Is it something we endorse? Is it something we'll be telling developers to use? Do we give it the thumbs up? Is it something we plan to sponsor?
I cannot say anything specific about that today, but it's a project that we're really excited about and interested in, and that's all I can say today, right now, Mr. Chair. So.
News to come on that.
We're pretty. I said I'm excited, but we're really excited. We're pretty excited. we're pretty excited, and yeah, I think it's. How excited are you? Pretty damn excited.
You see, if you put a big number to that, you'd have got a round of applause.
Lots of zeros at the end.
Yeah.
Stay tuned.
So we've had a message come in from Seth Thompson, who was speaking earlier, PM of V8, saying, yes, we do have real ahead-of-time compilation is coming for ASM.js. We didn't do it previously, but if you can check that out on chromestatus.com for news of that. This one's written in another different font. Guys, you're winding me up. The name of what?
Arial.
Oh, let's check it out. This is Alpha Slab. So this question's written in Alpha Slab. How will ES 2015 modules affect how we look at web components? So that's one for Dimitri.
So the web components is a loose congregation of specs, right? And it's been evolving over time. It's evolved quite a bit this year. As modules get ready to be shipped on the web, I think there's a lot of interesting possibilities that open up for custom elements and imports. And I'm really excited about trying to figure out how this stuff fits together. And especially with imports, I sort of want to, I've been trying to pitch the idea that we should try to look at the loading mechanism that hasn't yet been fully spec'd out for ES6 modules for browsers, and then maybe see if we can rebuild the imports on top of that and make something amazing happen there, because the features that modules offer are quite tantalizing. For the whole scoping thing is amazing, and the whole export stuff sounds really good. So let's go figure it out. Follow public web apps. No, don't go there. But yeah, there is a GitHub for W3C web components. It's a pretty active discussion, so lots of interesting conversations there.
Oh, would you look at the state of that? This is horrible. It's like reading a kind of, it's like a ransom note. It's starting to look like. Okay, so we have
I watched you changing that around, though. I think
there's a kind of fight
going
on. I'm
here,
trying to change it. Oh, we've got Comic Sans going on now. Thank you very much. Excellent. So yes, this question is written in Comic Sans. TC39 has discussed the possibility of adding types in future versions of the language. Is Turbofans type support ready to support this possible feature?
Yeah, there's definite interest from us in working on this? I mean, we are working on it. I mean, was there anything else beyond that? Or?
It was just, is Turbofan got some kind of type support in there, or is
yeah,
it
it's fully type aware, so it's actually it's like perfect fit for it. So yeah.
So it's another one this is from Unfunk on Slack.
Jake.
Oh.
Can I?
Oh, sorry. Constantly staring too much at the, trying to decode the fonts that are going on here. Sorry.
Yeah, I gotcha.
What font is your question going to be in?
I think I'll pick the Helvetica, of course. Okay, my question is, I'm Johan. So I'm building games using HTML5, and the problem for me is actually how we can hide if I want to post the score. For example, I built a Temple Run and I got the score of the player. I want to post it to the server, but the problem that I always face is people can just open the DevTools and then just throwing the same request to the server from the JavaScript console, and then they can manipulate the scores. So,
well, I mean, surely this must be something, the same problem that native games face, right? Because the code, you can always just put a listener on the wire, something like Wireshark, and see the request being sent and find out where the score bit is. So is that the answer? Or is it?
Or is like much lower, right? I mean, sure, you can also decompile Java.
Yeah.
Sorry.
I mean, using the native is you need another tools, right?
Can you add like a digital signature to the score and then check that on the server too before? And if it's errors, you're like, well, someone's causing some kind of, doing some kind of manipulation on it.
One idea also
like a Mac, adding a Mac to it.
One idea also come to my mind is it possible using a WebSocket, using WebSocket to connect between, so it's not like using the post request.
I think you probably still want to add some way to authenticate the actual score. So adding a signature for it would I think help with that, because they could still tamper with it in your client, in your game.
Okay, cool. Thank you.
So we got a question from Unfunk on Slack. What's the best way for developers to provide feedback and make feature requests, not just to Chrome, but also other browser vendors and standards bodies as well? Anyone want to be brave on that one? Standards bodies?
So I think this is a good question. I don't know if there is an easy way to go and I would like to propose a feature, because there is definitely W3C, which is not the easiest working group or group of people to work with. But I think did somebody make a face? But I think there is definitely more and more opportunities for developers. I'm going to tout ours, which seems to have worked really well, and this is just Blink Dev. I think there's a lot of developers listening there, and sometimes just putting an idea out is a good start. And I think as a community of browsers, we do need to get better at engaging developers collectively rather than separately. So I'm going to make a pointed look at Darren and Rahul there. And because, this is a Chrome Dev Summit, but there's people from Microsoft here, from Mozilla. It's a great opportunity, and you're all here, right? So it's a great opportunity, and we need to get better at this.
Yeah, there's also the YCG, the Web Platform Incubation Group. That's a great place to propose new things or sort of take problems to. And that's something we at Google use ourselves. The background sync specification is part of that movement. So what I would always advise, if you're thinking about a new platform feature, try not to think about solving just the one problem you have, but what are the parts of that problem, and can we create them all, and so those could be used in different ways to solve other problems as well.
Because designing a new web platform API is really, really challenging. There's all kinds of security considerations, other APIs in the platform that you have to fit within, other semantics that aren't immediately obvious. It does require a fair bit of effort to drive into it. However, you'd be surprised the number of times that browser developers and on standards lists, people were making arguments in complete vacuum. And there's developers who actually have very concrete use cases. They've got numbers or examples in the wild that would really help for those conversations. So I think looking for places to give that concrete feedback really helps the process.
So, and this is actually an issue that's been bugging me recently. When pages are launched from the home screen and full screen, you lose, or the user loses access to the URL bar, which obviously impacts the being able to share that page or that app. It feels like we're kind of losing one of the core features of the web. Do we have any ideas, any solutions for this? Alex, do you want to take this again?
Yeah, let's see. So Flipkart just had a session where they talked about how they put different navigation controls inside the experience once it's added to the home screen, and that is something important that you have to reason about. Like for example, I remember when we had I/O this past I/O, we had this awesome I/O web app that when it was on full screen, people would be looking at details on a session and be like, how do I share this? Because I know it's got a URL that makes sense. I can share it with people, but I don't know how to do it. And we all were like, oh, that's a really good point. How do you do that? And so it's important when you're reasoning through this to think about those kinds of affordances. We're also trying to look into how best to support that. So actually, Paul Kinlan's got a great post on his site that explains a way of doing this, of triggering a native share intent. But it's something that you do have to reason about if you're hiding this browser UI that we've just taken for granted.
Do you want to ask a question?
This one's a little silly, so I'll make it quick. I was wondering if you guys knew of any benchmark that would work really well in my Nexus 6P where I could beat an iPhone 6S. I mean, just anything, any place I could go where I can compete with my friend, not Paul.
You can already use your 6P to beat an iPhone, just actually physically beat it on the screen.
That's about all I can do.
And then your friend's iPhone will run a lot slower. Yeah.
How about loadflipkart.com?
What was that?
Loadflipkart.com.
Load?
The best benchmark is something that affects users, not in a vacuum.
Will I win though? Have you tried that one out? Because if he's going to see this, and if I lose at this one too, it's really going to be embarrassing.
So an app that I built, I can plug loads of things. It's great. SVG OMG, which is a kind of SVG optimization thing. Once the service worker's there, you revisit that, and that loads in 100 milliseconds flat. And that's using Service Worker. So on devices that don't have Service Worker, especially if you're on something like 3G, which has like 1.7 seconds worth of connection setup, that's what it's going to be on an iPhone. So find somewhere with 3G or 4G and set especially the second load or from a home screen launch of SVG OMG on both.
So
you will win by almost 2 seconds. Sorry.
So I really got to game it to win.
So I think what to layer into what Greg was saying is benchmarks are really finicky, depending on the precise characteristics of the device and what kinds of, just lots of different things.
Well, that's why I want one where I can win.
But that's why I think that Rail is an interesting way of looking at it. What ultimately matters is the user experience and performance, and that allows things like service workers and other things to have a really important impact on it.
Yeah, and I wouldn't say loading using caches and things and service work. I don't think that's gaming it. I think that is what we want the future of the web to do. We want when users go back to something they're used to, that it appears instantly and they see content that, or maybe even in future content that they haven't even seen yet using sort of background sync and things. And yeah, this is stuff that Chrome is way
So
ahead
Google's given us slower devices so that we can be better developers. Is that the gist?
Is it? Is it slower? It's definitely slower.
It's definitely slower. I mean, just raw JavaScript performance, it's a lot slower.
Well, it's Android Dev Summit, isn't it? Soon is that next week? You can take that one to the. We got a question from Slack from Tim Kadlec. Data Saver is awesome and necessary, but it's understandably bypassed on HTTPS, making it conflict with the security everywhere goal. Both are super important, but what's being done to balance security with the fact that many people need to use these proxy services for speedy access? Parisa, do you want to take this one on?
You did say the word security. This is about Data Saver.
This is Data Saver. It doesn't work over HTTPS, understandably. Should it? Or is it something that's going to die out as we push HTTPS across the web?
Is data that's a hard question. We have a long ways to go for all of the web to have full HTTPS adoption. So it would be nice if I could blink and say that that's going to be a problem we immediately need to fix today. And my kind of hope is that actually the needs for Data Saver are going to, at the same time, go away. And you look like you have something on your tongue.
No, go for it. Finish.
And so I'm hoping that HTTPS is going to get faster, networks are going to get better, our performance on bad networks is going to get better, and the need for data saver will at some point not be there anymore. So we're thoughtful to this. I think we are really, I care about HTTPS. I also care about people being able to use the web in networks where I recognize that it's not a experience and it actually impacts things. So I think we're exploring how to make this better.
The real promise of HTTPS is the endpoint security, and so we really are being thoughtful about that.
Yeah. Also note that data saver currently is implemented as a proxy service, right? Which is why all these thorny questions come up. You could imagine that the same transforms could be applied at the origin server. Tal mentioned briefly PageSpeed, which does some of this work. So you can imagine other ways to solve this data compression problem without running into a proxy service dealing with HTTPS traffic.
And in addition, just designing the web application to be smarter about how it uses the network. Flipkart's the great example here, right? Leveraging Service Worker, being smart about the initial payloads, being smart about bringing down content only when needed, and in the background caching it, and so on. All of those things really can pay off here to the point where, as Parisa said, a feature like Data Saver isn't really needed. And so Data Saver is really there as a tool to help users access the web that as it exists today. But as developers, we can all change the web. We can evolve it. We can make it better. We can make it so that things like HTTPS work great.
Yeah, and I think to maybe one, I don't know if this was implied by the question, but why not just have Data Saver support HTTPS? And that's a challenge as well too, because as Rahul said, it's a proxy, and there's SSL offers that end-to-end connection, and we as Google don't want to interfere with that. It's
Train, House, River, Skull and Crossbones. That question was written in Windings. Thank you very much to the people operating that document. We have a question on the mic.
Can you speak to us specifically about service worker and security for, say, like a banking application or retail as well? Is it just tell the security folks it's HTTPS and we can just be okay with that, or?
Well, if your bank website is not HTTPS, then leave that bank. Would be my first advice.
I don't work for a bank.
What security issues are you concerned about with this?
I work for Target, and they had security issues. I think everybody knows about that. But so in order to utilize this, which we're planning on, what do we give to the security folks? Because they've never heard of it before. So they're going to have questions about it. And in large corporations like that, it can take months and months for those people to catch up to these things. Could there be like a white paper that says, here's what you need to know right now?
Yeah. It's a great idea.
Yeah, we should do that.
Yes, I'm looking at Alex Russell. He's like writing the white paper up as we type, but he's the service worker security person. Yes, it'll be done probably by the end. I mean, we got 9 minutes.
I'll meet you at the front door. So.
Yeah.
We have another service worker question here. Exciting possibilities with service worker, but is an empty app shell a sensible starting point to progressively enhance from? Is there a strategy to better avoid serving a page without content until JavaScript successfully intervenes? That's from Phil Hawksworth. Thank you. He used to be my boss. You could have asked a kinder question. Does anyone want to take that? I mean, I could take that. I'll take that. Serving the app shell, I mean, currently using the app shell approach, you're going to get a result much quicker than you would by going to the network, even with server rendering. And we've proved that out. One website you can look at is if you search for offline Wikipedia as a demo I built, and you can sort of set different flags to server render or not server render or use a service worker. And you can put those results through web page test yourself and see what the effects are. But one thing that I'm excited about, and this will start landing early next year, is streams arriving within the service worker. These are streams that you can construct yourself. And the technique that I'm really looking forward to using is where you would serve the header of the page, including like a kind of first render toolbar and things, serve that from the cache, and then start streaming content from the network. And if that stream takes a while, you can start serving a different stream. So in that model, your service worker becomes the server, and you are serving one response with HTML in it. And I think that's a really interesting pattern. That's something that Wikipedia have expressed interest in because it matches much closer what they do on the server, and they can start sharing code between the server and the service worker. You have a question? You want to?
So most web technologies that we've worked with have the ability to do some degree of progressive enhancement, but Service Worker is very much your browser does it or it doesn't. How would you suggest building an application that needs to support browsers that don't have Service Worker without just writing the application twice?
Yeah, do you want me to do it again? Oh, I'm going to just be...
I mean, I'll just add a bit here. Actually, I feel like Service Worker was designed to be very complementary. Like, you can take an existing web application and add on a Service Worker that's going to be able to intercept the network requests that your page makes. You're not having to rejigger your page dramatically to start benefiting from Service Worker. Of course, you can go even further, but like compare that to sort of other techniques like using App Cache, where you really did have to be redesigning the way your page worked. Or if you were trying to use local storage to serve your resources and XML HTTP requests to fetch them, there you're very much redesigning your page for that technology, that sort of serving architecture. But here you can take an ordinary web page with URLs and start to capture them into caches and so on.
I guess I'm talking less about the case where you're just using Service Worker as a caching acceleration mechanism for resource requests, and more, the additional features or additional logic that may get pushed into Service Worker. I mean, push notifications already use that. Other things will start using that.
I think that's a good point, and you can imagine that you might want to, build a framework that allows you to take some of the code that would, to modularize, so the code that you want to have in the Service Worker could also run in the main document when you don't have the Service Worker as a context, But some of that's probably things. I mean, these patterns are things for us to figure out. I think for us as a community to figure out.
Yeah, all of the examples that we saw over the last 2 days using Service Worker, they work on browsers that don't have Service Worker. They just work better on browsers that do.
Yeah, one of the best examples that I've seen of this is at Google I/O 2014, the talk that you and Alex gave with the Game of Thrones, I think. No,
yes,
was it Harry Potter? I don't remember. It was one of those things. Anyway. You guys started out with
big difference there, Greg.
No, sorry, I don't know either of them, but
fool of a chook.
Yeah, that's true. Anyway,
I'm so embarrassed for you.
So, where you guys you guys started out with a non-Service Worker site, and then in the course of over 20 minutes, you converted it into offline, cacheable, and everything. And it was really, really magical to see, actually. So you can go back and stream that off of YouTube.
I mean, it is possible to create a site that depends on Service Worker, but we made it, so you have to jump through hoops in order to do it. Like, you would load, the thing you served from your server would be a loading page, and then you set up the caches in the Service Worker, and then once they're ready, you refresh the page, and then it can intercept it and serve something different. But it's, we've made that deliberately difficult. And if you can do that if you want to, but I will hunt you down, because I don't think that's the right way to build websites. We have another question on the microphone.
Yeah, this time about Service Workers. So how's Service Workers caching the app shell and serving the content via API have to do with SEO? How it's gonna work with SEO? Is the search engine will see the content in this case? How's about the app visibility?
I think it's a very similar answer to before. If you're using Service Worker as an enhancement, the user lands on the page and there's you're serving content, and then on the next load of the Service Worker you can do things with the caches. There, in terms of how Google's web search sees your site, it's exactly the same, and there's no SEO impact. Yeah, if you start making things depend on Service Worker, at the moment you will impact SEO. If we see a lot of people doing that, then we'll look at ways of fixing that. But there's nothing in there at the moment.
Okay, so basically it's all about progressive enhancement.
Absolutely, yeah. Service Worker was built with progressive enhancement in mind from the start.
Remember, the first load of the site that supports Service Worker doesn't use Service Worker, right?
Right.
So there's going to be a breakout session on Service Worker after the event. And I still have a little bit of energy left, so I could probably do a Q&A on that. So I'll kind of.
Why don't we take another Service Worker question?
Yeah, you guys are getting off lightly with this. When will Add to Home Screen be on desktop? Is a question we've had, because it's really annoying that mobile is pushing forwards here and the desktop is being left behind. Rahul, do you want to take that one on?
Sure, I can take a stab at it. we are looking at it. We are experimenting. We're, on desktop, I think, which is different from mobile in the sense that on mobile, a common user pattern is going to the home screen, launching an icon, and so bringing that to the web, I think, was a reasonable thing to do because you're in the user flow. On desktop, it's a bit more of a mixed bag. There's much more sort of established patterns of behavior. We need to be thoughtful about how we want users to change that behavior. And so we're looking at it, and we'll figure out. We'll try some things out, and we'll see how they work, and then make progress there.
I mean, since the beginning of time, since the beginning of Chrome has had a create application shortcut feature, which is essentially add to home screen. It's just not something that we are promoting in the same way that we were promoting it on mobile, where you see the banner show up and so on. But it's, as Rahul says, something we're looking into.
So I'm aware that I keep saying guys when I'm referring to groups of people, so I apologize for that. I'm going to blame being in America, because I don't do that back home, right? I always say folks. So something has gone very wrong in my brain, so I apologize for that. Another question. Angular is the largest front-end framework currently. Why does the Chrome dev team not include them more in demos? You would increase your target reach audience by several orders of magnitude.
Matt should probably take that, right?
Yeah. Yeah, exactly. I've got 1 minute and 18 seconds to do this one. So I've been doing this for a really long time. I've been in the web UI world for a really long time. So you see a lot of patterns emerge. So there's always about every 2 or 3 years, 1 or 2 years, there's a new hot thing that everyone sort of gets excited about. So right now it's actually probably React more than Angular. I'd say Angular is probably the last one a couple of years ago. And honestly, from the web developer's perspective, this is great. These are all great choices. The fact that you actually have a choice on the web as opposed to native is a really, really good thing. And you can find a framework that actually really suits you, and that's really awesome. And I'd much rather someone build an app in Angular than build a native app, frankly. I really want the web to win. And from the perspective of framework developers, because I was one previously, the web platform is this thing that doesn't really do what you want and that you can never change. So they build all these big abstractions and bring their own platform and bring their own programming model to the table. And it ends up being kind of an interesting thing. And it ends up being really successful, right? And part of our job in Chrome is to make those things run really, really fast. But Polymer is pretty different than that. And when we first showed up to work on Polymer, before it was known as Polymer, Darren and Dimitri sat us down and said, okay, here is these new primitives, web components. You have to make something out of this. It has to be idiomatic. You have to use the platform in the most idiomatic way, and it has to be really, really thin. And if something's broken, you have to tell us so we can fix it. So that sort of framework assumption was incorrect for us. We were actually allowed to change the platform. We were part of the platform. And so what happened is Polymer ended up being very different, right? We use DOM as the framework. We don't build a whole big framework. Apps built in Polymer don't have a really big JS payload. And they're really, really fast as a result, and we can innovate on them on a native level. So in the end up, Polymer was ending up just kind of an extension of the native platform, okay? And it was and we're physically part of the team as well. So I think it ends up, that's why Polymer is different. That's why we're part of the web platform. That's why you see us here. That's why you see us at I/O. And that's why we're focused on it.
And that is all we have time for. So thank you very much to the panel. Greg Simon, Darren Fisher, Grace Klober, Rahul Roy Chowdhury. Oh, God, I'm so sorry. And some other people. Dmitry Glaskov, Alex Komorowski, Matt McNulty, and Prisa Tabriz. A big hand for these folks. Thank you very much. You are released. You may go. Come on, Paul, get up here. Where's Paul hiding? Oh, here we go. Got to have the blue mic. Consistency.
I have to go around the... No.
How are you going to get past it? Disaster.
Panic. Right, it's fine. I'll come around the front. There we go.
How are you feeling? How's it going?
But I'm really happy. Oh.
Yeah, me too. I've really enjoyed it. It's been pretty good.
It's been fantastic. And thank you to all of you for that particularly. Right, but we are not quite done yet. We actually have some final breakout sessions for you.
Yes, we have experimental frameworks, how to experiment at scale on the web, and that's going to be back of the room on the left. We also have Service Worker, if I've got any energy left. But yeah, bring all the Q&As to that. That will be front of stage left. What is front of stage left?
Yeah, front
That's
of stage left. You follow the words, they'll tell you where it goes.
Hang on, is it our left or is it?
No, we get to choose. But
Okay,
since you
fair
pointed
enough.
over there, it's now front of stage right.
That's true. Yep, that makes sense.
But that's fine.
What else have we got?
We can work with it. Rail. Does Rail apply to you? If not, why not? We'd love to hear from you. That's front of stage that way.
Excellent.
And one on page speed as well. Final one there. Service that can speed up your site with a simple plugin. Back of the room, near the door. There we go. I'm falling over my words as well. Hooray!
That's good. Yeah, that's it. We're out of energy completely.
We're out of words.
Well, hopefully, apart from us stumbling over our words, it's been clear from the sessions over the past 2 days that we want a fast, featureful, and safe web for everyone.
And the buzzword for the conference has clearly been?
Service Worker.
No, it is not. Progressive, I think. We're growing the capabilities of the web, adding things like push messaging, background sync, the physical web.
But we aren't doing this at the expense of what makes the web great. Things like reach, security, privacy, low barrier to entry.
Yeah, we don't want things that show a white screen for 10 seconds, and then drops you like 10 permission prompts at the same time. We play to the web strengths, get a first render down under a second according to Rail.
And then once you've got that, you can start progressively bringing in all of the more advanced features, things like Polymer, Service Worker, add to home screen.
Right, it's not an all or nothing, and you can make amazing experiences. I think Flipkart really did show that, and then progressively give them the superpowers that users want, and we're ready to give, I think. So
yeah, asking for all the permissions at the correct time.
Yes.
With your help, really, we want to make the web a first-class platform on every device. Okay, and with that, we were starting to come to a close, and we have some people to thank for Chrome Dev Summit. We're not going to do individual applause because that's kind of boring. It takes forever. Instead, put all of your effort into one big rolling applause for catering.
Yep.
They put on the lunch, snacks, birthdays. The AV team, the DevRel ecosystem, keeping the live stream going.
Laura Brewer, who've been live captioning the whole event.
Well, live captions. The speakers, they spoke some words, and they were pretty good, right?
The Web Platforce.
Web Platforce.
DevRel, along with the organising committee and ATP, have done a huge job, and us two have had very little to do with it, frankly. We just got thrown on stage, but there you go. That's a huge task behind the scenes. They're giving up. Quick, keep clapping. Don't stop. Yes!
A second window. Everyone involved in this made it look easy, and making it look easy is very, very hard.
And mainly thanks to all of you and everyone on the live stream, and I guess we will catch you fairly soon.
So hope to see you next year.
Bye.
Bye-bye.